Good morning, Berlin. People of internet land all over the world, good morning to you as well. And I apologize to internet land because we're in a beer garden. Right? Come on, like how can it be, not everything is gonna go fine because we're starting a beer garden, which by the way, every time I come to Germany, that's the first place people take me is a beer garden, which is wonderful. This is my second time to Berlin. Really excited. By the way, I'm David Price from Redwood. Don't worry about me. You have some wonderful speakers and presentations today, but David is fine. Last time I came to Berlin, we showed up, friend took us to the beer garden, and there was no place to sleep in town. I'm gonna date myself a little bit here. Like all the hotels were booked. We ended up having to stay like 30, 45-minute train ride out of town because we found out this thing was going on called the Love Parade. It's a little while ago, so fresh out of college doing the backpack thing, and I had no idea what was going on. So anyway, I spent a good day or so at the Love Parade in Berlin. And yeah, I just want to say this is a little different so far. This crowd feels a little different than the Love Parade, but we've got an after party later. And we've got a beer garden, so we'll see how things go today. But welcome. I need to do the obligatory duty of telling you things to expect today. One of them is, did you notice they printed things on the back of the card? Like brilliant. So you have a schedule of everything happening today. The main thing you need to know is that there's gonna be a coffee break up next. Oh, and speaking of coffee, and I'll remind you of this, but over there, again, sorry internet land, but people here joined us for Prisma Day. Open bar, food all day long, German hospitality at its best. Thank you, Prisma. So I'll remind you of that occasionally as we go. But you've got the schedule and agenda on the back. And another thing, see the green thing? Have you ever been in an Uber and you didn't want to talk to the driver or a taxi? And they wanted to talk to you, and you're like, I'm gonna get some stuff done. I got 20 minutes to ride, and no, you have a conversation instead about, I don't know, politics, right? So anyway, feel free to pick up some stickers that we have today. Green, I forget is it yellow and red? And red means I'm in the Uber and I don't want to talk, I want to get some work done today. And green means I would love to talk with you about whatever you have to do. So I see a little bit of both, but please, respect those and feel free, whatever you need today. We want you to enjoy the conference as much as possible, so feel free to, hey, you be you, grab your sticker. Second thing, I'm trying to go through, there's a photographer here today. Remind me your name? Helena, who's amazing, and I was told some of you might have new profile shots by the end of the day, so if any of you are into the social medias, you want to talk to Helena. But also, if you don't want to be into the social medias or on Prisma Media, make sure that you tell one of the Prisma crew here or Helena, and she'll make sure that you're not in any of those photos. Or you could book her for later. So I hear it's great. And also, we have a photo booth that's somewhere around here. So that'd be another thing if you don't want Helena, which I suggest you do. There's a photo booth. I don't know where. Has anyone done the photo booth thing yet? All right, I'm in. Let's do that later today. It's over that. Oh, I see it. It's over that way. It's near the bar. So that. Smart, super smart. All right, I gotta look at my handy list. There's a few other things. We got food. By the way, there's an open bar that was on my list. You got the Wi-Fi conference set. Man, we're great. All right. So, you guys haven't heard of me before. Why am I here and doing this? It's my pleasure to, in 1 minute or less, just tell you a story of relationship and collaboration and getting to know Prisma. The real reason I'm here is because of collaboration and because of relationship and getting to work with an amazing team of people. I mentioned I'm from Redwood.js. It's an open source full stack framework for building apps. And 4 years ago now, 2019, two of the co-founders of Redwood, even before I kind of come on board, were in an office space. I directionally have no idea where I am right now. So that way, right? I can just point, right? In an office with Johannes, one of the co-founders of Prisma. This was Peter and Tom, and they were talking about how to build a full stack framework that would deploy serverlessly, what kind of ORM or query builder, for those of you who remember Prisma history, query builder they might need, and started collaboration with Redwood.js being in pre-alpha, with Prisma, at that time version 2 being in pre-alpha. And we spent over a year and a half at that time working together in Slack with Alberto, Hervé, Jan, Nico, wonderful team. I don't know who was all there at the beginning. And we just got to know all these people collaborating together. And Prisma's been in production now for over a year. We've seen countless startups and tens of thousands of apps deployed with Prisma. And it's a wonderful tool. But the history of Prisma that I love the best is a history of working with people and enjoying collaboration, being in the context of open source. And if anything, I can demonstrate to you just the relationships and the enjoyment of being able to participate in collaboration with a team like Prisma. I hope you see that today. So that's why I'm here, and that's really what I wanted to tell you, is that Prisma is a wonderful tool, but the people behind Prisma and getting to collaborate with them has been amazing. So with that, someone else from Prisma I'd like to welcome up is Soren, the CEO and the co-founder of Prisma. Where is he? We're going to our first speaker of the day. Please welcome Soren. And this was it. I just want to say publicly to you, your team is amazing, and it's just been a pleasure to work with you all. And Redwood would not be the same without Prisma. So thank you all. It's really been a pleasure.
Likewise.
All right. Thank you. Kick it off for us, Soren.
Thank you, David. Thank you for that warm introduction. Welcome, everybody, to Prisma Day. It's really nice weather. We're going to have a lovely day together. I'll throw some paper around. Good morning. I hope you all got some coffee and are ready to go. As David said, my name is Søren. I'm the co-founder of Prisma. So let's just jump right into the talk. There we go. We have some amazing speakers today. So I'm going to do a quick keynote just to get you all woken up. And then I look forward to see all the amazing talks in the rest of the day. I'm going to break this talk into two parts. First, we'll take a look at what has happened over the last year since our last Prisma Day. And then I'll talk a bit about some trends we're seeing in the industry and how Prisma fits into that. I'm seeing some weird faces down here. What does that mean?
The projector stopped working, but it's
Okay. Very good. So first, a year in review. It's been a year since our last Prisma Day, and that was an online event. It's really great to be here in person now. I mean, it's been 2 weird years, COVID and all this stuff going on, and getting back to being able to meet each other in person, interact and talk is just really amazing. So 4 years ago, we really started to see a change in the Node ecosystem, and that was the seed of what became Prisma. If you remember back, there was this war going on between TypeScript and Flow, trying to bring some sanity into the Node ecosystem. And at the time, it was pretty exciting. We didn't really know where it would go, but pretty soon it became clear that TypeScript would just dominate. Not only would it be the type language of choice, it would be the dominant language, period, in the Node ecosystem. So we saw that 4 years ago, and we started working towards this vision of building an ORM, a query builder that is really the most sophisticated library using TypeScript. And it is as a result of that vision that we today are really becoming the new default ORM in the Node ecosystem. We have almost 200,000 developers using Prisma. And that number keeps growing. It has been growing 10%, between 10 and 15% every month for the last 2 years, and it's continuing to grow. So that's really, really cool to see. This is an ecosystem that is vibrant and growing. Every day we have 500,000 downloads on NPM, and we have thousands of companies deploying Prisma in production-ready applications. Our team has spent the last year talking to many of them, and as a result of that, you can go online and find some of these showcases that really demonstrate what people are doing with Prisma. Here are a few of them. Invisible is a large company that migrated the entire stack from SQLize to Prisma, and as a result, they were able to speed up their development process. Cal.com is a really interesting open source company. They're venture-backed, but all of their software is open source. They have more than 20,000 users. So if you want to go and look at the source code of like a real high-growth startup, go have a look at their GitHub. And then finally, Poppy is a Belgian mobility startup that you can rent cars and mopeds, these kind of things. And they're running Prisma for the entire thing. They bet on Prisma from day one, and today they have more than 400 SQL queries per second in just normal load. And we are really, really excited, flattered that some of these next-generation developer tools are built on Prisma. They're using Prisma as the foundation. So Application is a low-code development platform for front-end and back-end developers. They recently raised $6 million in funding, and they have been embedding Prisma from day one. Another one is Redwood. It's a full-stack web framework for startups, kind of recreating some of that vibe from Ruby on Rails in the early days, but in the Node ecosystem. And for their ORM layer, they're using Prisma. Here today, of course, is our very own David, who is emceeing the conference. He's part of the awesome Redwood team. And they are funded by Tom Preston-Warner, one of the co-founders of GitHub. So that's a cool thing to be a part of. And finally, Keystone, with version 6, we're really excited to see that they switched to Prisma as the default ORM layer. It's a pretty big CMS, more than 1,000 installs and lots of open source contributors. Now, one of the things that I enjoy most is to see developers experience Prisma for the first time, see that aha moment when they do the auto-completion. It's like, it just does stuff for me. That's pretty cool. So we've collected some of those moments in a video. We had some issues with the audio before, so I hope it works. It's 40 seconds. I'm going to just play it. If the audio doesn't work, you can play a game of spot the famous developer in there. That'll be fun. I'll play the video, and then I'll get back to you in 40 seconds.
Okay, that is a pretty neat bit.
And hit refresh, run that again. Do we get another one? We do. Oh, how cool is that? Nice.
Thank you for giving examples, Prisma. You're the best.
Ooh. Look at that. This is so nice.
I'm not gonna lie, this is really cool. Like, I did not know that this was a feature, and this is a really, really handy feature. That this is, you know, a thing that we can just very quickly stand up. I like that a lot.
But yeah, this is awesome. This is really cool.
Exactly.
This loads up in the browser.
I'll submit these links. They're gonna go in the database. This is how easy Prisma makes working with databases.
It's really fun.
Okay, that is a pretty neat bit.
Once is enough. So now let's talk about some of the cool and exciting features we've added to Prisma over the last year. I think that really the biggest chunk of work has gone into full support for MongoDB. It was a huge effort for the query engine team. But now we support Mongo as a first-class database. We have awesome support for relational databases, but our support for Mongo is just as sophisticated. So that has been super cool to see. And we have about 2,000 developers that picked it up in the first month, and we expect to see that grow to become about a third of all Prisma developers over time. We also added support for Microsoft SQL Server, a little more enterprisey, but also Cockroach and PlanetScale. And they are awesome offerings for serverless relational databases. Another big area of effort over this year was to improve the flexibility of Prisma Migrate. So Prisma Migrate is really, really cool because it's a declarative migration system. That means you just write your schema, you make changes, and then you let the system figure out the delta to apply to your database. It's really cool when it works, but when it doesn't quite work, it can be frustrating. So the team sitting over here have been spending some time figuring out how can we help you get out of these issues. So with the two new commands, Prisma Migrate Diff and Prisma DB Execute, you now have more flexibility to recover from failed migrations and to run arbitrary SQL as part of your migration steps when you need to. And finally, we've been working on this thing we call the Prisma Data Platform. the ORM is really the foundation of everything we are doing. The open source ORM has a lot of users. There's a lot of work we still need to do. But our long-term vision is to solve data access for applications on a much larger scale. And that's what the data platform is all about. Over the last couple of years, we have spoken to hundreds, like almost thousands of developers using the Prisma ORM, not using the Prisma ORM, figuring out what are the issues around data access in applications. We've also spoken to large tech companies like Twitter and Facebook to learn from the tooling they have built internally to make their developers more productive. And the result of all of those conversations is our vision for the application data platform. The first part of this that some of you have been using already in preview is the Prisma data proxy. And we have heard from many users during this preview phase that it's really helpful. It helps you manage connections in serverless environments. And as a bonus, it also enables you to connect to your traditional relational or Mongo database from edge environments like Cloudflare Workers or Vercel. And also, this year, we announced our seed round, not a seed round, our B round. We raised $40 million from Altimeter. And some of you might be aware of the weird funding environment we are in right now, where some companies have really struggled to raise. Some large, later stage startups have fired a lot of people. It's really kind of uncertain times. But as a result of our large community using Prisma and our clear vision for the future of the application data platform, we were able to raise a good B round. And now we look forward to use this money to continue to accelerate our investment in the open source ORM. There's lots of work for us to do, but also to really speed up the development of the application data platform. Another fun thing that happened is that Nasdaq decided that we were one of the 10 most promising early stage enterprise tech startups. So they put us on Times Square, which was kind of fun. And our team is really a bunch of great people. This year we crossed 70 people, and we went to an offsite in Spain. As you know, it has been a couple of weird years during COVID, and most people joining the team that joined remote. We are a fully distributed company, and most people never met before. So just a few weeks ago, we were able to all come together in Barcelona, meet each other for the first time, and that was just it's a really nice experience. If there's one thing that sets Prisma apart as a company, it is our focus on hire really great people that we are excited to get to work with every day. So I feel privileged to be able to work with so many kind, smart, passionate people every day. And yeah, we are hiring. I just looked at the website this morning. We have 11 open positions across the entire company, engineering, product, design, DevRel. So if you're looking for something new, if you're here today, come talk to some of us. We all like to tell you about Prisma and what we're doing every day. If you are watching online, go to the website, have a look at our offerings, and come talk to us. So now let's switch gears a little bit and talk about some trends in application development and how Prisma fits into that. I'm going to talk through 4 trends that we are hearing from our users, that we are seeing in the industry. So the first is that front-end developers are becoming full-stack developers. We'll talk about serverless, developer experience, and then the increasing complexity in the data layer. There is this really amazing proliferation of full-stack frameworks like Next and Remix that they're really just great tools to use, and they enable front-end developers to start doing a little bit of back-end code. Some of these frameworks will enable you to write a small JavaScript function together with all your normal code, and then the system will just take that, create an API route, and deploy it to a serverless function for you, which is super, super cool and useful. This enables you do more work, do more complex things without having to think about all of the infrastructure, setting up a separate service, go through all of that work that would normally kind of hold you back. But one thing we have been hearing from many of those people is that it's easy to start putting some business logic on the server. Maybe you can start calling some existing API functions. But at some point, you really want to start storing state in that full stack context. You want a database. And that can get kind of complicated. Relational databases are very different to work with than our normal objects in JavaScript. There's just a mismatch. So as all of you know, Prisma bridges that gap. Prisma helps you think about databases in a way that is much more familiar to front-end developers. Yeah, apologies for this bad joke. Build more serverless. Serverless is a huge trend in the industry. Serverless enables you to really deploy complex infrastructure without much effort. It enables you to scale up and scale down easily. So it's an amazing enabler. But there is a challenge, and the challenge is that with databases, you really need stateful connections. Traditional databases, they require you to set up a stateful connection to read and write data, and that is a mismatch for how serverless functions work. Serverless functions are stateless; they spin up and down as your requests come in. And that can be difficult to all fit together. So to illustrate this problem, here's a graph that shows requests coming into your web service on the x-axis, and then the connections you open up on the y-axis. As requests come into your web service, normally you would be able to reuse connections between requests, but in a serverless environment, as you know, Lambda functions, they can just spin up, spin down, and often your requests will end up on different infrastructure. So that means you can't reuse those connections. So as a result, you will quickly exhaust the connection limit in your databases. The solution to this is to introduce another stateful component, a data proxy. So you can use something like PG Bouncer, but then you have to manage that on your own. It's kind of annoying. Instead of going through all of that hassle, you can use the Prisma data proxy, which is a managed serverless function as part of the Prisma data platform that will do this work for you. It's tightly integrated into the Prisma ORM, and you can enable it just by switching a single configuration in your Prisma schema. The third trend that I would like to talk about is developer experience. I think we all talk about developer experience as it's just something natural. We all want a better tooling, a better experience. But if you take a step back and think about what enables better developer experience, what is happening over time, I think it is useful to think about our industry as having kind of generations of developers that last about 5 to 10 years, and every generation of new developers is really 10 times bigger. Our industry is an industry that is just growing rapidly. It's super, super fast. So what happens every time you have a new generation of developers? You have a much bigger market, so we collectively can invest much more money into tooling for developers. At Prisma, we think of developer experience as having really two core tenets. It's productivity and confidence. So if you look at productivity, you can look at the company perspective and say, developer experience is important because we can move faster, we can be more competitive in the market. When you look from the developer's perspective, it's more about like having great tools, having fun doing the work we are doing. But luckily, those two things go together. So when we create tools that make you feel more confident, you can You can use auto-completion in the IDE. You will get error messages from TypeScript if you miss something. That confidence enables you to be much more productive. And as a result, the company you work in is more competitive. So that's why developer experience is something we all want, but it's also something companies are realizing that they need to invest in. They need to invest in developer experience to attract developers, of course, but just as importantly, to be able to compete with the other companies. And finally, the last trend I want to talk about is this increasing complexity in the data access layer. It used to be that we could all just use a single general purpose database and that would solve all of our needs. That was 20 years ago, at a time when we had much less scale, much lower requirements. People expected less from those systems. And what is happening now is that people are starting to introduce all kinds of extra functionality into the applications. You might need to full text search. You introduce a search index like Elastic or Algolia. You might need to serve really fast requests or scale, so you introduce a caching solution like Redis. Maybe you need to do some graph computation, nearest neighbors or social graphing. So you introduce a graph database like Neo for the dgraph. And the challenge with this is that using a single database is pretty easy. All of the internals required to make the database work and perform, they are just that. They are internals in the database. It's a really nicely wrapped product that you can just use. But now, when you're using many different databases, all of those internals very much become your job. You now have to understand how all of it fits together. You need to sync data from one place to another. You need to make sure it doesn't drift. All of the hard work that database engineers have been working on for decades is now your job. So we think the solution to this is to try to bring some of this complexity back into the product, under the surface. That's our vision for the application data platform, to build a system that helps you use all the databases you need to use, but without having to really be experts in the internals of databases. So in the industry, there's this emerging pattern called change data capture that really is used to synchronize different data stores and do it in a very production-ready fashion. Over time, you'll see us build direct support for this pattern and more into the application data platform so that you can use these things directly from the Prisma ORM without having to worry about all of the internals. And speaking about the Prisma data platform, we've been working on this for almost 2 years. Many of you have been helping us provide feedback for the data platform over the last months, and we've been very, very thankful for that. And today, I'm really happy to announce that the Prisma data platform is ready for production. We are launching the data platform in GA. Thank you. Some of you have been using this in production already, and you're brave souls. Today, you can sleep a little better at night and continue to use it. The data platform has the data proxy that I talked about. It has a data browser that you can use as a developer, but you can also invite other people from the company to access parts of your data in a secure way. We have the query console you can use to go and write Prisma queries against your production data and see what comes back, and a bunch of other things. And this is really just the early beginning. This is the first step towards that vision that we are talking about. It will take us many years to get there, and over the next few years, you will see us add more and more functionality. So to wrap it up, those were the 4 trends we talked about. Front-end developers becoming full stack and how Prisma helps bridge that gap towards working with databases. The fact that serverless is just an absolutely dominating trend in our industry, and you need ways to deal with the statefulness of traditional databases and then the ephemeral nature of serverless functions. We talked about developer experience and how Prisma thinks about developer experience as a thing that can empower all of you, but also help your companies be more competitive. And we talked about how the data layer is becoming much more complex and how we aim to help with that in the future. And before we end, I want to invite all of you to thank Natalia and the entire team who have put together this conference. Thanks, Natalia. She's sitting somewhere. It's over there. We're going to have a great day. Finally, thank you to all of you for coming out here, flying some from far away. Take the day, talk to each other, come talk to me, people from Prisma, have a lot of fun. Drink the coffee. Talk to David, he's a fun guy too. Welcome and enjoy the day.
Thank you, Zoran. And I can agree from the outside looking in, being in the JavaScript node ecosystem, working with Redwood, it feels clear to me, and I don't have the data on this, that Prisma is definitely becoming the de facto ORM right now. We see that especially in new projects coming along. I feel like Prisma was one of the instigating factors in all these kind of full stack serverless Jamstack application and frameworks that started up. Prisma was behind all of those that I saw. So thank you, Zoran. They're doing wonderful work. And speaking of people we've had an amazing opportunity to collaborate with, Vercel has been one of the early, come on up, Delva, has been one of the early partners with Redwood. Again, phenomenal team, wonderful people.
Hey.
And it's a pleasure to introduce Delba from Vercel, who, I'll let you take over. Thank you all.
Thank you.
Real quickly too, Delba, sorry I forgot this. If you all feel free to scoot back if you're feeling like there's too much sun or the sound is too loud. Lots of shade, and there's also video screens set up in the back. I wanted to tell you that. And now we'll hand it over to Delba. I like the sun's going to be great, right? See, that's why I brought a hat. All right, thank you all.
That's good. Hey everyone. So as David said, I'm Delva, and I'm really happy to be here and see you all. So I work for Vercel, and some of you may already know Vercel. We are the creators of Next.js, and our platform supports over 35 plus front-end frameworks, including Redwood. So today, I'd like to talk to you about your journey, or the journey that your data takes from your database to your front-end application, specifically in React 18. And I'm curious to know, please put your hands up, how many of you used or use React? Okay, most of you. What about Next.js? Wow, that's amazing, cool. So you probably already know this, but a few months ago, React 18 was released, and it introduced new concurrent features. And on the React blog, the team itself, they mentioned that concurrent features will have a big impact on the way that developers build applications. So I want to discuss with you how concurrent features, as well as React server components, will impact the way we build applications and what that means for frameworks like Next.js and, of course, Prisma. Now, I'm going to specifically look at routing and how it impacts data fetching and rendering, because I think they're kind of like the pillars of front-end applications, if you think about it. Now, before we jump in, I want to share with you a very short story. I learned how to code through a boot camp, and I spent 9 months learning about the front end and the back end. We started off with, basic HTML, CSS, JavaScript, and of course React. And once we were confident we could build very simple front-end applications, then we moved on to the back end. And in the back end, we learned how to spin up very simple node servers. And I remember one particular team project where we had to use Express and middleware to manage the back-end routing and create our API routes. And we had to manually update our schema. So we used a query builder to do our SQL queries. And then we had to use another tool to preview our database. And then back on the front end, we used a global Redux store to fetch our data and store it so that we could pass it around our application. Now, I don't want to bash on any of these tools. I was definitely misusing them due to my lack of experience. But as you can all probably imagine, it was very difficult for someone who was new to coding to understand the data flow from the database to the backend, to the front end, and of course, finally to the components. And although there was a very clear distinction between front-end tools and back-end tools, the journey of the data was very convoluted. I mean, if you think about it, I had to learn so many different tools just to create a very basic CRUD app. And because there were no conventions, whenever I started a new project, we had to take a different approach to routing and then another different approach to data fetching. Now, fast forward a few months, and I made 2 discoveries that really changed my workflow. And what I loved about them is that I could finally get past trying to glue everything together, trying to debug everything, and actually build applications. And the first one was, of course, Next.js. The data fetching methods in Next.js gave me a very structured place to fetch data within my application. And with the API routes, it also meant that I didn't have to create a separate backend. One thing that I also loved about Next.js was the file-based system, which meant that routing was way more intuitive than using code. So I didn't really need 2 routers, one for the backend and one for the front end. Now, the second revolution to my workflow was, of course, Prisma. And Prisma provided a very declarative way to model my database, query my database, and preview my database. And in my previous workflow, those 3 things were separate. But if you think about it in retrospect, it kind of made sense to combine them. Now, with Prisma and Next.js, the journey of my data became much simpler. Now, I hope I'm not selling it too much. I do love both of these tools. But the takeaway that I want to, to tell you today is that there is value in abstractions and conventions, not just for new learners, but also for more experienced developers and their teams, to enable them to work faster and also more consistently. And secondly, sometimes new innovations, new tools, they kind of tend to blur the line between what we considered a solid boundary before. So when we use these tools, we kind of almost have to shift our mindset on how we build applications. But anyways, going back to React 18 and React Server Components, I believe that a shift in mindset is going to be happening very soon as we adopt these new features. You see, for a very long time, there was a very clear distinction between single-page applications on the client, which React is associated with, and multi-page applications on the server. But there is an emerging trend in our industry, and it's not just with React. We are seeing front-end frameworks moving towards more hybrid solutions that leverage both the client and the server. So in early 2020, the members of the React team, they were publicly discussing moving more rendering work to the server. The idea was that if we have to go to the server anyways to fetch data, could we do some of the rendering work while we're there, and therefore reduce the amount of code that we send back to the client? Now, you can probably imagine the hot takes that follow that tweet, and they can be summarized as, this looks a lot like traditional server-side rendering, a pendulum swing back to MPAs. But to quote a not-so-serious meme from one of my favorite people on Twitter, this is less of a pendulum swing and more a spiral of incremental improvements or switchbacks. We're not looking for purely SPA or purely MPA, but we want to combine the benefits of both the client and the server. So each time this conversation was brought up on Twitter, the React team was careful to emphasize that they were looking for a hybrid solution. And I think an important takeaway here is that this hybrid solution wouldn't be creating additional requests to the server. It would take advantage of a request that already has to exist anyways. So in December 2020, the React team gave us an early Christmas present that would enable frameworks to move more towards hybrid solutions. And that was React Server Components. When you combine React Server components with features like suspense and streaming, we have the primitives or the building blocks to address some of the disadvantages of multi-page applications while maintaining the user experience of single-page applications which we come to love. But there is one last piece to the puzzle. In the last few months, the Next.js team has been considering if we need to go to the server to do data fetching, and now with React Server components, we are going to the server to do some rendering, could we also use the same round trip to do some routing? Could we enable developers to build hybrid apps where data fetching, rendering, and routing happens where it makes more sense for the app that they're building? And could we do it with easy conventions that will allow them to shift the work back and forwards between the client and the server? So, a few weeks ago, we shared an RFC. And in this RFC, we proposed a new router that builds on top of React Server components and React 18 features. There is a lot more detail in the RFC, and if you're curious, I would recommend reading it to know more. But for now, let me just share with you some of the things that I'm excited about. So with React Server components, we can interweave client components and server components in a tree, meaning that in your page or in your route, in your application, you could potentially have client and server components. And if you think about it, with this model, it becomes increasingly important to break up flat routes into smaller fragments, or as we like to call them, route segments. And these route segments, they map to your components and to your URL segments. And although we are breaking up the routes, we want to maintain file system routing because generally it's more of an intuitive way for developers to define routes. And breaking up these routes into small segments has three benefits. The first one is that we're able to create layouts. And layouts has been a very requested community ask. And we are defining a layout as UI that can be shared across sibling routes. And these layouts shouldn't re-render or lose state on navigation. This also means that for components that don't change when a user navigates between a route, those components should also remain interactive. And secondly, if we are combining this model of nested routing with server components, it means that on navigation, we only have to fetch and re-render the segment that's changed, and we don't have to re-render the whole tree. And thirdly, we can have more granular control over data fetching by allowing each segment to fetch its own data. Since we already moved data fetching outside of your rendering code or your components with the Next.js data fetching methods, we can eagerly initiate those requests in parallel. This helps minimize waterfalls, and overall, it reduces the amount of time that it takes to fetch and render the content for the routes. And overall, by building a new router with React Server components, we're able to reduce the amount of work that the server has to do on navigation, the time it takes to do that work, and also the amount of code that gets sent back to the client. And by combining it with concurrent features, such as transitions, suspense, and also the future off-screen component, we can simplify loading states and improve the navigation experience. So for example, if you're using client-side routing to do data fetching, and you're fetching as you render, you may have too many staggered loading states. And you want to consolidate those loading states into like a fewer, more meaningful loading UI. On the other hand, if you're using server-side routing, you have to fetch and render the content before navigation starts. So your application will appear unresponsive while the work happens on the server. In that case, you might want to add loading UI to show that the work is being done. And we can improve the navigation experience by pre-rendering a small, meaningful part of the future screen. This means that when the user navigates to a new route, the navigation will be immediate, whether that's client-side routing or server-side routing. And then we can show something like a cover photo or a title while the rest of the content loads. And in a similar fashion, and this is one of my favorites, is that we'll be able to stash routes in the future. So any routes that have been visited can be stashed, and then we can pre-render routes before they are visited, so that when the user navigates backwards and forwards between those two routes, the navigation will not only be instant, but we can also store the state and restore the state, sorry. Now, if routing, data fetching, and rendering are the pillars of front-end applications, then I want to argue that URLs are kind of the foundation of it. If you think about it, the web has something unique, which is the ability to link to almost every single piece of content on any device, with any browser. And we want to provide simple conventions that doesn't just make it easier for developers to implement great UI patterns, but also embrace the web for what it is. That also doesn't break URLs. So for example, in a route, you should be able to have one or more parallel segments that can be navigated independently. Take, for instance, two tab groups. If you navigate one group, it shouldn't affect the other. And when you navigate backwards and forwards, it should remember the combination of those tab groups. And in a similar fashion, sometimes you might want to intercept a route from within another part of your application. Take, for instance, an image post that appears as its own page, but then you can intercept it and then present it in line as a modal from a profile or from a feed. In this case, the URL should be respected, and if you were to link to the page, it should load the correct image and not the content behind it. So I've talked about React, and I've talked about some of the things we're excited about in Next.js. But what does that mean for Prisma? Well, for you, as the developer, not much. And I know this might sound a bit anticlimactic, but it's actually a sign of a good architecture, because we're able to completely and fundamentally change one side of things without affecting the other. But saying that, let's see how Prisma might fit into this new model. So with suspense and streaming, we might consider breaking up our requests into essential and non-essential. For example, if you want to get something fast on screen, you might want to stream the contents of a blog post first, and then stream in the non-essential comments later. With nested layouts, you might want to fetch your e-commerce categories in the menu in the parent layout, and the individual product info in the nested pages. And with meaningful skeletons, we might pre-render a blog post by fetching the post title and the cover image first, and then the rest of the content. In each one of these cases, React and Next.js will deal with the data fetching and the sequencing, and Prisma is ready to handle the data requirements. So this kind of like fine-grained data fetching is exactly why Prisma is so good. Now, I want to conclude today with some thoughts and some of my own opinions on my abstractions. On one end of the spectrum, we have databases, and we have all the complexities of storing and retrieving data from databases. Just ask any of the speakers here what they do, and you will know that databases are complex. But on the other end of the spectrum, we have browsers, and all the complexities of drawing the pixels on screen. And as app developers, it's our job to manage the data flow from our database to our application. We could use raw React to manipulate the DOM. We could use raw SQL to manipulate our data. But if there's anything that we can learn from the success of React over these many years, is that there is value in simple and more declarative abstractions that rein in the chaos of these underlying languages. And it's not just about the ergonomics of abstractions. It's about benefiting from the immense experience that these teams have and get pulling their updates to your project. So essentially, we have 3 teams that are working on very specific things. And what we can do is we can let them almost ghost code or ghost write the boring and hard parts of building applications so that we can focus on the fun stuff. So thank you for listening, and I hope that has given you a glimpse of what we're thinking about in Next.js. And I think right now it's time for questions. Right. Any questions?
Yeah. Do you have any timeline for all of this, or is it not decided?
So we're implementing it right now, so we're building the system. I think there are a couple of hurdles we have to overcome first. But the main thing is that we're also working in parallel with React. So we have to account for the changes in React and then think about how to implement those changes in Next.js. Hopefully, though, I think that we might have something for developers to try out soon. And if you haven't read the RFC but you want to give feedback, we really would appreciate your feedback as well. Any other questions? All right. Thank you.
Thank you, Delba. Who has deployed to Vercel? Yeah, see, I knew it. It's a phenomenal product, and I'm excited to check out the RFC, so thank you so much. After each talk, the speakers are going to have some time for some question and answers, as you saw. And the way a better MC would have told you this beforehand, but I just realized it'd be a good thing to know. Now, just raise your hand, and one of the members of the AV crew will come over, bring you a microphone. You can ask your question, and that way the people that are watching on the live stream will be able to hear. But feel free. Also, all these speakers would love to talk to you in between the breaks, so that's a good time to talk to them as well. But if you've got those questions, write them down, and we'll have about 5 minutes after each talk for some Q&A. Next up is Jesse. Unfortunately, Jesse, such are the days, wasn't able to join us today. But we're going to be watching Jesse's presentation on screen. So make sure you can see the screen. Again, we have some screens in the back. And there will be time for live Q&A with Jesse. He'll be joining us for Q&A. So we'll have 5 minutes of Q&A with Jesse after the talk is done. So hold on for that, and then we'll go to a break. Sound good? Was there anything I missed? So far, so good? You seem happy. All right, good. And I'm learning with the German crowd. It's not like an American happy, but I've got it. It's a little bit doubt. See, that was good. You can laugh. All right, go ahead. We'll listen in on Jesse, and then we'll do some Q&A.
Good morning, Prisma Day. I wish I could be there in person, but my wife and I are stuck in New York City with COVID. You can see I'm in a hotel room. I was really looking forward to visiting Germany and meeting you all in person. And I didn't want to completely miss this event, so I'm here by video. And I hope you learned something. And thank you to the Prisma team who have been very supportive and understanding. I hope to see everyone in person sometime soon. Who here has had to deal with relational database spaghetti? I mean, it looks like a nightmare, right? That's terrible. Oh, well, that actually looks pretty good. It's not quite lunchtime yet, so we'll get through this talk and then we'll get something to eat in a bit. Today we're going to talk about a different way of storing data. Structuring data as normalized is the standard for relational databases, but who wants to be normal? Let's denormalize our data, put it in documents, and get lightning fast reads in our applications. I'm Jesse Hall. I'm a senior developer advocate at MongoDB. You might also know me as Code Stacker from YouTube. So today we're going to look at the document data model and how it's different from the standard relational model that you may be used to in a SQL database. We're going to look at some trade-offs between normalization and denormalization, and we'll look at relationships, and then data modeling with documents, embedding versus referencing, and how Prisma can help us with this. So back to that relational spaghetti. When we model data in a relational database, something like a SQL Server, Oracle, or Postgres, you go through a process of normalization of data elements, which is, by its very nature causes you to separate data into separate tables. And so you're going to end up with something like you see here. And this type of data storage has really been the norm for a very long time, and it still is. But today we're going to talk about a completely different way of storing data. But why has storing data in rows and columns been the prevalent way of storing data? Well, here's the reason. When databases were invented, it was very expensive to store data. The hardware was expensive. In 1956, it cost $9,200 US to store 1 megabyte of data. Today, in the year 2022, you can pay as little as a fraction of a cent per megabyte of data. So when normalization was introduced, the most precious resource was disk storage. And as a result, the primary rule was to reduce disk space by never duplicating data. Here's another look at the rapid reduction in data storage costs over time. Edgar Codd introduced the rules of normalization in 1970 when storage was still very expensive. And then around 2007, someone comes along and asks the question, does normalization still make sense? We no longer have the constraints of limiting data that is saved because of financial costs, and this was the birth of MongoDB. And this is a great way of visualizing the difference between storing data in a relational database versus a document database like MongoDB. So in the relational database, if we wanted to store our car, we would separate our car into a tires table, a seats table, an engine parts table, a brakes table, and so on. And then we have to join everything back together when we want to drive the car. Now, has anyone ever said, let's not use the brakes today, we don't need those, or we don't need the tires, or any other piece of the car? No, you need every piece of the car every time you want to drive it. And so all of this has to be joined back together every single time we want to use our car. In a document database like MongoDB, this is how we store our cars. It's all together, ready to go when you need it. So generally in MongoDB, data that is accessed together should be stored together. And if there's one thing that I want you to come away from this talk with, and it's this. This is how we model data in MongoDB. But not all data is created equal. There will be use cases where we don't need all of the data every time. And so we're also going to talk about how MongoDB stores related data in different ways. So let's take a look now at some terminology surrounding MongoDB document databases. So some refer to MongoDB as a NoSQL database, and that gives the impression that SQL is not allowed. But the term actually means not only SQL, and so this isn't really the best way to describe it. Others refer to MongoDB as a schemaless database, and that's not an accurate description either because it does have a flexible schema, and you're encouraged to define a schema for your data, and you can even use schema validation in MongoDB at the database level. And so then others also refer to MongoDB as a non-relational database. And again, this isn't a great description because relational data can be stored in MongoDB, it's just stored differently. And so really the best category to put a document database like MongoDB in is non-tabular. We don't store data in tables with rows and columns. And so it requires a shift in the way you approach storing your data. Normalization of data has been ingrained in us, it's all we know. So storing data in a document database requires a shift in thinking. And so we're going to go from tables of data with relationships to documents of data which can contain embedded data. And these documents use a JSON-like structure. So this document here is the representation of the exact same structure as the tables. And so as you begin to think about the schema for your application's data, ask yourself 4 important questions. What does my app do? Describe its workload. What does my data look like? Identify and model the relationships. How do I access my data? What tooling am I going to use? Hopefully you'll be using Prisma. And how is the end user going to use my app? So apply existing data access patterns here. You may think that your data is unique, and it may be, but the way in which your users access your data is probably not unique. And so there are existing patterns that can help you to model your data. How do we model relationships in MongoDB? A flexible data model means that one document to the next can look completely different in the same collection. And that's okay. It's called polymorphism, not schemaless. You can also store documents that have other documents nested or embedded. You can normalize data if that makes sense for your application through the use of references. And what you really want to focus on, though, is how your application is going to reference or use the data as opposed to how it's stored in the database. How will your users access the data? This is the opposite of how data is modeled in a relational database. In a relational database, we get the data requirements, we model the data, and then we pass that along to the application UI. In MongoDB, we start with the UI UX and ask how will users interact with our data, and then we model the data accordingly. And so this is where the flexible document data model makes sense. You're not constrained to one way of storing data. You can choose to normalize some of the data if that makes sense, embed other data that will be accessed together, or any combination of storage methods that makes sense for your application. So again, data that is accessed together should be stored together. Let's take a look at modeling relationships. These are common relationships no matter what database you're using. We have one-to-one, one-to-many, and many-to-many relationships. So let's take a look at modeling one-to-one relationships. In a traditional tabular method, we would have a movie table, and that could be related to a movie details table by the movie ID. In MongoDB, we could do the exact same thing and have a movie collection and a movie details collection and use the movie ID as a reference. Or if the data is usually accessed together, we could just have one movies collection and embed all of the data there. Now looking at the one-to-many relationships, in a traditional tabular method, we would have a movies table and a cast table, and we can see here that there are many cast members related to a single movie. In MongoDB, we could do that exact same thing and have a movie collection and a cast collection, and the movie ID is a reference to each cast member. Or again, if the data is usually accessed together, we could just have one movies collection and embed all of the data there. You might use embedding to make queries more efficient. Nested arrays give you a great way to model one-to-many relationships. The cast is an array data type. And the benefit of this is that you can use one single query to retrieve all of the data that you need for the application. So now let's look at the many-to-many relationships. In a traditional tabular method, we would have a movies table, a locations table, and a movie locations table. And we can see here that each of these are related to each other and are creating a many-to-many relationship. In MongoDB, we could do the same thing with two collections where the movies collection references the filming locations and the locations collection references the movies where they were filmed. Or again, if this data is usually accessed together, we could just have one movies collection and embed all of the data there. Again, if the data is accessed together, it should be stored together. Next, let's look at embedding versus referencing. We're going to look at some pros and cons between these in MongoDB. So in embedding, when you embed data, you can use a single query to retrieve the data, and this is much more performant. You can also use a single operation to update or delete data, reducing the amount of writes needed. But you will likely have duplication of data and possibly larger documents. But remember that data duplication, though, is not necessarily a bad thing. Depending on the use case, it could actually be more efficient. So with referencing, there is no data duplication. You'll also likely have smaller documents, but you'll need to join data from multiple documents, which will decrease performance because of the extra resources needed. And so again, with document databases, we have the ability to choose how we store our application's data. You should use embedding for data that is accessed together. You're going to get fast reads, but you may get a chance of slower writes if the embedded data is duplicated in other areas of your database. You should use referencing for data that is infrequently accessed together. You're going to get faster writes because you're not duplicating data in this way, but you may get slower reads because we'll have to reference multiple collections to join the data back together. And so you have to decide what is more important for your application. Do you want faster reads or faster writes? Does your data change a lot? You might want to separate that data so that you don't have to update multiple duplicate locations. Or does your data rarely change? You might want to embed that data to get faster reads. And now, how does Prisma help us to store data in a MongoDB database? Well, it's really simple to set up. You're going to add a database underscore URL variable to your environment variable file that references your MongoDB Atlas connection string. And then in your schema.prisma file, set the data source DB provider to MongoDB, and then pass that environment variable for the database URL that you just set. And then you can use embedding by creating types. Here we have a movie model, and this has an ID, a title, a director, runtime, and locations. Now, the locations references a location type. So next we define our location type, which has a country and a city. And this schema is going to result in a movies collection in MongoDB, and the location will be embedded in each document. And Prisma can also help us with references as well. We can use references by using relations between models. So here we again have a movies model, just like before, but this time there is a comments field containing a comment array. And then there is a comment model, which has a relation to the movie by the movie ID. And there's also a relation to the user who made the comment through the user ID. Then we have our user model, and that contains the user info. And this is going to result in 3 collections in MongoDB: a movies collection, comments, and users. So Prisma makes it super easy to set up relational data in MongoDB by either embedding or referencing or any combination. So to recap, we looked at the document data model, normalization versus denormalization, embedding versus referencing, relationships, and how Prisma can help us model embedded and relational documents with ease. Thank you again for your time. I hope you learned something. Be sure to check out the M320 data modeling course on MongoDB University, and we also have several other blog posts on the subject on our Developer Center on mongodb.com. Hello, Prisma Day.
Jesse, this is David.
Hey, David.
We miss you and wish you were here.
So nice.
I'm gonna help with some Q&A time. You have some time for Q&A?
I do. I have plenty of time for you.
Sorry, that was a terrible stuck in a hotel room in New York joke. Jesse, if anyone has a question, we'll get the microphone to you. Who has a question for Jesse? If not, I'm going to ask him questions, and that's not what you want.
I don't want any hard questions.
All right, go ahead. We've got one here. Is it Frederick? All right.
Hi, Jesse. For relational databases, migrations are an important topic, schema migrations. And so I wonder if you can share any stories from users, how they evolved their schemas with Prisma and MongoDB.
Yeah, so migrations is not a thing in a document database. Because of the flexible schema of MongoDB, it's actually, in my opinion, it's much easier because there are no migrations. Your schema just evolves as you need it. And so you really don't even have to worry about the entire migrations process.
It's scary, right? You'll be okay.
Again, like thinking in a document database is completely different from the SQL world. You have to throw everything out the window because it's a totally different world.
Any other questions? Thank you, Jesse. Yeah, we got another one for you.
Hi, Jesse. Great talk. I had a question because the relational and embedded difference. I was a bit surprised that you showcased that in the Prisma model, the way you modeled your types in Prisma led to different ways that MongoDB actually organized the data. I thought the purpose of Prisma abstracting this away was that the developer doesn't really need to know the details of this, for example. So in my head, I was kind of confused about it because, like, imagine a developer doesn't know about MongoDB stuff and structure the data in one specific way. They would need some MongoDB specific knowledge in order to structure it in the correct way for read access or something. I was more expecting something like I model my data how I want to, and I do like an annotation quick read or something, and then MongoDB like organizes it according to my needs. I was confused about the tie-in there.
Yeah. The way that it's modeled again is completely different, and so from a relational database world, you're used to normalizing everything and separating everything, and then from the MongoDB perspective, we start with the user experience. How is the user going to access the data? And so think about it in that way. What data does the user need to access on this page versus the next page? And you model your data in that way. And that's how we can decide which pieces of data that we want to embed versus reference. And so it does, again, take a totally different way to think about it. But Prisma does an amazing job of making that super simple and super easy.
Very good. We still have some time. Yeah, go ahead. I think there was one in the back. No, maybe you answered it. Okay. Yeah, go ahead, Pavel. We have a couple more.
Yeah, so, thanks for the talk, first of all. And my question would be, like, seems like this non-tabular approach is like very powerful and probably can be used like in many ways and replace tabular approach. But like still, can you come up with some use case where MongoDB wouldn't be like a best solution, and where would you still go for SQL-like solutions? Thanks.
No, I get that question asked a lot, and I know that there are some use cases. And I'm not going to say that MongoDB is the best, or a document database is the best for every single solution, but I can't think of a use case off the top of my head that it wouldn't work for, because there are so many areas that it does work. So.
Yeah, thank you. Yeah, go ahead. One more here.
Thanks. This is actually funny. Yeah. So the only like trap that I discovered so far with the denormalization of the data is that it's very great and performant when you have static data that like doesn't change a lot over time. But when you have dynamically changing data that is expected to change frequently, it's actually troubling in the normalized world, because, for example, we have a profile name that is used in like hundreds of other collections, and when the user updates his profile name, now it's a huge hassle for us as a developer to keep track of every collection, of every use case of that name, and update that. So in that case, we usually currently use referencing and kind of trade off our performance of read queries so that we don't have a hassle of tracking everything. My question would be if a Prisma can actually, or any other like abstraction on top of any NoSQL database, could help solve us that problem and actually track that for us, so we don't have to think as a developers and spaghettify our code to actually do that ourselves.
Mm-hmm. Yeah, no, so again, it takes, there's some give and take there. Do you want really fast reads? Do you want really fast writes? How often does the data change? All the same things that you just said, that's how you would model your data. So if you are having to update, like you said, maybe a user profile, that is not something that you would probably want to duplicate too much. And then it comes down to tracking how many things are duplicated. So there's one thing that in MongoDB Atlas, there are triggers. And so you could on write to a certain cluster or a certain collection, you could tell it when this write happens, go ahead and update these other pieces, and that will happen for you automatically on the back end for you. So that's one way to go about it. But then it just, again, it comes back to tracking where is that data duplication and making sure that you've got all of your bases covered. again, it's case by case basis as to whether you would want to duplicate data or not. Some cases it's much more performant to duplicate the data. Some cases it's not.
I like that one. I learned something. We need to move on. Sorry. Thank you. Jesse, I have a question though.
Sure.
Okay, so I can't make any promises because I don't make the decisions, but I know people. So we wanted you to be here and you couldn't make it. So what if we get together in a beer garden in Berlin sometime next year? What do you think? Would you come and join us then? You want to do this again?
I'll be there.
All right.
Yep,
we would love to have you. Jesse, thank you. Really exceptional talk, and thanks for joining us live. All right.
All right, thank you all.
So we're about to go to a break, and we've learned a few things so far today. If you didn't know, MongoDB is now GA for Prisma, which I think is phenomenal for the JavaScript ecosystem. I've had a lot of success in past endeavors with Mongo, and it's worth checking out. I think Prisma solves a lot of the issues we had at that time, and I just wish we had Prisma back then. So we learned about MongoDB GA. We learned about the data lifecycle that Prisma supports inside of an application, and the Prisma data platform is, this is Soren stock, GA. You got that? So again, all right, Germans. So when if I do the pause thing and wait, that's where you can just chime in. The day will go on. So there's an open bar. Now we're just on the coffee. So by the way, we're going to go to break and be back at 11:45-ish. We will be prompt, actually. But I want you to have a successful break. The toilets, that way. I actually don't know where they are. I was just told to point that way. Toilets are over there. The coffee, also that way. The open bar, it's a little early, that way. And there's a photo booth over that way. So any questions for me about what you should do during your break? No? Good? Everybody clear? All right, 11:45, we'll see you. You can switch seats around if you really want to mess somebody up. I'll see you in a few. All right. Okay, all you social people. It's time for our next presenter, but I'm going to stall. I'll give you a few seconds to come over, get your beverages. All right, well, welcome. For those of you tuning in live just now from the land of the internet, I'm sorry, we're in a really beautiful place, and I wish you were here right now. We are in a beer garden in Berlin. It's the perfect temperature, a little bit slightly cloudy, so there's not too much sun, right? It's like it's just right, and it is a lovely day. We've heard from some great speakers so far. Our host is phenomenal. Couldn't have asked for a better MC, and yeah, thank you. Yeah, see, that's good. No one's paying attention, except for you. But thank you for that. Yeah, we've got a lot more to come today. So thank you. All right. So anyone go to the workshops yesterday? Did you know about? Okay, so there were Prisma workshops yesterday. A lot of people went. Did any of you who are here now go to any of the workshops yesterday? Yeah. So was it good? There's a right answer to this. It was good. All right. You'd recommend? Okay, more Prisma. Yes? All? Oh, yeah. So very good. All right, so Prisma workshops, look for those next time. I know that the Prisma team, when I got to meet with them yesterday, they were very excited about the Prisma workshops. So they said they had a great time. For all those who joined, thank you so much. Well, we have Michael from Stellate now. Is that correct? Yeah, come on up here. Which was GraphCDN, which we've also gotten to know because Redwood's a GraphQL application. Max Stober and crew, yeah, we're excited what's happening with Stellate, and we're excited to hear from you. So
thank you.
I'll get out of your way and let you go.
Awesome.
Welcome, Michael, everyone.
Hey, I am going to be talking about building Typesafe GraphQL APIs with Prisma and using a library called Pothos that I've been working on. So what is Pothos? Pothos is a code-first schema building library for GraphQL. If you're familiar with Nexus or Type GraphQL, this might be an alternative to those libraries. If you're not familiar, code-first GraphQL builders are basically a pattern for building GraphQL APIs through code. In this case, it would be TypeScript. And kind of the schema, your GraphQL schema ends up being an artifact that is generated from the kind of the code and the types you define inside of your application, rather than building manually typing out your GraphQL API and then building out resolvers that match the schema you've defined kind of manually somewhere else. One of the big focuses for Pothos is type safety. It has a pretty powerful type system internally that makes it one of the best ways to ensure that your GraphQL APIs are completely type safe. This means that everything from defining types and fields and arguments all the way through resolvers that actually return the data for your application are entirely type safe, and you'll get great autocomplete throughout that whole process. And then one of the big parts of the type safety system is that it is entirely built through using TypeScript features rather than depending on things like code generation or experimental decorators or other metaprogramming techniques that you might have run into if you've built GraphQL APIs with TypeScript in the past. It also has a very extensive plugin ecosystem. So there are plugins for all kinds of things like authorization, validation, data loaders, and of course Prisma, which is kind of why I'm here to talk about this. The plugins for Pothos use a kind of unique pattern that makes the plugins really feel like they're part of the core API, and the plugins can hook into and take advantage of all the same type safety features that exist in the core. And that means things like defining a authorization check or something in your schema. If you have a field or a mutation, you want to perform some kind of authorization logic on that. Those authorization checks will automatically get access to your GraphQL context and your arguments, all with complete type safety without you having to import types from anywhere. And you also don't have to manually specify types anywhere. Throughout this whole presentation, everything will be type safe, though you won't see a single manual type definition anywhere in that process. And kind of this all kind of culminates in what I think is a really great developer experience. You kind of get to build an entire GraphQL API with all the different components, whether that's like authorization or the actual code that does resolve the data for those requests in one kind of consistent API, rather than having to like define your schema in one file, then define your resolvers in a separate file, and then authorization checks somewhere else using a different library. This kind of brings all of those pieces into one nice, clean API. So why would you use Pathos? It's designed to work at kind of any scale. This is a project that I started building at Airbnb when we needed to quickly build out a GraphQL API that exposed the majority of Airbnb's data for customer support agents. So Airbnb has a whole lot of different services, and a lot of those services were designed to expose data for the consumer-facing use cases, and we were kind of working on redesigning a lot of the tools for customer support, so we needed to quickly spin up a pretty complicated GraphQL API, and Pathos was part of that solution. It also is used internally at Netflix for a couple of APIs, but it also works great at really small scale. So I use it all the time for prototyping things. It is very fast and easy to set up and just kind of works out of the box without a lot of configuration. And so it's really great at almost any scale you can imagine. It's very flexible and extensible, so you have a plugin system to kind of add your own features. It has a lot of different patterns that it supports for how you can split up how you're building your applications. And then it is designed to work with your data. One of the common pitfalls when building GraphQL APIs is that you will either first design your API and then end up having to basically match your data to the API you've designed, and that can be kind of a painful process. The other way of doing things, which is probably worse, is that you'll build an API around your data and have your API look exactly like the data that you have in your database. This is really great at first, but it doesn't scale well as like your applications change over time. It's really important to be able to kind of have those pieces evolve separately. So Pathos is very intentional about making it easy to build an API manually that kind of works with whatever shape your data is in, and ensures that kind of the translation from like the way your data sources to how they're exposed in your API is clean and has good type safety, but doesn't kind of enforce a lot of constraints. And then obviously it works great with the rest of the kind of Node GraphQL ecosystem. So it's completely compatible with things like GraphQL Yoga, Envelop, Apollo Server, or whatever else you might be using today. So I'm going to jump into some code examples. Hopefully these slides are somewhat visible. I know the contrast isn't great, but let's get into it. So on the right, we have kind of a very simple schema that we're defining, and on the left is basically a fully functional GraphQL API built with Pathos. The first thing here on line 4 is you basically create a builder, and then you can start defining types. Here we define the query type, which is kind of one of the main entry points into any GraphQL API. And then we just pass in a fields function that basically just returns the set of fields we want to have available on the query type. Here we're just defining a single string field, hello, defining a string argument, and then a resolver here that returns hello to whatever name is passed in. And as you can see here, we're accessing the name property of arguments, which will be entirely type safe. And you'll get nice autocompletes as you're kind of accessing those properties. And then finally, we call toSchema just to generate kind of a standard schema. This uses the all of the kind of normal modules you get out of the GraphQL.js package. So this will work with Yoga or Apollo Server or kind of anything else. And that's a very quick overview of what it might look like to build a very simple thing with Pathos. But we're at the Prisma Day conference, so I want to try to quickly get into the actual Prisma plugin and what it can do for you. So the goal of the plugin is to make it easy to build with intention. I wanted to talk more about kind of problems with automatically generating your schema, your GraphQL schema from what's in your database. But these talks are fairly short, so I didn't have a whole lot of time to go into that. But the goal is to make it as easy as possible using the data you already have in your Prisma schema to explicitly define an API that kind of you control and design rather than just generating that automatically. So it lets you define types and fields and relations to other types. And then it will help you to optimize the queries that are actually executing and resolving to kind of surface that data to users. So GraphQL APIs tend to get very complicated and interconnected. And there's a lot of different ways a user might be able to query your API, kind of going through various relationships to load data. And manually defining queries that can resolve any query efficiently can be really challenging. So one of the big focuses of the Prisma plugin is making all of those queries as efficient as possible, and will generally result in queries that should be much more efficient than what you could write manually. And obviously, a lot of the easy cases are going to work great, but it also tries to expose some like building blocks so that when those easy cases don't quite work, you can still take advantage of some of these systems and still get great performance out of your Prisma API without having anything get too complicated. And then finally, obviously, this integrates great with the rest of the Pathos ecosystem, so you can still take advantage of all of the like validation and authorization plugins that exist. I'm going to dive into some more code examples here. This is a little bit more complicated and kind of shows how you might define a post type in Pathos, or with the Prisma plugin. So the first thing we're doing here is we're creating a new object type in our GraphQL schema for our post model. And then again, we just pass in a fields function that is going to define the fields that are available on that type. Here we're defining ID and title. I don't know if it's obvious what I'm highlighting. Hopefully it's somewhat visible. ID and title are basically just exposing some scalar fields. We use the expose ID and expose string methods here. These expose methods in Pathos are basically just a shorthand for defining a field with a resolver that resolves to like a specific property on the underlying data source. And so it might look like there's a little bit of redundant information in here, but with like the title showing up twice on these lines. The reason we do that in Pathos is pretty intentional. We want to make it always explicit what that you're mapping from one kind of source to another. So on this next line, we have a body field that is exposing the content column from our database. And this is pretty useful because oftentimes you want to be able to change the name of something, and you don't want to tie those things too closely together. The other thing that's interesting here is in our database, we're already defining the type of our content column that's going to be a string or some kind of text type. So we could infer that this should be a string in our Prisma schema, or in our GraphQL schema, sorry. You don't want to be able to change the type in your database and have that automatically reflect the change in your schema. And there's not always a clean mapping of your database types to the types that exist in GraphQL. So a string type might be a string, or it might be an ID in GraphQL, or maybe it's like a custom scalar like an email or something. So in Pathos, you're generally going to always be explicit about the types that a specific field resolves to.
Sorry to interrupt. There is an issue with your mic.
Oh.
I'd like you to just use that one, okay?
Great. Sorry.
Okay with the hands?
Yeah. Hope everyone can hear me now. I apologize if you haven't been able to hear me. So the next thing I'm doing here is defining an author field, which is a relation to another model. In this case, it's a user model. And then finally, we have a comments field. And this, if you've ever built relay compliant API, defining connections can get pretty complicated. So this is a pretty cool method here that will define a fully relay compliant connection, which basically is a way to expose like a paginated list of data. And all we're providing here is the ID column, which we're going to use as the cursor when we're doing that pagination. And on the right here, you can see that there's the comments field has the before, after, first, last kind of normal relay pagination arguments. And then there's a connection with edges and page info and an edge object and a connection object that all get defined for you automatically. And so all of this kind of shows you how you can define some types and expose some fields, but it doesn't really show you how we are getting data. So the next step is to actually start, is kind of where we get into how we use Prisma to actually start surfacing some of this, or querying this data. So in this example, we are going to be using the Prisma field method, which basically just lets us create a field that is going to be powered by a query from Prisma. And so again, we're just giving it a type of post because we're going to be exposing a single post, and then defining an ID argument, and then a resolver for that data, for that post, I guess. And so here we use Prisma post find unique, which is just an easy way to get a specific post. And then in our where clause, we pass in the ID that was passed in through the arguments. And then finally, there's this query thing we're spreading here. And this is where the Pathos plugin starts getting pretty interesting. So the query is going to automatically give us either a select or an include that basically defines all of the relationships that were queried by the user. So if the user requested a post and also asked for the author of that post or the comments, the author or the post relation are going to automatically be included as part of this query. So that's kind of what I meant earlier when I mentioned optimized queries. So the way this works is basically that we create this query object and then recursively walk down through the selected fields in our GraphQL selection, in like the incoming GraphQL request, and see what fields were selected, and then map those to relationships that are defined in our Pathos using the Pathos plugin. And then we kind of merge that all down into a single query object that can then be spread into a Prisma query to automatically fetch all of those relationships. If you've ever seen libraries like Prisma Select or Pal.js, this might sound familiar, but this works a little bit differently. There are some fundamental problems with how Prisma Select and Pal.js solve this specific problem, and it doesn't work well with things like aliases or arguments. So when you're selecting these nested relationships and you're either aliasing a field or the relationship, like the comments connection, for example, is paginated, having those arguments as part of your API makes it much harder to figure out exactly how that relationship needs to be resolved. And so that's why this plugin, this kind of deeper integration, is maybe a better solution than some of those libraries that don't have as much understanding of exactly how your schema is built. And so to describe that a little bit further, or give an example of how this can actually play out in practice, I'm defining a user object here that has two fields that use the same relationship. So there's a drafts field and a posts field that are both exposing data that is based on the posts connection in your database schema. So drafts here are going to be passing in a query option where basically we're saying, hey, this is a relation to the ships to the posts, but only the posts where the status of those posts are drafts. And this is kind of powered by Prisma, so all of these types here are kind of match up to the things that are available in your Prisma schema, or when you're using Prisma to query for a post. These all the options here should be fairly similar. And then similarly here for posts, we're defining an argument where we're passing in the status, and then we have these arguments and creating some selection, but this is also a related connection, uses the related connection method, which is going to handle pagination. So on top of the where clause here, we'll also have a cursor and some limit option that will also get added into that query. And so if you're familiar with how Prisma works, you probably know that there's not a way to select the same relationship multiple times in a query today. And so we can't automatically include both the drafts and the posts as things that we're going to query in that optimized query. So in that case, what happens is we first look at the drafts query and include that in the initial query that gets run. And then when we try to resolve the post thing, we know that the posts that were queried are going to be the drafts and not the posts that we're trying to expose here. So rather than trying to just return the data that was returned for in the post column, we're actually going to, I have some weird ordering here. Look at the user, kind of the type. And so this is a relationship on the user type. And so what we're going to do is reload the user type, basically do a find unique query with Prisma, and then include the post type and kind of automatically issue that, basically, and do a select, and then pass in this where clause along with the pagination information. And then once that resolves, it will automatically return things. And this kind of serves as a fallback for a number of different cases. The kind of collision case where you have multiple relations for the same thing is pretty uncommon. But the same pattern also applies if, for example, you forget to spread that query object in and don't actually issue the query that has those fields pre-selected. Or there's a couple of other kind of edge casey things. The overwhelming majority of the time this doesn't happen, but the Pothos plugin tries very hard to make sure that all of these cases are supported. These queries also end up being very efficient for a number of reasons. So we have, we query using find unique on the parent object, which allows us to resolve multiple relationships with one request. And then Prisma also has an optimization when you use find unique that allows you to automatically batch multiple queries for multiple users into one request. So if we're in like an n+1 type of situation where we had a list of users and we're trying to resolve all of their posts, those will automatically get batched into one thing. And there's a number of other optimizations here I don't have time to go into, unfortunately, but hopefully that gives kind of a rough overview of how some of this works. I've got a couple of, I'm running out of time here, so I'm going to go through this very quickly, but there's some other cool features I want to just mention briefly. When you're defining an object type, you can define an include on that, and automatically when you define a resolver, you'll have access to those fields that you're including on the object type. Let's see, we've got, you can do something similar rather than defining stuff for a specific object type. You can basically have selections that only get added in when that specific field is queried by the user. So here we have a profile bio that we want to expose directly on our user type, but it goes through kind of a nested selection. So this is a field that does a select of that bio field, and then this in an entirely type-safe way gives you access to that user profile bio field that you selected above. And then finally, there's a select mode. So by default, when you define a type, it just loads all of the columns for whatever type you're loading. But you can also put it into a select mode by defining like a default set of fields you want to select. Here, we're just using an empty selection. And then you can expose whatever fields, even if they're not part of that selection. But then if you define a field that has like its own resolver, you just specify the fields you want to select to be able to resolve that field. And then it will let you do that. Basically give you a resolver that can resolve those fields. And all of this is kind of type safe, and those selections automatically get merged together into that same single query. Let's see, there's also relay nodes, which I didn't get a chance to mention. Variance allows you to find multiple types based on the same model in your database, so you can do that. You can add counts on relations and connections. I'm just going to skip over that because it's too. And then, oh yeah, composite types are something that I haven't had time to support yet. So all of you who are excited about the new Mongo features, I'm going to be supporting composite types in Pothos as well soon, but I haven't gotten around to it. And adding some new features for input types, filtering, sorting, better docs, and some helpers to make some basic CRUD stuff more easy. Currently, it's a little bit complicated. There's a lot of manual stuff you have to do to set up a CRUD type API, and I don't think generation is generally a good solution, but this might be helpful for people building quick prototypes and things. And I think that's the end of my slides. So if anyone has any questions, just let me know.
We'll keep going. If you have questions for Michael, you know where to find him afterwards, but he would love to take some. Michael, thank you so much. It's been amazing to watch, just as technologies have changed and evolved, how you can move types, from your database to your back in your API, working in the client, and all that feels seamless inside of your code base. So tools like Pothos have been amazing if you're working in full stack development. So thank you for that. And then also, you may have heard about the serverless dream, but did you know about serverless heaven? So Hassan is going to come and talk to us about serverless and the work he's been doing in his company with serverless. So please welcome Hassan. Thank you.
I need the HDMI thing. Yes. All right, perfect. Well, hello everyone. My name is Hassan Bezzi. I'm from Tyre, Lebanon, which is a small Mediterranean city. It's actually the 4th oldest city on the planet. And I'm here to talk to you today about serverless heaven. So about 35 years ago or so, Freddie Mercury and Queen got up on stage and in 20 minutes gave the crowd a touch of the heavens. Now, unfortunately, I don't have maybe 1% of Freddie's skill or his entire band, but what I'm going to try to do here is give you a little touch of a different kind of heaven, a serverless heaven. So first of all, let's kind of bring it back to the basics. What are we? What do we do? We're developers. We're building experiences. We're building products. And at some point, really, that is what really matters, right? I've been building products and websites since I was about 12. I started basically hustling websites in my little town back in Tyre, and that's really all that mattered. And anytime I would try to overcomplicate things or try to explain, like, I actually remember a story once where I was 13 years old, and I was trying to learn like Cold Fusion or whatever, because it was cool at the time. It's some PHP thing. And I went to this, actual person at a store. He had a DVD store. And I was selling him a website. And I'm like, yo, you're going to have a Cold Fusion website. And the person looked at me like, what is this kid talking about? Like, I just want to sell my stuff online. So what we're doing is we're building products that people love. It doesn't really matter how we get there. It just matters that we build them. So this is what a product journey usually looks like, right? You're trying to ideate. You're trying to come up with whatever you want to come up. You're working on the design. That can be a database design in terms of actual data, or it can be UX, whatever it is. And then you're developing, right? Like you're writing a bunch of code, beautiful code, preferably written with Prisma. And then you're scaling it, right? Like you're grabbing this code, and you're like, OK, cool. We built this for 5 people. Now 5,000 people are here. What do we do? So the problem with this is that on that 4th step, there's a giant amount of FOMO, or fear of missing out, right? There's always something new. There's always a new framework. This was and is always the case also when you're developing your actual code. But in scaling, there's always a new, better way. There's Kubernetes, or you have to shard your database, or all this stuff where we feel as developers like, oh man, I go to a conference and I feel, oh no, I know nothing again. I have to learn stuff all over. What is this cube thing? What am I going to do? Everyone else is better than me. the reality is that's far, far, far from the case, right? We're all, again, building these beautiful products. We're going through this journey. And so how can we turn this FOMO, this fear of missing out, into JOMO, or a joy of missing out, right? I want to wake up one day and say, I am so happy that I actually don't know any of these things. I want to wake up and say, oh my God, I am so glad I know nothing about Kubernetes. Nothing against Kube, by the way. I actually love it, but it's just a good example because everyone's always kind of talking about it. So how do we do it? And what's the point of basically ignoring all of this, right? Thomas Gray once said, when ignorance is bliss, 'tis folly to be wise. What he was basically saying is if you can ignore something, then it's not just bad to worry about it, it's foolish. It's foolish even to be wise about it. So if someone has solved your problem, it's okay, just let it be, right? So what does an ideal product journey then look like? So 1 and 2 don't change. You're still ideating. Obviously, we can get so much better at this. But then once you get to number 3 and you're developing, we've gotten really good at this. We have amazing frameworks, Next.js, Redwood.js, like the list goes on and on and on. And these frameworks, they don't just allow you to write good code, they take care of all the quote-unquote DevOps steps that kind of have to happen afterwards, right? You write a little bit, and then they just take care of all of it. So why can't we just have this in the scaling world, right? I want number 4 to disappear. I want that to be the repeat place where I can keep iterating on my product. I can keep making it better and better and better. And I don't have to worry about, now that we've built this feature, we have to worry about scaling it for another 3 months. So let's take things back to basics just a little bit. And we're going to talk about the mental models of scale, just very briefly. So I very proudly stole this graphic from Vercel's website. Sorry, but it's a really good one, and the credits are there. But this graphic really shows you a form of horizontal scaling, like the classic way of doing things, right? And let's kind of simplify it big time. Let's imagine you are at airport security, right? So you're at the airport, you're going through security, and there's usually more than one lane there, right? And then people start to flood in because, I don't know, there's like 5 flights going on or something. And then one of the officers says, OK, we have to open a new lane, if they can, right? And then they begin that process of opening that lane, and they bring a bunch of people off of their lunch break, blah, blah, blah. Now, the problem with this is if they open that lane too early, then you're paying a whole bunch of people so much money, you just wasted a whole bunch of resources, right? So basically, if someone's there and they, let's say, put a threshold, they put a line somewhere and they say, once we have 10 people waiting, we open a new lane. You don't really know how fast people are going through security, so maybe by the time you've opened this new lane, the problem is not even there anymore, right? And then if you open it too late, you're going through a whole lot of congestion. And you almost basically have to be lucky. It's the same thing really in a lot of these horizontal scaling solutions. Yes, we're getting better, we're getting smarter, but at the same time, really, we're just kind of relying on CPU and memory for the most part, right? Memory's at 70%, spawn a new server, blah, 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 right? So how can we truly make things easier? Now, I'm going to just spoil the whole thing. I think that's the solution, right? Serverless. But what is serverless, and why isn't it terrifying? Every time I talk to someone about serverless, it's like the new Kubernetes, It's like, oh my God, what is serverless? Why isn't there a server? What am I going to do? So folks, it's simple. First of all, there's a server. Don't worry. But let's just kind of put this to rest. So serverless is super, super easy. You're writing a function, which, again, who cares that it's a function? You're writing code, right? You're writing code somewhere. It doesn't have to be a single file somewhere. Don't worry about that. Write code the way you would normally write code, right? You're just writing. And then a server is actually running somewhere with your code on it. So it's the same thing. And this code you're writing is scaling infinitely, right? So every time someone comes in to your website or your app or your service or whatever it is, it's scaling up. And you don't have to worry. about all the actual orchestration and all the infrastructure and all the real scaling that's going on in the background, right? So that's it. In layman terms, thank you, Cube, again, someone is doing the Kubernetes for you. It's amazing, right? Someone is there worrying about all of this, and you don't have to worry about it. So again, to take this from Vercel, it's simple. One request comes in, and one invocation happens. And if we go back to the airport security model, another interesting thing happens there. So imagine you walk up to security, and then a magic lane appears. And that gets invoked in a split second. Like, this magic lane allows you to get through security, and you're good to go. And then OK, sure, there's maybe, let's say, a second for this lane to be built, but it's still pretty fast. But let's say someone comes right after you, and those few lanes are there. Then they can just reuse your lane, because it was just there. The same exact thing happens in functions, or what we call usually cold boots and hot boots. It's, when you hear these words, they're not scary. All that means is someone has recently used this function, so we invoked it, we did all the hard work, right? And now we're just going to reuse it because some other visitor or user is coming in. Again, you don't have to worry about this. And going back to airport security, imagine every time you go to airport security, you have your own lane, your VIP, right? Now, cool, you're sold, you're convinced, but as with everything in life, there are caveats and best practices, right? And the thing is, I always hear this. I always hear, if you do what you love, you will never work a day in your whole life, right? But have you actually tried deploying to serverless? Now, here's the problem. The problem isn't that it's not good. The problem is that you get all these high hopes and dreams that I just sold you. You go like, oh my God, this is great. This solves everything. And then you go to your favorite cloud provider, and you sign up, and you get your Lambda, and you start using that cool word, which it is cool. And then things are slow, or they don't work, or things are hard to debug, or you're dealing with databases in serverless, or any form of stateful event. So again, how can we bring the joy of missing out to this same problem? And it's simple. Have the super smart people. I'm not even going to call it super smart. People who are getting paid every day to just solve this for you. Let them solve it for you. And that is what people are doing in serverless. There's a bunch of people that are very good at scaling databases and sharding them and all of this, right? Let them do it. And then all you have to do is write your code. So let's talk about some of the challenges. We already spoke a little bit about cold and hot boots. We'll talk about them in a little bit. You have a bunch of size limitations to work with. You're basically sending someone code and telling them to run it somewhere. We'll talk about those. Working with databases, debugging is an interesting issue on serverless. Native APIs are not supported. What does this mean? That means if you're trying to access like the file system, you're not going to be able to sometimes. For example, in Vercel, if you're using a serverless function, it's fine, you can do it. If you're on the edge, you can't. It's the same thing with Cloudflare workers. And then you have limited execution time. So you need to get your whatever work you need to get done, like come in here, you have 15 seconds, get it done, and leave my server kind of thing. But I'm going to take care of everything for you. So how do we deal with all of this? We're going to now go into an example, right? I promise this is not a paid talk, but I'm just showing you what worked for us at Nuna. So at Vercel, the idea is that it just works. I'm not going to bore you and go through how to set it up, right? But I'm going to go through some best practices that we've gone through that are very important, like that are going to make your life easier. First of all, caching. So one of the most important things you have to do is caching your endpoints, specifically any GET endpoints, right? And it's pretty simple for the most part. All you have to do in Vercel is add usually a cache control header. And there are so many things you can specify within this cache control header. One of the most important is the max age. So how often do you think this thing is going to expire? And then another thing they use is something called stale while revalidate. If you're in the front-end world a little bit, this is just like a service worker. It does things. That's usually the caching strategy in service worker. What that means is if something's in the cache, give it to the person. And in the background, go check if it changed, right? So for example, at Nuna, we have a bunch of tools. They're therapeutic tools. Did I even mention Nuna, by the way? So I'm co-founder at Nuna. It's a mental health app that helps you with stress, anxiety, and depression, right? It's simple. But the idea is, at Nuna, we have these tools, these mental health tools, right? And these tools are controlled by our psychologist. She changes them every, 2 weeks, 3 weeks, whatever it is. So I don't have to keep hitting the database and grabbing that all the time. So stale while revalidate, what that's going to do is it's going to give the user the latest tools, and then right after that, it's going to say, hey, Emilia, did the tools change? Or the database, basically. If it changed, cool. The next person's going to get the latest tools. Now, the next thing is, this is one of my favorites, Vercel Dev. Why is this awesome? Because developing serverless locally, usually you start developing, and then what happens is you deploy something to the cloud, and it doesn't work. So what this does is it just mimics the cloud environment locally for you by actually running your code in the serverless environment, right? So your code is literally being ran on serverless and then being piped into your local machine. All right, cool. Next, size matters big time. So first of all, the most important thing when it comes to size mattering in this case is that when you have a whole bunch of code, so you have this giant bundle, that code still needs to be parsed and gone through. So people, for example, say, oh, my serverless function is taking 4 seconds to have a cold boot, right? And a lot of times, it's simply because it's huge. So how do we eliminate this? First of all, when we're talking about Vercel, again, in a serverless function, we have a 50 megabyte limit. Now, you might be excited. Oh, my God, I have so much to work with. It actually is, but don't use it. Try to keep your serverless functions as small as possible. Now, luckily, Vercel does some of this heavy lifting for you. We'll talk about it. But one of the most important things you should do is only importing what you need. So all of you out there doing import everything from Firebase, don't do it. It's massive. You're going to have a slow serverless function. If you need auth, just import the auth part, right? On Edge, you have a 1 megabyte limit. So that's even less. And this means this code is running right next to your user, which is amazing. And there are no cold boots at all. But again, they're limiting the size. One small caveat, by the way, about if you're using Vercel on the edge and you're using Prisma, like we are, you should be importing Prisma client edge. And what that's doing is it's basically doing things where it's no longer accessing the file system at all, just so it works. You'll probably just run into this error. It'll actually tell you, like, hey, you're importing the wrong thing. But I spent like a good 30 minutes figuring this out. So, and then finding alternatives. So this is interesting. When in the front-end world, so I originally was a Preact.js maintainer. And Preact.js is a tiny alternative to React. It's 3 kilobytes. And people would go like, one of the Preact maintainers are here. People would go like, why would you do this, et cetera? And we're like, well, we need to deliver less to the people and still have the same functionality. And then when we would talk about the backend, people just wouldn't care. Who cares? I can import whatever I want. Well, now it finally matters. So find alternatives, small alternatives to libraries. Luke Edwards, for example, is an awesome developer, and this is pretty much all he does. If you go look at his work, it's like, oh, you need a function that does this? Cool, I made a 10-byte alternative to it. And then when it comes to the heavy lifting, so Vercel is going to do your tree shaking, which means if you import just the auth from Firebase, it's going to only bundle that. If you import just that one function, it's only going to have that in your final Lambda. And then it's going to bundle stuff. Why does this matter? Again, if you're trying to build serverless on your own, you have to figure all of this out. You have to figure out that, oh my God, I have 10 functions, and a bunch of people are coming in, and they're calling, let's say, 2 of them. And every once in a while, someone is calling that third one, so that one's always cold. So when Vercel thought about this, they're like, oh, OK, cool. Let's bundle them all within limit, right? And so when someone comes to any of your functions, the entire Lambda is always going to be warm. Super simple stuff, and they do it really smartly. Something that's coming to Vercel soon is also screenshotting code. So screenshotting your initialized code. So once you hit that, again, initialization code of a cold boot, they're just going to take a screenshot of it and just run it in the future. Again, the goal is to make these cold boots as low as possible. And then their support is awesome. So again, if you're struggling with this, this is what us personally. Like I would go like, I have no idea what's going on here. I would open a ticket and an actual engineer would go through the bundle with me. This stuff is there. Again, use it. And we're on a team plan. We're paying like, I think, $60 a month or something. Doesn't make sense. So then, choosing the right region. So when a user comes in, right, so let's say they're in the States, and then they're hitting your serverless function, and basically that function, again, lives somewhere. So let's say it lives in Europe. If your database then, I don't know, is in Shanghai, you are going to deal with lots of latency. And you have the option of specifying region in almost every provider, right? So for example, in Vercel, you can do it. You can say, hey, you know, my database is in Ireland, so I'm going to choose Dublin, Ireland as my serverless function location. That means those real servers, it's not serverless, are there. Cool. And then working with databases, and I have a minute. This should be fun. So connections. When you're working with databases, you have a whole lot of concurrent connections that are happening, right? And you have a limit to that. So for example, on MongoDB, you have a limit of 500 concurrent connections, even if you're working with Mongo serverless. So this is where you should use things like the Prisma data proxy that Søren talked about. And then there's schemas that you're dealing with. And then you also want to be scaling, right? So how do we solve all of these? Prisma Cloud comes in here, right? You have, again, the data proxy that's pooling your connections. You have the data explorer, so you're easily able to explore your data. And on top of that, it has environments built in. Why is this important? I can go into data proxy, and I can easily switch right then and there. I don't have to sit on figure out the connection strings every time, and what am I talking to, and who's talking to what. And then MongoDB support means I don't have to worry about migrations, because MongoDB is pretty much schemaless. Again, my goal is to not worry about anything. I just want to build products. I just want to deliver mental health to people. That's it. So, and then you have preview deployments. This is something coming soon in Prisma, where right now, when you are developing something in Vercel, let's say, and you make a new pull request, right? It does a preview deployment. Super cool, right? But then the problem is, if you've made a schema change, let's say, it's not going to work anymore, because all of a sudden, it's talking to a different database. So what preview deployments for databases will do is it'll give you a new tiny database to work with. And then projections, which are basically going to project your data to things like Elasticsearch as they change. So last bit, at Nuna, we've also chosen to go with MongoDB serverless. What's interesting about this one, I mean, again, it's not serverless. There's an actual Mongo thing going on somewhere, right? But they're scaling it. They're taking care of security. You're on the latest Mongo, blah, blah, blah. The concurrent limit is still there. So just because you're using MongoDB serverless doesn't mean you are not going to need to use the proxy. And then with the proxy, we're getting all the cool Prisma stuff. And that's about it. So again, Nuna is our mental health app. Check it out when you get a chance. And thank you so much. Oh, yes, Q&A, anyone? In the back.
Can you get a little bit more into detail about when to use serverless versus edge? Because some things seems to be fuzzy there, and it's not, for me, clear when one would be a good case and when the other one would be.
Sure. So on serverless, you're basically, with serverless versus edge, one of the main things that you're worried about are basically these different limitations. First of all, edge is brand new. So it's something that is coming out right now on Vercel, for example. So it's still in beta. Now, one of the things that you're going to be dealing with is execution time. So on serverless, you're going to have like about a minute to do things. On edge, you have 15 seconds, so it's a lot less. Another one is size. So you have a 1 megabyte bundle. There are some things that are just really hard to get under that sometimes, depending on what you're doing, and you're going to have to go with serverless. Another thing is working with distributed databases. This one is way more complicated, because now you're basically going to have to worry about when you're reading to the database, when you're writing to a database, and if something happens before something. So in general, edge should be used for more, let's say, authentication, endpoints. These are usually very easy to go with edge with. Just like anything that can be very, very simple for the most part. What I know for a fact, though, is the Vercel team is trying to get the functionality of edge, so the quickness of edge, if you want to say, out into the public. So yeah, I don't know if that answers the question, but kind of, yes. Anyone else? Cool, amazing. Yep, we have one more.
How do you limit the amount of the requests that's run? Because when there's a billion requests, you're the one that ends up paying for it. How can you prevent like a DDoS costing you a lot of money using serverless?
Yes, yes, you can. So there's a lot of built-in support with most of the serverless providers. For example, again, I'm just saying this because I know it. With Vercel, what they do is in that first, I think minute, I'm not sure what it is. It's like minute or second. Once their DDoS mitigation comes in, anything after that will just be discarded from your bill, right? So, but excellent question, because yes, you're not going to have to pay for anything as long as like they know, okay, cool, like a DDoS happened. There's a lot of mitigation there that's happening. I think it's the same on Cloudflare as well. They do a lot of this.
Hassan, thank you.
Awesome.
Thank you, thank you. Please, another round. If you have any more questions about serverless, the lunch break will be coming up next. Please find Hassan. And serverless, something that's been amazing with Prisma is seeing applications that can switch back and forth if they need to try different architecture without having to switch anything on the ORM query side. That's been a real advantage, as I've noticed with a lot of startups. So next up, we have Ollie. And who I learned last night, did anybody know you can, in North America, you can just start your own telco? I didn't know that was a thing because I don't necessarily like my telco, but you can just start your own. And so I just learned that last night. Thank you, welcome, and excited to hear more.
Thanks, David. All right. Hey everyone, my name is Ollie. I'm head of engineering at Oxio. And today we'll talk about something that everyone hates, which is telecom companies. All right. So the title of the presentation is Using Prisma and Other Web Tools, Web Technologies to connect any Canadian household to the internet. So first, what am I doing with my life? That's a question I want to answer a lot of times. But 10 years ago, I learned to code with a bunch of friends by hacking online poker platforms. So I count on you not telling my mom. That would be not super cool of you. And on the right side, you can see one of the bots. Oh, so you can't actually. So you cannot see the slides, right? So in the meantime, I'll say that American MCs are the best. All right, that's good. So that was the title of the presentation, Using Prisma to Connect Any Canadian Household to the Internet. And then about me, really quick. 10 years ago, I started to code by hacking poker platforms online. It was a great way to learn stuff. Not really glorious, I would say, but on the right side, you can see a bot called the George Cantor 1. At that time, it had 4 jacks, which is pretty handy if you want to win online poker games, I'd say. After that, I moved to real jobs. So I wrote software for brick-and-mortar stores, law firms, factories, and now the telco industry. So I think you see the focus here. So my focus is really about automating old industries, so industries that have a lot of low-hanging fruits, and that just basic automation can have a huge leap in these industries. So quickly, what is Oxio? So Oxio is a digital ISP, so an internet service provider in Canada. Digital means that we don't own the last mile infrastructure. We'll talk about it later. And we are a provider and also a software company building automation software to help other ISPs around the globe to automate their operations. So we are not offering this software in Canada because telco is war, so we don't want to fuel our competitors. You'll see you have a lot of context about this industry a bit later on. So the Canadian ISP landscape. In the past, there was a monopoly, and prices were super high for average speeds. So that's not good, first. The sad thing is, though, that networks were subsidized by the government. So you have super high taxes, it pays for the networks, and then the monopoly leads to you having to pay super expensive prices for your internet, and you cannot just not have internet, so you pay it anyway. People were angry, of course, and I'm sure you would have been in that case. Now, it's a bit different. So there are laws and regulations that force ISPs, which we call incumbents, like the big players, to rent their network to other operators. The other operators are called competitors. So that being said, prices are still high for average speeds, and people are still angry. And we'll see why a bit later. These are reviews from the three biggest telcos in Canada. So I would say that people are typically 90% angry. A bit of context. So let's talk about the value chain spectrum. On one end, you have the network. So like the network provider. Really, it's a spectrum in the sense that you could be both a service provider and a network provider. But if we look at the extremes, a network provider could only choose to roll out networks across the country, across the regions. They would have super high entry costs. You have to purchase fiber optics and cable. But your margins are super high because you just rent these infra to others, and not much operation expense. So what we call the last mile infrastructure is actually what connects the homes to some data centers across the country. So the last mile is really from all the houses to a couple of data centers. So we don't have, as a digital service provider, to roll out networks from those places. We only connect from the data centers to the internet. So which means the digital ISP is their expertise is business to consumer. So it's about serving the customers, innovating in terms of services, and you'll see a bit of examples later on. So entry cost is super low compared to the other end, which is the network provider, because you don't have to roll out infrastructure. On the other hand, you have lower margins because you rent your network from others. And that's where automation is super important to make sure you are super operationally excellent and that you can lower your expenses. So you can see the network provider a bit like AWS in a sense, because they would have all their own physical infra and they would rent it to others. The digital ISP is building services on top of the networks that already exist, right? So please understand how bad the software world is in telco. So no Canadian ISP has ever built their whole business and operations software in-house. So they see themselves as a network company, and they don't see any advantage in building software. They see software as something that's kind of alien, that it's from another industry. So they would typically purchase a whole monolithic software that would, either one big or a ton of small ones, and then twist their operations, their day-to-day operations, to fit this software. So another weird thing is that, let's say you are a digital ISP, you are using someone else's network. By the law, they have to provide the network to you to create competition because of the X monopoly that there was. But the law only states that they need to give you some kind of access to manipulate and communicate with the network. In fact, they will never give you APIs to communicate with the network. That would be too easy, of course, and that would create too much competition. So the expectations are that as a digital ISP, you will have new subscribers coming in from your website. You'll take all this data, input it in some kind of form online from the network provider, and on their side, they'll grab this data and have another human input it in their own system. So you have a huge flow of humans inputting stuff from A to Z. So that's so every operation of the network must pass to on a form like this, or sometimes it's templated emails. So if you send an email to this address, and it's well formatted, it will like change the speed of a customer or activate someone or change the modem and so on. So I guess you can see how old school this is. So then how do you compete against the big guys when everything seems a bit rigged? Well, you start by automating everything. That's something that's a bit obvious for probably all of us in the tech industry, but in the telco space, that's out of this world. So here we have an example of, I don't think you can see really well, but that's a GraphQL mutation. It's called start internet activation. And you've provided the customer info, so like the address, the name, and you provide like what speed the person wants, and what's the device info. So we want to give him like this modem with this MAC address. And this simple mutation allows to connect anyone in Canada to internet. So in this industry, that's a complete game changer because you abstract really, you have an interface to connect anyone to any network available in there. Here we have some kind of slide to visualize how it works. So you have the houses on the bottom, and those are connected to one network. I'd say one or plus, but since there is a monopoly or oligopoly, there is no overlap between networks. So some house could be connected to Cogeco, some to Rogers, depending on the region. And then those networks, they give you portals or email templates if you want to interact with the network. So that's where the Internet API, that we call it, comes in handy. So it's really the GraphQL API that abstracts everything to connect customers. So we have bots on each web portal, and just to like reverse engineer HTTP calls, craft sessions, and so on, just to make sure that there's no human intervention in there. So if the customer or a customer care agent wants to like activate some new customer, change their internet speed, change the modem, and so on, they go through some basic UI that calls this API, and everything is like pretty easy for once. So step 2, how do you compete again against the big guys? Basically with crazy short time to market. So you could imagine that, let's say there's a new service that's coming out, like satellite internet. You can pretty much imagine that the big players will not have it available, make it available to customers like in a few weeks. It's normally a matter of years, to become available to the public. So that's something that by being a tech company, by building our own software, we can just pretty much do everything ourselves and operate fast. So basically, we focus on tools that basically just work, that developers love to use, that developers are super productive using, and most importantly, I think that we already master. We don't have kind of time to like rebuild the query builders, ORMs, CSV parsers, and so on. So we stick with like Prisma, GraphQL, React, TypeScript, and tools that like have a huge community that are already like well implanted in the industry. So that's kind of a crazy example here. So a few guys at Oxio said, could be nice to support crypto payments. I mean, it's a few months ago when it actually was worth something. A lot of customers wanted to pay using crypto. So we made a proof of concept in 2 days, just hacking around. We tested it with a few employees, and then GA was 1 week later. So if we think about like how our competitors see that and how they'd be able to do it, it would have been a matter of months, if not years, to just have all the legal setup and all the approvals of all departments to roll out something that's kind of simple in the end. Step 3. So how do you compete when you're a tech company and that others are a network company? Well, expansion is super complex for those players. They have to roll out networks to other regions, and if they are not like automated and they don't have like a lot of software, there's a lot of implications for them. So we can think of like, so there's a new region, so there are new tax codes. We need to support new devices. So the billing software needs to be updated. We need to activate customers via a new web portal that we need to automate, and so on. So there's a ton of stuff in there that needs to be done on the software side. So if you don't own the software stack, which is the case for all other ISPs, you're super limited in your growth, in your agility, your innovation capabilities, because like at the end of the day, if you don't own the software and you cannot like update it, maintain it, and operate it, you'll have to plug in together a ton of stuff. You'll call your consultants to make a change request or a feature request, and it's a matter of like months or years to be able to come in a new region and operate there. So a short time to market really is, I think, the key differentiator in this industry and in many, many other industries, and that's where like startups are super good at. So the architecture to support quick expansion. So on our side, we have a microservices architecture. We have like 12 or 15 microservices. So I added a few of them. So like you have the analytics. So new region means monitoring the new network, monitoring the usage, monitoring like quality of the service. So you want to support new tax codes in the billing microservice. You want to support new devices in the inventory. You need to automate the new activation, and all operations on the network. So that's via the internet microservice. You want to ship to new locations. So you'll partner with maybe Canada Post, UPS, and so on. And you have to add new plans, new services in the product catalog. So that's a ton of software to update. And if you don't own and don't operate that software on a day-to-day basis, you're not in a good shape. On top of all these microservices, we have Apollo Federation to create like a super graph just to make sure that the front end doesn't know that it relies on 10, 12 microservices in there. And basically, we have two front ends here, which are React web apps. One for the customer-facing part, so the Oxio.ca website, just to subscribe to the services. And then for the Gaia app, which is the agent-facing part. So the agent-facing is like what the tech support and customer care agents are using on a day-to-day basis. Finally, each microservice, again, it's about like using tools that just work, that people are productive with, and that they love using. So again, all microservices follow the same pattern. So Prisma and Aurora for the database, Lambda with API gateway for everything everything serverless actually, and GraphQL for the API layer. And one thing I want to mention is that when we want to roll out our services to a new region in Canada, we have 2 weeks of lead time. So again, when we compare to competitors, it's about it's months. So which means customers waiting a long time in typically to have this service available. So in the end, what do Canadians gain? I guess they have access to the best services now in their region at a lower price. And all of this is via software, is via automation, is via web development. They have legendary customer experience, I guess, because they are kind of used to having to call their ISP, wait for 25 minutes or more, and to get told, oh, you didn't call the right number. So that's something of the past. They have self-serving capabilities now. They can go to some web portal and handle their connections themselves. They can change their plan, change their address, move to somewhere else, and keep their activation, and so on. And we think we might be like the first internet service provider that they will actually like, because have you seen 90% of people are super messed up and hate their ISPs. And another thing for the end, I guess, I think with software we are somehow used to go super deep in the tech and nerdy way. I say I worked a long time in machine learning, and it was super intense. And at the end of the day, there's a lot of opportunities to just find old school industries that really need to be automated, and that there are a lot of low hanging fruits. So if there are entrepreneurs in here, I beg you to tackle these industries, and thank you very much. Merci. All right, questions?
Yeah, hello. In the beginning, you showed that there were a lot of forms involved and humans putting data into the systems because there were no APIs. Did you then build the APIs, or did you build then a software, for example, that can control the browser and then fill out forms automatically?
Right. So we built the software to. So I think there's a slide. Not sure if you can see that one, but all the network. Oh no, that's bad. So yeah, we built bot for each web portal. So we started with Selenium, like a naive, use case. It was a bit too slow, so we ended up just reverse engineering the HTTP calls. So we can see we use our customer care agents to use the forms like they were using it as they are intended. So we record all the traffic, we reverse the calls, and then we just replay them. So we are able to just to know that if we want to activate this customer or change that speed, we need to send this huge weird ASP.NET payload somewhere with this and that header, and it will work. So it's really about bots that are pretending to be humans, and there's a lot of throttling and so on. So we need to be kind of smart in a way, because we cannot just bombard them with calls. Thank you.
So the situation you described in Canada, I think it's exactly the same here, and I guess in many other countries as well. Do you believe there's an opportunity to productize the software that you guys build and kind of use that in other markets as well? Or do you feel it's necessary to own your own stack, so the ISP, the operator, the telco company would need to build, maintain, operate, change the software?
We really think there's an opportunity there to provide our software to other ISPs and use it like we do, because we have a mindset of kind of a Shopify for ISP in a way. People could, the community could build plugins. So let's say there are a lot of networks in Germany. People could build their own plugin, their own bots to automate these networks, and have a marketplace where you can just get this plugin from there. So I think the community-first approach and the crowdsourcing the plugins is a way to make sure that it works in other countries and other regions, because otherwise we end up in the same situation where the ISP would just buy a monolithic software that doesn't really work for their operation, and they would end up in the same shit.
Hi, and thanks for the presentation. It was very inspiring about the amount of low-hanging fruit that there is in the traditional industries, so thanks for this. Just one question. When you make this draft to enable crypto payments, and you said you have something already working in a week, just out of curiosity, how big was the team working on this? How many people were involved in this task?
2.
Amazing.
I guess it's just about using software that you tools that you already master and that you like using. So if you're passionate about it, you'll code all night and it will happen pretty quick. Thank you.
Thank you, Ollie. Please, another round. That is well done. I live in a town of 600 people, rural, and we need that too. So come to us next, okay?
I will.
Pleasure. So learning some inspiring things. So one, connecting the dots between Prisma and these JavaScript Node frameworks that are out there, and that's a recurrent theme that we're hearing a lot. And again, from what I've seen, Prisma is becoming a de facto ORM and across the Node JavaScript ecosystem. And another thing, I love all the examples in the past 3 talks of Prisma in production, and has been in production for a while. I asked Ollie, fairly large company, I don't know if he talked about, but the subscriber space is large right now, and Prisma's backing all of that. There's another co-founder of Redwood here, Peter Pistorius, who's building, he's right over there, but Snaplet, been in production for about a year now, and running with Prisma. So Prisma's out there and working and empowering some wonderful startups right now. So anyway, Prisma team, well done. This thing is working so far. Okay, enough of me. We get to have lunch. Food's been all right so far, right? And I mean, I'm downplaying that. The food has been exceptional. So lunch is coming up now. And we'll have 60 minutes. We'll be back at 2 o'clock. For those in internet land, We're going to be back live again in an hour, but you can take a break too, whatever you need to do wherever you are. Maybe it's nap time or middle of the night. We'll see you then. I think that was it going into lunch. I'll remind you of many things. I have a bunch of hats though, so if anybody didn't bring a hat, do you need a hat? Yeah, I mean, it's sunny here. Here you go. So I'll have some more hats later. But if you didn't bring a hat, just let me know. The sun's going to come out this afternoon. All right, we'll see you all after lunchtime. I'm going to hit the photo booth if anybody wants to join me. See you over there. Got it? 1 minute. 1 minute till the presentations begin again. 1 minute. All right. The sun came out, right? Just like I promised. Welcome back, Internet Land. Welcome back, all of you joining us here in Berlin at a beautiful beer garden. The sun is out, and it's a gorgeous day. And the good news is, we get to stay all day. I hear there's even an after party, so we've still got time. We're not quite into the love parade mood yet, but we've got time to get there, right? It'll be a little bit. I introduce you to Josh, who's going to talk more about TypeScript, and we've got some wonderful presentations coming up for the rest of the afternoon. Sit back and enjoy. Josh, thank you.
Thank you very much. Thank you, David. Thank you, Redwood. Thank you, Prisma. Hi, I'm Josh, and to get us in the spirit of the Love Garden, I would like to take you all on a journey, a JavaScript journey, and we're going to do this together. But first, I'm going to take a selfie. 3, 2, 1, cheese! That was lackluster, but thank you anyway. All right. All the way on the left, we have a database floating off in the cloud somewhere. And all the way on the right, we have users. And this is pretty much every application, or most applications on the internet, when you get down to it. It's some fancy way for one or more users to write or read or do both in some database somewhere. Now, Prisma is fantastic. We all love Prisma, yay! It does all this stuff, or a lot of this stuff, that we need for interacting in our application code to database areas, the more back-end parts of the code. It gives us structure, it gives us safety, migrations, schema gen, all this stuff. But what gives us that safety, that lovely happiness, what was referred to earlier as productivity and confidence by Soren, in the rest of the application code, the stuff that touches users, that's not quite so Prisma managed? It can feel, if you're writing just vanilla or plain JavaScript, that the Prisma stuff is this lovely walk in the park where you have structure, safety, protections, and the rest is the Wild West. So in case you haven't guessed it by now, I'm going to say that we need the types of docs and safety in the rest of our application code that Prisma already gives us. And does anyone want to guess what technology, what language or framework we're going to suggest as using that for that? TypeScript? TypeScript and generics, yes, thank you. Hello, I'm Josh. We're going to be talking today about adventures in Typesafe Prisma clients using TypeScript. A little bit about me first. I'm an open source developer. I've been doing that for about 6 months. I focus on open source static analysis tooling in the JavaScript TypeScript ecosystem. Static analysis is stuff that looks at your code and yells at you without actually running the code. I also recently wrote a book, Learning TypeScript. You should all buy it. It's pretty good. Previously, I worked at Codecademy, before that Microsoft. Now I'm an independent consultant. Most of what I do is yelling at people about how they should use TypeScript and doing it for them. You can reach me on Twitter at Joshua K. Goldberg and on the internet, joshuakgoldberg.com. Paperwork out of the way, let's talk about the actual stuff. First, I introduced this journey that you have all embarked on with me, potentially against your will, sorry. Second, we're going to go over TypeScript. Why am I so excited? Why were several people shouting out TypeScript from the audience? We're going to talk about types generation, how Prisma, which, spoiler alert, is fantastic with TypeScript, does generate really interesting TypeScript code for us. We're going to go into generic types, the wonderful way that Prisma code gives us really strong type safety across all sorts of different models and queries, stuff like that. And then we're going to get into the fun part of the talk, the shenanigans, where I'm going to go over some of the weird stuff Prisma has to do. And we're going to end with a bit of philosophy, how to write types good. Is everyone excited about this? Are we ready? Let's do this. Yeah. Okay. Thanks. For the record, I did not have any of the beer at the beer garden, but I will later. All right, TypeScript. Why doesn't tech Twitter shut up about it? Why is this so popular? Let's take a look at this code. That's an excerpt from my book, Learning TypeScript, you should all buy it, called Paint Painting. Looking at this context this snippet of code without any context, we have vague ideas. We can really only guess at what it's supposed to do. What is painter? What is painting? What are these parameters? What is the result of dot finish? There's no way of just looking at this code and knowing what it's supposed to do. You have no confidence in your code. And there is this community standard that sort of has a spec kind of called JSDoc, where you can write comments from your code. First of all, JSDoc comes from JavaDoc. And if there's anything that should convince you not to use a tool, it's that it comes from Java, right? But also, there's no real specification. There's no enforcement of JS docs in JavaScript. If someone were to refactor this code to take in a string instead of an object for painter or painting, or vice versa, there's nothing enforcing that we also update the docs correctly. So you don't have confidence in these docs. They are sometimes useful, sometimes harmful. So you don't know what these parameters are. You don't know if they're accurate. You don't know if they're correct, if they're even the right names, and you don't know what, still, the return type of painter is. What is this painting thing? So here's a snippet of TypeScript code, and you don't have to already be a TypeScript developer to understand this. You don't need to understand it, but you do need to appreciate and love it, as we all do, that this type painter says that, okay, the painter has 3 members or properties on it. It's got a finish method, it's got its own materials, and it's got a paint. So we know what painter looks like, and fun fact, TypeScript will yell at you. It'll build fail if you mess this up. We know what goes into even this paint method, and we know what comes back out from finish. We know this returns a Boolean at the end. So this is great. This is TypeScript. It gives us the confidence and the documentation that we need. And I'm going to go over a few really cool features in TypeScript because I think it's just such a cool type system and because we need it for the talk. To start, union types. Now, a lot of older languages like C# and Java don't have this concept, but it's a really important one. Sometimes you have a value that could be one of potentially 2 or more different types. Let's say that you have something that's either a number or a string. And we could represent this with a union type, number or pipe string, where let's say we have a variable, and we can say assign a number or a string to the variable. But if we assign something else, Boolean, TypeScript knows that, OK, that's not on the allow list of allowed types. So that's the first TypeScript feature we're going into today, union types. The second is literal types. Union types are expanding the possible allowed set of types that a thing can be. Literal types restricts it. This bit type, which is shamelessly copied and pasted from a talk I gave that implemented binary arithmetic in a type system, this says it can be not just any old number. It has to be specifically 0 or 1. So if we have a mybit variable, we can assign 0 or 1. But anything else like 2, heavens forbid, not allowed. We can't do it. So we've expanded our allowed types, and we have restricted our allowed types with unions and literals, respectively. Cool. Are we ready to go to the next section? Yes. Thanks. OK, cool. Types generation. This is all actually useful and important stuff. It's not just cool, because Prisma uses it. So this is a Prisma schema. Show of hands, who here has used Prisma before? Not everyone raised a hand. Odd. All right. And this can be represented by a very structurally similar TypeScript type, which Prisma actually does in its code gen. When you ask Prisma to generate your client for you, it takes in your models and it generates client code. And it doesn't just generate the runtime classes, the user delegate whatevers, it also generates types for them. So fun fact, these types are not exactly one-to-one with what's in the model. This doesn't have a posts array on it. And we'll get into later about, well, these optional fields, how do they get loaded by Prisma? But the nice thing about these types is that the client code can be annotated with them. So in the, for example, user delegate class that Prisma generates, we have methods like find many and find unique. And Prisma's code tells TypeScript what these methods return. So same as the paint painting method from before, we don't have to take any artistic license with it. We know exactly what they return, promises of user or user array. Now, we're going to start talking about the types that go into these methods. For example, find many might take in an args type like user find, which here I've defined as a much simpler type. I know there are many features in Prisma not covered. That takes an aware object, which has, let's say, optionally ID and email. So that gets a little tricky sometimes, because right now, let's say you do const user equals await Prisma blah, 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 user find, or find unique. We now know that the type for the user is going to be ID, email, password, name. So this is immediately a key benefit of TypeScript, reiterated, this time with Prisma, that we know what comes out of our functions. Because the Prisma code gen does all this for us. You don't have to write your own JSON serializer, deserializer for the database data or whatever. This just does it for you. But there's some magic that goes into the types. That if you include, say, posts true, if you add in and include to your find, there is also going to be an extra property on the returned type. What? There is no way to represent this in most languages. This is a beautiful thing where you can have the input to the function change the return type of the function itself. Or in slightly more technical terms, Prisma method return types change on their arguments. Fun fact, the argument is the thing going into the function. The parameter is what the function declares. So this is the key thing in the talk that I want to go over, because I only discovered this relatively recently, and I think it's really cool. Like, how does it do that? How does it change the return type of the function based on the arguments? Generics. Show of hand, who here has written a generic function before? Who here has like sworn at their computer angry words based on that generic function? Still a good number of hands? Yeah. Thank you for raising your hands. I want to give you an example, again, shamelessly copy and pasted from my book. You should all buy it. For this identity function, if you were to try to represent this function without generics, you wouldn't be able to. It takes in an input and then returns that same input as output. We need a way to say that the function's return type is the same as whatever was passed to it as an argument, that the return is based off of the argument. And this is how you do it in TypeScript, and also in many languages, like C#, Java. You declare a generic. There's this T type, and this T type can be different for every instance of this function, every call of the function. So if you were to call it with identity me, the T would be the me string literal, or for those who don't work in a language with literals, string, and it would return that same type. Okay, cool. And you can have generic types too in TypeScript. You can say that there's this boxed type, which takes in a value generic. So if you were to say, declare a variable that's type boxed string, you could say box equals value head. But if you were to put some other type in the box, like the number 7, it wouldn't not be allowed. It would be a type error because you already declared it as a string. Shout out to anyone who gets the movie reference. Conditional types are where it really starts to get cool, and I think this presentation picks up a little bit again. You can add logic to your type system. Pardon me. I'm so excited I can't speak. You can have a type that says, I take in a generic opponent, and if opponent extends rock, meaning is this type usable as the other type, then the resultant output type is something else, let's say draw. And if otherwise the opponent extends paper, if it's paper, then the result is loss. Otherwise, the else, it's a win. So does anyone want to try to guess or infer the type of this against rock type? What would this result be? Rock matchup of rock. Shout it out. What was that? I couldn't hear you, but I think you said draw? Thanks. What's your name? Oh, I can't hear, so I shouldn't have asked that. I'm sorry. But round of applause for our friend over there who got it right. Thank you. And again, sorry, I can't hear anything. It's draw because, well, that's what the logic says. It's rock, so it's draw. Against paper, it's going to be loss, and then against scissors, win. Cool. So we have logic in the type system. And that logic is really important because we have already said that our goal is to be able to represent that the return type of a function is changed based off the arguments given. And fun fact, you can constrain your generic types. It's kind of like saying that a parameter is a particular type rather than any. Here we're saying that the opponent is only allowed to be rock, paper, or scissors. So fun fact, if you ever want to play rock, paper, scissors in the type system, first of all, don't. Second of all, this is how you could do it. Cool. So let's make this a little more useful. Suppose you have a function, trimmed length, which takes in text t, and t is allowed to be string or undefined. And you return the length of it after trimming it. That could be undefined if t is undefined, or it could be a number. So in this function, where we use an as cast to kind of massage the type system, we are saying, and I'm going to go over it line by line, this number if defined type takes in a t, and it says, if that t is undefined, then my result is undefined. Otherwise, then result is number. Which means in my trimmed length function, if we know text is going to be a string, then the result is number. Otherwise, if we know it's undefined, the result is undefined. So putting that all together, if we do trimmed length of undefined, again asking you to shout out, what would be our return type for this version of the function? Undefined, thank you. Oh my God. I'm honest, it's always worrisome giving these. You never know if you're actually explaining things right. Because undefined is undefined, it extends it. So yes, undefined. How about if we take in the string Josh, what would the return result be? T would be a string. No, string doesn't undefined. What is it? Number, or 6. Sorry, someone was saying 6. Yes. You didn't have to count out, but thank you. Cool. So if we then give it something that could be either string or undefined, T is string or undefined, which means it could either be undefined or not, which means the result is number or undefined. Cool. That is the limit of the type system shenanigans that I'm going to go over in this talk. Cool. So now we've exhaustively covered these features in TypeScript, so we can talk now about how to represent the Prisma types, how Prisma takes in function arguments and then changes the return types based on them. So just to recap, this is what we want to represent, that when you add include posts true, it includes the posts field. So this is a slightly rewritten version of our user delegate class. We find unique, which takes in a generic args type that must be a user find. And the result is user finds if, sorry, it is two things. It is both a user and a new type, add posts if included, which takes in that args type, and add posts if included args says, given an args type parameter, if the args has an include, that extends post true, meaning if args.include.posts is true, if it has posts, then we add in an object that has posts in it. If yes, add posts. And if no, then we add an empty object, an object with nothing in it. So putting this all together, if we await prisma.user.findUnique, don't worry, I won't ask you on this one. I see the lack of enthusiasm. If we find unique where we don't have a post, then the args is where ID string does not have an include, does not have posts, so we just have user find with nothing else. And if we have await user.findUnique with posts, then we do have include posts true, so we add posts. So this is good. We are checking our return types. But that's not all, because Prisma actually has features like include, post, nested, include categories true. So we're going to have to go through and write 4 to 5 levels of nesting in our. I'm kidding. We're not doing that. I want to instead switch over to the last part of the talk, type philosophy, because complex types are a simple symptom of complex logic. And I really want to emphasize this, that complex types, complex uses of TypeScript type system features are a symptom of your logic being complex. Show of hands, who really enjoys working with complex logic code? I asked this at the end. Put your hand down. If it's generics, yes. We have a joker in the crowd. I saved it for the end because fewest number of people will raise their hands. No one wants to work with complex code. And for generics, there's a golden rule from Dan Vanderkam's Effective TypeScript, which is a quote also from the TypeScript team. If a type parameter only appears in one location, strongly reconsider whether you need it. For example, we have the shout function, which takes in a t, which is a string. It only appears in one location after declaration. There's no need for this function to have a generic on it. We could have just removed the generic and switched it to an input string. So I want to bring up, there's this Gartner hype cycle concept that gets floated around where something will get really exciting and everyone will want it, and then they realize all the things you can do wrong with it, and then eventually we figure out, okay, it's actually good, not amazing. TypeScript has its own hype cycle. It's gone through this cycle, and I think we've leveled out as a community, as a web development space. But each individual human, you and you and you, every one of us, when we use TypeScript, will go through our own little mini type cycle. We start off, we realize, oh my God, I understand generics now. This is great. I can add 4 generics to a function and infer everything. It's beautiful. And then you realize, much as you did during this talk, this is incomprehensible garbage, and I can't work with this. It's terrible. But then, when you stop overusing generics, you reach a plateau of productivity. And you realize there are times for these complex things, and there are times where you should stay the heck away. So, because people only understand and remember in forms of memes, here is Drake. You should not hate on TypeScript for having complex types. You should recognize that there are pros and cons. And these pros and cons reflect the way that most architects want to architect code. Your app types should stay simple. We don't want to work with complex types. The library types. Prisma can have 12 levels of generics nesting in their code because Prisma has to do complex stuff to make it so you, the developer, don't have to do complex things. I actually really appreciate the talks earlier about how like you don't need to be the expert in everything. Let them do their magic. App code should stay simple, and library code should be complex only to assist you in your app code. Great. That's all from me. Just to recap, we talked about the journey we went on together, TypeScript, ? Types generation, generic types, how Prisma used those generic types, good stuff. If you want to learn more, TypeScriptLang.org actually has really good documentation. Props to their team. Prisma also has good docs on how they work with TypeScript, prisma.io/TypeScript. I wrote a book, please buy it. Also sponsor me on GitHub. I need your money to do open source things to make TypeScript world better for everyone. And most exciting of all, I'm doing a giveaway. Tweet at LearningTSBook and hashtag PrismaDay on Twitter about what you learned or wanted to learn for TypeScript to win one of 5 ebooks. So just to repeat, you could win a free ebook if you tweet at me. Yeah. Thanks. You've all won my affection and undying love. If you need a suggestion, I'm at PrismaDay and I want to learn TypeScript because something awesome, learning TS book. Okay, cool. Thanks, that's all from me. I hope you enjoy the rest of the conference and the beer. Cheers, everyone.
Good work, Josh.
Thank you.
I confess I'm a TypeScript consumer mostly, but you're inching me closer. That was good. So thank you. If you have questions for Josh, please catch him at the next break. He would love to answer it, or tweet at him on the Twitters, right? Is that how they do it these days? So that's good. Thank you. We're going to move on to one of my favorite topics, which may not be your favorite topic, but coming up, Nilu and Lucy from Prisma. And actually, I'm going to pause them right here because documentation is one of the unsung heroes in the world of software and code, and I'll grab that for you. Oh, actually, I think we have, I'll let you take it. And it often gets unpraised, but Prisma documentation is fantastic, and at Redwood, Prisma is such a key part of the experience of people learning how to work with the framework that it's a pleasure to point people to the Prisma docs, and it's seamless experience, and people rave about it all the time. And secondly, the people that create the documentation often don't get the credit they deserve. So you're about to hear from 2 people behind Prisma Docs, and I love that at this conference there is a talk on docs, because documentation, without it, the code just isn't as good. So Neela and Lucy, please take it away.
Hello, everyone. I'm Nilufar Bawa, and this is
Lucy.
And together we'll be talking about how we make Prisma docs effective and engaging. Yeah, so starting with Lucy.
Hi, yes. So as you've worked out, this is a joint talk between Docs and WebDev. So I'm a technical writer at Prisma. I'm fairly new to it. I previously worked as a software developer. So I'm still sort of getting my head around how Docs works, but really enjoying it and enjoying combining the two things.
And yeah, again, Nilufar Bawa. I'm a web development lead at Prisma. I've been working here since March 2020. A great place to work at. I was initially started off as a BlackBerry app developer, then turned to a web developer, and I've been living in Berlin since 6 years, and these are my handles. Now I'll pass the mic to Lucy to talk or start the talk.
Okay, so we're going to talk today about how we write and build our docs and the whole process from start to finish. So we'll start with the planning stage, where we find out what needs to go on, and then we'll talk about how we write and build the docs, and then the process of reviewing, releasing, and getting feedback from the community. So, yeah, first is planning, where we try and find out what's going on. We use a docs-like code type of approach, where we work closely with the developers, and basically as soon as after they've started coding, we want to be starting writing. So we embed with the dev teams, we attend their planning meetings at the beginning of the sprint, and we try and keep up with what they're doing, essentially. That involves us being very nosy, so we spend a lot of time hunting down interesting things in Slack channels and internal documents so that we're keeping up with what's going on. So once we've worked out what we're going to do, it's time to figure out the content. So for these slides, we're using, I don't know how clear it is, but it's a sort of running example of a guide to Prisma Day. So to do this, we'd talk to developers and product managers. We'd read all the internal notes we found while being nosy or that we were pointed to. And then it's time for what I'm rapidly discovering is the trickiest question in technical writing, which is working out where the topic actually goes once you start writing it. And that seems to lead to a lot of discussion and trying to figure out where it goes. So at that point, we're ready to start drafting. Neely will tell you a lot more in a minute about the technical side of what we use, but to give a very basic overview, we write our docs using Gatsby. The docs themselves are written in MDX files, which are markdown files, but with various custom JSX components, which allows us a bit more flexibility. So in our example Prisma guide, we have mostly markdown, but we have a couple of extra components. We have a top block component, which we've defined, which we use for the overview. And we also have an admonition component we've defined, which we use for info, error, and warnings. So then, at this point, we can check whether it looks good. Gatsby allows us to have a local preview, and that reloads automatically, so we can do iterative changes and check it looks good. We host it on Netlify, so Netlify also comes with a preview, so we can send a preview link to any reviewers after it's been pushed to GitHub. So at this point, I'll hand you over to Nilu to talk about the building side.
Now to building the docs. Once the docs writing team decides that they need new MDX components or maybe enhancements to the existing ones, they'll start creating issues in the docs repo. So I don't know whether you can see it clearly, but this is an example of how an issue is made. So once they create the issue, they have to label it according to whether it needs to be picked up for the next sprint or not. And they also have to talk to the design team to make sure they have a proper design for the MDX component. It is feasible to be in the docs, and it is useful as well. And once they do this and they create the issue, the web dev picks it during their sprint planning. For web dev, the sprint planning takes place once in 2 weeks, and one of the doc writers, they join the planning meeting, and they then explain how or what they need from us. Then after this, we start building. We use Gatsby for building the docs. Nothing against Next or any other static generators, but we use Gatsby. And a few of the advantages we found in Gatsby is like better load times and its MDX friendliness, the SEO usage, and stuff like better community plugins. Now, there are two major plugins which we use, which we found useful for our docs. One is the Gatsby plugin MDX, because the docs are being written in MDX. This helps in generating HTML files from the MDX pages or the content files or MDX, any MDX files for that matter. And the Gatsby source file system plugin, which helps in separating the MDX content and the source folders. Now, there are also a few other plugins which we use, and some custom plugins which we have created from the team as well. Since this is an open source project, you can check these out in our plugins folder. Now to the components. We have layout components, and then we have custom MDX components. The layout components, for example, when you open the docs page, you can see that there is a nav bar, there is a secondary header, there is a side nav. I don't know whether you can see it clearly again here, but there is a table of content. Then there is the actual MDX content. And these, all the layout components reside in our source folder, and all the MDX component has its own folder called as custom MDX. That's how we have built the docs architecture. Now, how we make these MDX components available to the docs writing team, that is done through shortcodes. It's a pattern where we don't have to import every MDX component into every MDX file. You can just use an MDX provider and make it available globally. There is also the front matter, which is of very high importance to us because we use front matter to manipulate our SEO data, our page hiding or showing, or maybe the the table of contents, stuff like that. So this is an example of front matter. It's too bright to view. So we use GraphQL queries to manipulate the front matter data to make sure that the SEO title and the description is available like for every page. It's custom made for every page. Now, after this is done, after we create the MTX component, now it's time to create the PR. And once this is created, we have a deploy preview in our hosting provider, which is then inspected by the docs writing team to make sure that everything is working as expected. And when they are happy with it, when everything is working fine, then it is merged. And it is made available to the entire docs writing team. And we also have a style guide in the docs web pages. It's under About. You can check that out to know about all the MDX components we have created. So yeah, that's it about building. Now
Okay, I'll carry on and talk a bit about how we review our documents once we've got our draft to a reasonable state, and then it's time to ask for feedback. So it's pretty straightforward process of opening a PR in GitHub, and then we ask for feedback in the relevant Slack channels. So we normally try and get a review from a writer to check it reads well, and at least one review from a developer. We actually get really active engagement from developers, so often, even if you don't tag somebody in the GitHub PR, you'll get lots of people responding anyway, so we always get plenty of comments. That all works really well. And then there's one underlooked point, I think, with docs, which is that it's not just a one-way flow from docs into code. We also help test the product too, because when we're writing docs, we might discover things that are a bit inconsistent or the flow isn't that good, and that can be worked back into the code. So we do also help test as well. So yeah, at that point, we're ready to release if the reviews have gone well. So most of our docs go out during releases at the same time as the code, so we have to synchronize with the developers. We use a traffic light process on Slack, so it's fairly straightforward. We'll get a green light from the developers when they're ready for us to release. We'll merge our docs, we'll give a green light, and at that point, the release notes can also go out and link back to the docs. And then, yeah, we're not quite done yet, because then we have to see what everyone actually thinks. All our PRs and issues are on GitHub, so we do get comments from the community throughout. But of course, it's when it goes live is the point when the most eyes are going to be on new features, and that's when we tend to get issues. So we do get a lot of feedback from the community, which is really, really useful. And yeah, the docs team would like to say thank you for that, because our docs would not be as high quality as they are without everyone else's help. And now Neelu's going to say a little bit more about other ways we collect feedback.
Yeah, about the feedback component. So every MDX page or every docs page has a feedback component at the bottom of the page, like so. So we just have a thumbs up, a thumbs down component, which asks for your simple feedback, whether you're happy with it, whether you're unhappy with the page. And once that is clicked, an appropriate form slides into the page, which asks for the real thoughts, like what exactly you felt or what exactly was your feedback. And this form uses a Prisma client in the background, and we connect to our Postgres database using Netlify Lambda functions. And from these functions, we then use, just having the data is not enough. We need to identify the pain points and the strong or the useful features we have in the MDX or the docs pages. For that, we have a Redash dashboard. We fetch data from our Postgres database into this, and we make sure that we can, or the relevant person can see like what each page is about, whether they're happy with it, whether they're unhappy. So this is the data for a period of 6 months. So you can see how, mostly people are happy with the pages, some are not. There's also further drill downs here. Like you can see for each page what is the real feedback, and what are the pain points, or what are the points, or what are the components which users really like. And depending on this particular information, the docs writing team or the web dev team can decide on whether to improve a component or a page, or whether to just keep doing what they're doing. So that is really useful for us. Now, I guess, that's the whole idea about creating the Prisma docs, collecting feedback and everything. That's it. Anything else for you to add?
No, I think that's good. Thanks.
Yeah.
Thank you. All right, so here's what I want you to do. Go ahead, pull out your phones, github.com/Prisma. You're not pulling out your phones, /docs. All right, 387 contributors to the documentation. If you've not participated in open source before, or if you've been a part of the Prisma community and you're looking for a way to give back, open a PR. A little edit, finding a spelling mistake, changing grammar, as you're going through Prisma yourself, making a recommendation on a way that you can make the docs better, you're paying that forward for everyone else that's going to come and read those docs in the future. And it's a wonderful way to give back and participate in a community. It's also one of the easiest ways to just break the ice and becoming an open source contributor, which is a whole other wonderful experience. So thank you. I'm a big fan of documentation, if you can't tell. So, all right, next up we have Alberto. How many people knew that Prisma has a VS Code extension? Huh? All right, good. For the rest of you, we've got a treat. Alberto, come on up, and he's going to talk to us about the VS Code extension for Prisma.
Hi everyone, Alberto Esquivel from Prisma here, and today we're gonna talk through things about the Prisma VS Code extension that just make sense. So our developer extension went through some major refactorings this year, and we're excited to have already 330,000 downloads. Well, let's see how it works under the hood, right? So we provide editor support for our schema language via LSP, the language server protocol, which standardizes how things like auto-completions, jump to definition, and other editor features work in our extension. We use the Microsoft implementation of it, targeting VS Code. But the cool thing is that the LSP is actually editor agnostic, so it can be used with several editors of your choice. We have developed that in TypeScript, but we also use Rust under the hood, right? So we reuse some logic that comes with Prisma CLI commands, like the format command, that's used for parsing, formatting our schema in a human-readable way, and also for providing some linting information. Of course, we also had a few gotchas while developing this. For instance, when using the Prisma client, we had to watch for changes in the types generated by the client, and we weren't able to do that with the file watcher supported by VS Code by default. So we had to work around that with a custom file watcher. And moreover, we have to manually restore the TypeScript server every time we change the client types, because the TypeScript server every once in a while doesn't really realizes that things have changed under the hood. So gotta be honest, Rust is an awesome language for writing parsers, especially for our schema parser. The thing is, when you have to use it from a TypeScript server, things can get a bit difficult. So we used to spawn child processes and then try to parse the CLI output from Rust binaries. But that's kind of unsafe, error-prone, right? You never know what you're going to get. You can also have a whole set of problems that might come from the loading binaries that can be targeting different architectures and operating systems. Especially if you consider a VS Code extension, like a sandbox, it might be hard to download a binary to use as a sidecar. It comes with a whole set of security issues and concerns. And the VS Code editor doesn't really like that. So that's a problem. So what do we do? Enter WebAssembly. So what we did was taking the formatter, Rust, rather than compiling that to a binary, we compiled that to a single cross-platform WASM artifact that can be loaded by the Node.js platform at runtime as any other Node module. So we use that, again, in the backend for our schema language server, and it just works. It just works. This allows us to get rid of a whole class of potential errors that comes from downloading the binaries, because downloads can fail in pretty creative ways. We really don't want that, especially for a Prisma extension that's used by so many developers. We also support context-aware autocompletions. So what do we mean by that? We try to provide the best autocompletions possible depending on how much you fill the schema, how many of our optional fields you actually fill, right? So for instance, if you select a data source provider, you might get more accurate autocompletions than if you don't, of course. And for just seeing an example, let's take a look at this diff right here. Like we have a Postgres provider, which is remarkably similar to the Cockroach provider in terms of interface exposed. However, there are some native types that change drastically. For instance, you can see here, you can see the red squiggly line provided by our linting in the editor. Let's take a look at the Postgres. It supports the XML data type. The CockroachDB doesn't, and our auto-suggestions reflect that. So I really encourage you to try out our Prisma extension and try to see how our autocompletions may change. And before leaving you, I would like to share with you guys and folks this tweet right here that I found yesterday. If your developer tool is not running in the editor, it's running too late. So what we mean by that is that developers really want, for optimal developer experience, they want things to run where they work the most of the time, which is on the editor. So having created the Prisma developer extension just makes sense. And that's it for me. Thank you for this. I really hope to spark your curiosity. And now we have time for a few questions. Any questions so far? All right.
Is there any timeline for some more development on the side of WebStorm and the plugins there?
So there are some community-supported extensions targeting, for instance, Emacs and Vim. And they indeed use the same backend that we provide for our own extension. What changes is just the front end of it. So they do have to implement their own syntax highlighting, just plug in a few things. But most of the core of the extension is actually reutilized. But we officially support only the VS Code extension.
I'm so sorry. It's okay. So I'm sure compiling Rust to WebAssembly instead of the binary is convenient and it's probably good for supporting the web as well and stuff like that. But out of curiosity, was there a performance or a significant performance difference between using the binary and using the WebAssembly, essentially, as in the Node engine?
So 2 things here. First of all, to answer your question directly, I do not have the data at hand to tell you exactly what were the performance differences. But I can also tell you that we were able to use WASM because the formatter doesn't need anything too fancy under the hood. It doesn't need to run I/O. It just needs our schema in input, and then it returns an output that we parse and display in a fancy way. If it had more complex things running over, then we probably wouldn't be able to port it to WebAssembly as of today. We'll probably need WASI or something like that. So the short answer is I don't know yet. If there aren't any other questions, I think we can wrap it up. All right. Thank you so much.
Thank you. I love using the extension, so thank you guys.
Thank you.
It's super helpful. Oh boy. Next speaker. So we've all experienced this weird thing in the internet where the last 2 years we didn't get to meet people in person, but we got to work with people. And so this is one of those people that I've known is now a friend, and I just got to meet her yesterday. So that's a pleasure for me. But the story goes, she dared to invite me. This is Amy, by the way. She dared to invite me onto a podcast that she was hosting. And I learned that she was doing a bunch of teaching material on her, Learn with Amy. Anyway, I was like, this is someone that loves to teach code stuff. So the second half of the interview was just me pitching her on the help we needed at Redwood. And look, it worked, right? So Amy, thank you. I'm really excited for your presentation to come. And thank you for taking me up on my harebrained ideas.
I'm always for the harebrained
ideas. So please welcome Amy. And you're about to learn a lot more than I could teach you about Redwood.js.
Hello, my name is Amy Dutton, and I'm the Director of Design at Zeal. So today we're going to talk a little bit about Redwood. But first, let's just talk about the world in general. There's a lot of problems out there. You don't need me to tell you that bad things happen. You look on the news every day. But instead of focusing on the bad, let's talk about the good and all the positive things that have happened. And really, over the last 10, 20, 30 years, a lot of the good things have happened through technology. We've put people on the moon. We're able to connect with people instantaneously on the other side of the world. We have people watching live right now. And with COVID, it's allowed us to continue to work and move forward and make progress in 2 years when it seems like the rest of the world has really slowed down. So I could go on, but the point that I want to make is that for something where there's so much change to happen, really only half of 1% of the world can code. It's crazy that you can have that much impact with such a small percentage of people. And the cool part is that's us. That's room for us to celebrate that we are part of that 0.5%. So we are the coders. We're the people that are making change. We make a positive impact in the world. So if coding is so important, why don't more people do it? Well, it's hard. You don't need me to tell you that either. We've all struggled with those bugs, with those semicolons, with the casing that's messed up. There's so many frameworks and languages and packages that we have to try and figure out. So I started coding 20 years ago. So before you do the math, I started when I was 16. And so I kind of grew up adding on knowledge. It's kind of difficult now because there's so much to learn, but I slowly just started adding on things. I started as a front-end developer because I love design. I love being able to make these beautiful user interfaces and create these beautiful user experiences for people, but the truth of the matter is it doesn't really do anything. You really need a server and a database. So fortunately, JavaScript has changed a lot of that. It's made the back end more approachable to someone like me that's familiar with the front end. So I started learning JavaScript with jQuery, again, dating myself. But it allowed me to make my designs interactive, but honestly, my websites were still dumb. You can't really save state. So the back end has always eluded me. So it's hard to learn new things. Maybe you've seen this curve before, but this is when you're trying to learn something new. So a lot of times you have a lot of confidence, but very little wisdom. So people would say this is the the peak of Mount Stupid. You really don't have a lot to back up your confidence. And then you realize, I don't know what I don't know. So you kind of go to this valley of despair. There's so much to learn and so much growth that needs to happen, but then as you slowly learn things, you are enlightened, and then you eventually are able to sustain that knowledge. So for me, tools like Redwood and Prisma have allowed me to make the backend approachable, and it really was love at first sight. So that change, that learn curve that you see, really flattened for me with Redwood because it made the backend so approachable. As David mentioned, I first learned about Redwood, or really explored Redwood, when we had David on our podcast. So I co-host a podcast called Compressed FM with James Q. Quick. So we had David on. It's episode number 54 if you want to go listen. And I think it also goes to show that I really have no association with David or with Redwood. This was just a happy coincidence. But the selling point for me with Redwood was really their generators and the fact that it would create a lot of code for you and that it provided everything out of the box. So you might be thinking, oh, gross, everything out of the box. I would really rather make my own decisions. But the thing that's nice about Redwood is it adds all the components that I would be using anyways. So with Storybook or React or Prisma or GraphQL or TypeScript or Jest, it's all built in out of the box. So you don't have to add those packages and those settings yourself. So just to kind of prove a point a little bit more, I have a series on YouTube for testing with React. And I have one video in that series specifically for just setting up tests and getting everything running. If you look at it, this video is 10.5 minutes. So the crazy thing is that Redwood makes that a whole lot easier, and I'll get back to that. So the backend is no longer this elusive thing, but it is still magical. These tools allow us to be full stack. So if you are a front-end developer here, or you're weary of learning something new, I want to show you just how easy it is to get started with Redwood. So I decided, because I'm crazy like this, as David said, I have these wild hair ideas, I was going to make an app specifically for Prisma Day. So one of the things that I wanted to revisit with this app idea is the idea of that catalyst for change. How can I make something that's going to make a difference? Well, change is kind of this lofty idea that you might have. It means a lot of things to a lot of different people. And really, the easiest way to create change is to ask questions, because when you ask the right people the right questions, you suddenly get knowledge. Your perspective changes. So for the app that I created, I called this Ask Me Anything Anytime, or AMA Anytime. So imagine if Twitter and Quora had a baby. So Twitter is great because it allows you to post something and interact with somebody at a specific moment in time. Quora allows you to ask a question to the general public and anybody can respond. So this idea kind of combines those two things. People can have a profile and other people can come and ask you questions there. So there's a lot of places that already do this. People have this on, say, GitHub repositories, GitHub discussions, Reddit, Zoom, Twitter. But this would be an app to have all of that in one place. So as I mentioned, I'm a designer. The design part is easy for me. I started pulling images together to create a mood board, started sketching some ideas, and then put something together in Figma, and this is what I came up with. So I wanted to push the boundaries a little bit more with this design. So it has a little bit more personality than what you might consider in a normal product design. So to build it out, really the easiest way to get started with Redwood is to say, yarn create Redwood app. And my app is called AMA Anytime, so that's the project name. It creates a folder called AMA Anytime and puts all the code inside. So Redwood is going to generate a bunch of code, and at the end, it gives you some commands that you can run. So this is my folder structure. I have a web folder for my front end and an API folder for the back end. So there's a nice mono repo that keeps everything together. And then since I mentioned testing earlier, to get your test set up, this is the beautiful part. You just run yarn redwood test and magic. It all works. So my tests are up and running. And then I mentioned Storybook. If you're familiar with front-end code, you can create all of your front-end components and put them in Storybook for other people to be able to access. So for Storybook, you don't have to do any settings either. You just run yarn redwood Storybook and magic. It's up and running. So you're seeing an error here because I don't have any stories created. So as soon as you create your first story, that error will disappear. So as you start creating your components, you can say yarn redwood, and that's RW short for redwood. G is short for generate, so generate a component, and then you name your components. That could be navigation, it could be header, it could be footer, and magic. So the cool part is when you create that component, out of the box, it will give you a storybook file, it will give you a test file, and it will give you your component file. So already, I love that Redwood is encouraging you to put the best practices of coding in place. So the next thing you can do is start to build out your layout. So you can use Yarn Redwood, generate layout, and generate pages, and give those names. And here, you'll see that it created some code for your layouts, and again, you can test those layouts and create stories for those layouts. So as you're working with these different layouts and components, it will also have a routes file. And if you look, this set wrap tag will allow you to create a nested wrapper, which is very convenient as you're building things out. And then if Tailwind is your jam, just wanted to include this, how easy the setup is. You can run a setup UI Tailwind CSS, and it will create your post CSS file, and it will set up everything with Tailwind, so you don't have to worry about that either. So once you have your beautiful storybook built out with all of your components, now we get to make that leap into the back end. So it's a big, fun jump. And this is the part really where you're crossing over from being that front-end developer to being a back-end developer. If you're running Postgres locally, that's just as easy as running that create-db database name to get that up and running. And here I have 2 lines because one is for my production, or really my development since it's on my local machine, and then a test database to run all of the tests. From there, what you would do is you would add your Postgres connection strings. Now, we'll hear from PlanetScale later, so if you wanted to use MySQL instead, you would plug in a provider name here for MySQL with the PlanetScale databases, or you can use Postgres. So the nice thing is you can easily swap out whichever database platform you want to use or you're familiar with. So let's look at the design, and I'm just going to start making a list of all the dynamic pieces of information that I have here. I have an avatar, a cover image, a name, a username, a bio, my location, a URL, the people that I'm following, the people that are following me. I have the person that's asking me a question, the question itself, the answer. So I'm going to make a list of all these things. I'm sure you guys have probably done this before, and see how they're all connected. So really all I need is a users and a questions table. You can make that a little bit more complicated if you wanted to blow out the scope like I did here. But you're going to take your schema.prisma file and list all of those things out along with the type of data that it is. So once you have that done, you can run yarn redwood prisma migrate dev, and magic. My database is set up. So from here, I can scaffold out, say, my questions section by just running yarn redwood, generate scaffold, and then the name. And that name matches my database. So let's see what a scaffold actually does. So here, on the back end, it creates an SDL file and a services file. So you can see that right there. And you can actually run these individually, but a scaffold will do it all together. So I could say SDL question. But you'll notice that in the Prisma file, or the SDL file, it creates a type there with the questions, and then it's connected on the left with the actual service. And so if you look at that, that's Prisma running. It says find many. So that's a lot easier to write than a complicated SQL call. So if you scroll on down, this is another custom one that I wrote, so it's easy to add to the ones that are already existing within the generator, and those 2 names line up. So I don't have to write any resolvers, which is, for me, huge. So the next thing that scaffold creates is it creates a few cells, and cells is a unique concept to Redwood. So what that does is, you can see that right there, the question cell, and you can, again, run cells individually. You don't have to have just the scaffold do it. But that creates a GraphQL call, so this makes it accessible on the front end. So that cell is going to live on the front end. It's going to call the GraphQL section of code, so I get all my data out of the database, and then it creates a loading component, an empty component, a failure component, and a success component. So the nice thing is, instead of having to write conditionals to handle all those different cases, you can actually pass in components, and it will handle that state for you. So when it's loading, it knows to handle the loading component. When it's empty, it will send you the empty component, failing, and then success, which is really helpful. As you're working with GraphQL and trying to pull in those queries, there's actually a GraphQL playground that is included so that you can basically test those queries and mutations to make sure they're working before including them within your cells and components. And there's also a Yarn Redwood Prisma Studio command, which will give you a WYSIWYG editor where you can manually add data, which is really helpful that as you're building things out, you're able to test that. If you want to do that programmatically, Redwood also offers a scripts seed file where you can dynamically add information. So as you're building out your website or application, in my case, the AMA Anytime, one of the things that I want to do is to be able to add authentication. And this is another piece that can be sometimes complicated and a little overwhelming. Redwood does have support for third-party providers, but it also gives you a lot of those tools out of the box. So for example, I can run yarn redwood setup auth, dbauth, and add some information to my user model. And then I would want to generate a secret session key. So running this will automatically create a unique session key and stick it in my environmental variables. And then once I run yarn redwood generate dbauth, that will create my routes for my login, sign up, forgot password, and reset password. So magic. If you're trying to protect pages, one of the nice things that you can do is within your routes file, you can use a private wrapper, and then you can tell it where you want it to redirect if that page is private. And that's all it takes in order to protect a certain route. If you wanted to protect something that's inside a page, like a component, Redwood would give you a use auth hook that you can use to wrap your component so that it will only be available if something is logged in. So all this stuff is right out of the box. So it's simply a matter of running these scaffolds and generators and then being able to update the styles that you have and connect that with Storybook. So just to wrap up, some of the beautiful things that I've discovered about Redwood is it really creates these guardrails in the best way so that you're creating code that's clean and smart, but it's also providing generators that make it easy to approach the backend. It generates a lot of those CRUD operations that you have to do in almost every single application and makes it incredibly easy. So if you would like to connect with me, I'm Self-Teach Me on most platforms. So you can find me on Twitter. Again, I mentioned my podcast, Compressed FM, or YouTube. So are there any questions?
Hi, great talk.
Thank you.
I love Redwood too, and I use it too. I have a question. You showed the Redwood setup tailwind command, UI tailwind command. Now, you mentioned that you love design. Imagine there's like a setup design something something command. What could Redwood generate or like set up for you as a designer that will help you get started with a project? Was there something missing?
Yeah, I don't think that it's necessarily anything missing because if you do, it's like this weird balance. If you do too much and take too much customization out, then you can't use it quite as much. But when there's the right amount of customization, you can do a lot. So it does offer, to your point, that UI tailwind component, which makes it really easy to style the things that you need. But it would be interesting to, I don't know, David, if it has like a UI Google Material where it would automatically install Google Material Design or other components like that.
Kind of to the same points, but I see that Redwood is built on top of Webpack bundler, and main question would be like how easy it is to actually like get it out and put something new and modern like White as a bundler for a whole Redwood stack. And also the same question for Jest, like how easy it would be to change it for vTest, for example.
Yeah, I think David could probably help me on this one, but I think they're working on hooking up to Vite. Did I see that? Maybe. Maybe. Yeah, coming future, we'll see. But I do know you can also easily add on packages. So my team in particular is working on an application, and they've put Cypress on top of it. And that was pretty easy to do as well. So. Anybody else? David, do you have questions?
Thank you. I was actually wondering if we have a couple minutes.
Yeah, let's do it.
What is missing from Redwood?
What is missing? That's a good question. So the two things that my team has added as we've been working on things is customizing the linter, which you guys already provide ESLint out of the box, but further customizing it for what our team needs. And then the other piece was that Cypress integration. So that was something that we had to add on top of it. So I think further extensibility there.
Yeah. But one of the themes, and this was in one of the questions, was that even though Redwood is tightly integrated, adding on, taking things out, that was possible to do with what your team needed.
Super easy. Yep, sure thing. And you can also, I should have mentioned this, I know this was a talk about approaching the back end. You can decouple the front end and the back end and just deploy that front end that you need if you wanted to do something to just for sell or something like that.
Yeah, and technically you could even decouple Prisma. So Prisma is not a requirement in Redwood. But so far, I don't know. I mean, again, I don't know why. No one I know is actually, except for experimentations, no one's taken Prisma out of the back. So thank you.
Oh.
That made me happy on so many levels. Amy, do you need a hat?
Yes, I do.
Okay, you want this one?
Sure.
All right, there you go. This one's
Thank
yours.
you.
That's a good one. There's not any more of those. So thank you, Amy Dutton. That was an amazing experience for me on many levels. But here's the theme I want to share with you all is, right, so the origin of relationships going back 3-4 years now with the Prisma team and the opportunities that came out of that. Prisma really enabling a workflow and a process. And going on with it, we haven't talked about deployment, but deployment with Redwood wouldn't be the same without the ability to run the Prisma Migrate Deploy at the time of deployment, and everything we can sync up to that inside of a build process that's very much Jamstack oriented. So Prisma helping Redwood, that's enabling developers, and then relationships with developers that are now helping to teach Redwood. The community experience and the possibilities that have come out of participating in open source and working with other people in the projects has just been a delight. And I would encourage you to think about you being a part of this community as well. You're here. You're amongst other Prismaites, Prismates, Prismians. Yeah, we'll figure that part out. But you're here and you're amongst those people. So what opportunities and potential do the relationships here with the Prisma team, with the other people you're collaborating with, open up for you? And you might be delightfully surprised 2 years from now you find yourself in another country, hanging out in a beer garden or at the Love Parade with someone that you met on the internet who's doing some amazing things with something you helped create. So wonderful. And I dig. Okay, it's break time. I'll stop there. It's good. There's sunscreen in the back. I have a couple more hats, but you'll see I'm giving those out. I don't have many to give. I've got a beanie, though. That's coming. Terrible day for a beanie. But coffee break time, which maybe it's a little bit. You're feeling the post-lunch. The food was good, right? Feeling the post-lunch lulls. So we've got some coffee. You know where the bar is by now. Yes, maybe too much so. We'll see you back in exactly 30 minutes. So 50 past, 10 till. For those in internet land, 30 minutes. You get a break too. All right, see you soon. Check, check. 1 minute. You've got 1 minute until Prisma Day kicks off again this lovely afternoon. 1 minute. All right, welcome back. It's only more beautiful here in the beer garden. Internet land, thanks for hanging in with us. Apologies for all the comments on the lovely weather. I hope the weather's nice where you are too. I hope you're enjoying a fine beverage on this beautiful afternoon. Okay, so we've had some great themes so far, right? Anyone picking up? We don't have to do the interactive thing, but I hope you're picking up on some of the things that I've enjoyed about Prisma, and more so the things that I've seen Prisma empower people to do. And that's a lot about what Amy was talking about in her talk. I remember when DevOps was terrible and took a team of 20 people, and containerization and a lot of changes in infrastructure, DevOps was possible to do get so far with just one person. And that was like revelatory and mind-blowing to me. And now with Prisma, we're seeing people who predominantly might have front-end development skills, and they're able to start working across a full stack, work farther into deployment and DevOps now because of these integration pieces that are being handled by a tool like Prisma. So it's just a wonderful time to be doing this tech stuff, don't you think? So thank you all. We've got another great presentation. We'll have one more break, and then a few more presentations. We have 4 left. But yesterday on the Twitters, there was this Matt Billman of Netlify was talking about this database Neon thing that was coming out. And we've wanted to see some better database, like the serverless and database world just still has some problems. PlanetScale, we'll hear from later. They're solving those same things. But I saw this thing called Neon, and lo and behold, Nikita, come on up. The tweet was about this guy and the thing he's working on, so I'm really excited to hear about Neon from Nikita. So welcome.
Right. Thank you.
And I'll hand it over to you.
All right. Thank you very much. Super excited to be here. The first question I have to the audience, and usually I start the question, how many people know what this is? But for this audience, I'm gonna ask the question, how many people don't know what Postgres is? All right. I see 0 hands in the air, which means everybody knows what Postgres is. And our mission is to make serverless Postgres. and give service Postgres to every developer. So I'm here to launch and introduce Neon, which is, as you may have guessed, serverless Postgres. So now, the way Neon works, there's actually a pretty complex systems project that sits behind it. And what we did is we separated storage. Oh, we don't have signal. One sec. All right, here we go. So we built a next generation cloud native storage subsystem, and that's what basically powers Neon and powers Postgres. So with that, now that we have that storage, we can do pretty cool things, and we are focusing a lot on the developer experience. So now, if you think about kind of the new lines of code written every day around the world, pretty much the majority of those lines of code are written in JavaScript. So we will look at the JavaScript developer, and we want to make sure that it's incredibly straightforward, incredibly easy, incredibly intuitive to consume and use Postgres, and something that a lot of people know and love, and certainly people in this audience know what this is. We learned that developer experience, if you build for it, can be a foundational architectural choice, right? Or an architectural driver. And here I'm quoting a tweet from Matteo Collina. Maybe some people know who that is. And what he's saying is, something recently clicked. Developer experience is a part of a software architecture. Now, I have been building databases for probably 17 years. So it's been a long time. I worked on a company called Microsoft on a product called SQL Server. Then, yeah, some people know what SQL Server is. You run my code. So, well, I worked on CLR integration, runtime, which everybody uses. Scalability and XML, nobody uses XML anymore. But XML kind of technology became JSON, which is still warms my heart. And we're learning, so infrastructure people know when you need to change the architecture of an infrastructure project, and databases are certainly an infrastructure project, that actually means that there's an opportunity to rethink and rewrite the whole thing. And when people are tweeting like this and assuming they're right, and building for developer experience impacts the architecture, that opens up new possibilities. And Neon is certainly striving to seize one of those opportunities. I want to deconstruct what makes a good DevX. And frankly, I learned what makes a good DevX from the companies that are focused on front end, and the companies like Vercel, Netlify, Prisma, obviously GitHub, Replit, Fly.io is kind of the new kid on the block, which we're huge fans of. So those companies are rebuilding dev platforms for the next generation developer experience. So we systems people learn from them. And let me try to deconstruct it real quick. So what makes a good DevX? And if you guys disagree, throw some tomatoes at me or make new suggestions of what else makes a good developer experience. Well, it's certainly CLIs, APIs, and docs. It's latency of like, I want this thing and this thing is there, right? Setting up your developer environment, provisioning infrastructure. You kind of want to live in the world where you click and it's there. And I'm going to give you a pretty visceral example. You know how like you go, who loves going on the AWS console? Okay, I see. Yeah, some people love going on the AWS console, but not many, right? And then, if you consume their stuff through an API, the way the API is set up is like, oh, I want this resource. They're like, oh, here's a token. hold that token, and then come back to me and ask me, am I done or not? And then she kind of waits. But of course, a much nicer developer experience when everything is synchronous, right? And you can make it synchronous when it's fast, right? And if you can say, oh, I need, in our case, Postgres, in 2 seconds you get Postgres. The other thing that kind of the anti-pattern of developer experience is cold starts. Cold starts is like a big subject, and solving cold starts is very, very domain specific. What else gives good developer experience? Yeah, we all like REST and GraphQL. Why? Well, because we can call it from a JavaScript, right? And like I said, lots of code is written in JavaScript these days. We all code in developer environments, right? Sometimes it takes a long time to set up your laptop. Now, people work on something, they want to share their developer environment with somebody else. And then there's all these dependencies that you have from your developer environments. So having something that's really packageable, that's good developer experience. If it's not packageable, it's bad developer experience. Everybody runs CI/CD. And now these modern platforms, like Vercel, Netlify, Fly, they implement this thing called push to deploy, right? You do git push, this thing is up there on GitHub, those platforms pick it up from there, and the app is up and running in production. So all of those things are good. And we as database people are looking at that and it's like, well, if we want to run Postgres, like half of those things are just not true. And that's why we thought that there is an opportunity to redefine what a Postgres experience might be, and that's why we built Neon. This is another tweet, and this tweet is from Jake, who is the founder of Railway.app. Maybe some people know what Railway is. For those who don't, it's kind of like a next generation Heroku. And he's claiming that front end will always have a good developer experience because the speed of iteration is high. And then infrastructure is not going to have, it's always going to be lagging behind because the speed of iteration is slow. And in a way, that's true. And as a database engineer, we used to say database wars are battles on the water in slow motion. Like it's slow, right? You build in systems code, your release cycle is like a year. I remember at SQL Server, some people are users, release cycle was 5 years, which is kind of in the modern day and age is completely nuts. Like that doesn't make any sense. And I'm telling him that we're going to have it great for Neon. And now I'll explain how Neon works, what Neon architecture is. We also have a blog post on neon.tech. So if you click on the blog, as well as go and start our GitHub repo. Everything at Neon is open source. And we'll talk about how we build for developer experience. And also we'll explain how we build for engineering velocity. How can we be faster, advancing the technology faster than people next to us? So when you use Postgres, if you decided to do it yourself, or if you use something like RDS or DigitalOcean Postgres or whatever, typically you end up having something like this, right? You're going to have a primary instance of Postgres in the cloud running on the VM. That VM is going to have an EBS volume attached to this VM for storage, and that's a durable storage. And then you realize that this VM can go away, and you will have downtime, so you'll have another one with another network attached storage, and then you replicate Postgres between the two, either synchronously or asynchronously. And then you realize that if one fails, then you don't have any redundancy, so you'll have another one. So you have 3, right? And EBS volumes also provide a level of redundancy for you. So now you're paying for storage at least 6 times. EBS volumes are not known to be cheap, and also they're not really known to be fast unless you pay Amazon even more money for the 6 times the storage plus more money for provision IOPS. The other thing is that if you look at this infrastructure picture, that you'll notice that you will either over-provision storage or compute. Right? Postgres is a monolith, and it has storage and compute put together. the amount of storage and compute is the amount of storage and compute on the VM. So in day 0, when you don't have any data in your database, you clearly over-provision storage. And then as you run out of storage, you have a no-shit moment. Sorry for using those words in the presentation that live streamed. And you'll have to do something, right? So you can do a lot better. And the way to do better requires some system engineering. We built all that next generation storage, which is going to be right here in the page servers and safekeepers part in Rust. And we built it in Rust because we are optimizing for engineering velocity. And we observed it, and I've been part of large C and C++ projects before, that engineering velocity can be a lot higher in Rust. So how this works? So Postgres storage engine operates at what is called page level, and pages are 8 kilobyte blobs of bytes. And right there, when Postgres reads data, down in the code, it goes and at some point reads a page from disk. So we go and modify that part of the Postgres engine. And by the way, all the Postgres modifications are in our repo, in the Neon database repo. And we are optimistic that we're going to make it into Postgres 16 or 17. Postgres 15, that ship has sailed. And so we replace reading that page from disk to an RPC call in our service, into the page servers. And that service is multi-tenant and scalable, right? So we run it kind of one per region. Then the right path of Postgres is, you do update t, set value, or like name equals Nikita. And then all the way down, Postgres generates a log record, a transaction log record, which looks kind of like this, a pointer to the page and a diff, like in bytes, of what kind of changes you want to apply to that page. There are lots of other types of log records, but that's like a typical one. So we intercept that right path as well, and instead of saving, applying that log record locally, we're sending that log record into our service called Safekeepers. And it's also a multi-tenant service that's built one per region for all the clients. It's scalable. The performance, the workload is very predictable, right? We're just kind of sending log records, and all we need to do is persist them. So we've implemented a consensus algorithm to make it very reliable. And both page servers and Safekeepers talk to S3, so we can offload that data to S3, and especially cold data, right? And S3 compared to the live low latency storage is basically 100 times cheaper. So, we can give you infinite storage for your Postgres instances. So lots of benefits into this architecture. A few that I will highlight. The biggest one is Postgres Compute. If you do that, Postgres Compute is stateless. And that's like your genuine Postgres. It runs all the extensions and just like works like Postgres because it is Postgres. It became stateless. Now we can put it in a container and run it in Kubernetes. And now we can dynamically allocate resources to those containers. We can also kill it, start it on a different machine. And because this is not a monolith anymore, we don't need to move data to that new machine, right? We can just start it on a different machine and then point at the same storage. So that's what allows us to both start Postgres in about 2 seconds and dynamically adjust the amount of resources we allocate to Postgres. So that's kind of the big benefit number one. The second benefit that we have here is, well, we control storage. What other tricks do we can do with storage? And we introduced the notion of branches. So now you can actually create a branch of your Postgres instance. And it's a full copy of data that is, and the creation of the branch takes also like a second or two. So how is that possible? Well, the magic technology is copy and write, right? So we don't really copy that data. We just like move a bunch of pointers around and generate another endpoint. and when you connect to that endpoint and start writing in it, then you diverge into two branches. So you're only paying the delta overhead on storage. But branches is really cool, right? Because A, you can query them. And if you don't, see, they're all integrated with S3, so they're like offloaded to S3, so they're actually very cheap. So you don't need to like delete them. Two, they're cool because branch could be your backup. So instead of creating a backup and then having a size of data long time restore operation, you can just like basically say, oh, I'm just gonna swap it with this branch. So now that's also instant. And the more important thing is, well, branches could be a part of your workflow. So now every time you deploy schema changes or any changes in your code base that are impacting the database, you can create a database branch and try running your CI/CD pipelines against that branch before you roll them into main. And that is what I'm going to demonstrate to you. We worked with Prisma. And I'm going to demonstrate you how you can run a migration through Prisma that is using the new branching functionality. So this is my console. All these records here are endpoints to serverless Postgres. Just for you here, I can create another one. This is another one. I just created it. So I can go to the SQL editor. And type select, just like in the blog post, select hello world. So it's up and running. So I didn't lie to you earlier in the presentation. You can really spin it up in 2 seconds. We can actually take a look how long it took. Yeah, 3 seconds. Sorry, I did lie to you about 2 seconds, but it's 3 seconds. And the other thing is, we completely scale down to 0 if you're not using it. So if you're not using it, you're not paying for it. So. And I'll give you an example. It has a bit of a cold start issue. So it takes the same 2 seconds to bring it back to life on starting to generate traffic on it. So this is what happens when system engineers try to build a blog, a web app. So this is what it looks like. So I'm going to refresh. And then you see that spinning. That is a cold start. Now it's going to start. Yeah, so now we refreshed. I can go back to my console, and you'll see that Prisma Day is active right now, right? So Prisma Day was the special Postgres that I put together for this presentation. The blog runs this kind of blog runs off of this. So now I can go to the blog, create a draft, say Prisma Day. Author Nikita, and author name is empty. And I'll put something like, I don't know, rocket ship here. Create. So I've created that draft. Now later I can publish it, but that doesn't really matter. Next day, I realized I want to enforce that non-null names in my blog. So I'm going to run a Prisma migration right now in front of you. So I'm going to do git checkout out -b, not null, I don't know, 102 or something like this. So I clearly practiced it 101 times. So then I'm going to go to Prisma, schema.prisma. I'm going to find that string name. I'm going to remove the question mark here. And then I'm going to run npx prisma migrate dev not null 102. This will run for a while, I think. Let's see. Now this demo is not like fully. Ooh. Cannot reach the database. Let's just try that again. Cool hats neon.tech. Okay. Well, live debugging. This is Morning Firefly. And no, this is the cool hat database. Okay, it's up. And Prisma Day local. That's live too. Okay, all data will be lost, yes. So the janky part of the demo is that I created I put the database URL and database URL local as just empty databases locally. Later on, as we do a fully integration with Prisma, we'll make it a lot smoother. But anyway, so that generated a bunch of migrations. Well, it hasn't yet, but it's going to very soon. And now I'm going to commit it, and I'm going to create a pull request in GitHub. Hey, hey. All right. I'm running out of time. Okay, git status. Okay, untracked file, I'm going to edit right now. Git add, git commit, -a-m. Prisma, git push, oh well, set upstream. So I pushed it. Then I go here, and it says, create a pull request. I say create a pull request. And now, so this is kind of cool, right? We have Vercel, we have Prisma, and we have GitHub Actions. When you click on GitHub Actions, it's running, it created a branch. It's right here. I'm trying to make it bigger. It switched to a branch, and it's trying to apply migrations to the branch. And all your production database is not it's not suffering, right? It keeps running your blog. You can continue interfacing with the blog. And it says, well, the migration failed. And what I'm highlighting here is column name and relation user contains null values. So now you're safely ran your CI/CD pipeline against the production database. Well, you create a branch, right? And it failed in the middle. But you know that everything is okay, right? Because you didn't touch your production database. So now you can go back here to Prisma Day, go to the SQL editor, update names in the table users and say it's V for Vendetta or something, and rerun the jobs. And this will now succeed. So that is an example of how you can integrate branching all the way into CI/CD pipelines. And now that what allows you to scale that application process to more people because your deployments are now safer. We're working on those integrations with Soren at Prisma. We're working on those integrations with Vercel. We're working on those integrations with Netlify. We're super excited to give everybody, every developer, a push-button Postgres. And because everything is open source, we're also excited about the fact that the internet is going to be running on open source technology rather than proprietary technology, let's say Amazon Aurora or RDS, that is, for you it's Postgres, but all this machinery underneath is proprietary. All our machinery is open source. So take a look, start us on GitHub, and also know that we are hiring. And we're particularly hiring front-end, back-end system engineers and DevRels. And we're always welcome more engineers to come in and join us. Thank you.
Nikita, thank you. That was a great presentation. If you have questions for Nikita afterwards, there's a break coming up after the next talk. Please find him and ask. There's a lot going on about Neon that I'm excited to talk to you about. So thank you for that. It's really, I feel like I've been waiting a long time for database solutions to be optimized for serverless situations. And really, I think that's been the holdup. Someone asked earlier a question about deploying to the edge and what the difference was. And there's a runtimes, but really, like, as soon as you're on the edge or as soon as you're serverless, all these networking regional deployment concerns come into play. They just haven't been solved yet. So technologies like Neon are amazing in what they're going to bring to deployment opportunities. And then also, there's this other thing called PlanetScale, which Liz is going to talk about. So pleasure to introduce Liz to you all. 2 things I learned from Liz last night. Yeah, don't cue the music yet. 1, you can just move to Portugal, which seems like a great idea.
It's amazing.
And then also, MongoDB is not, if you want to have a conversation with Liz and see her fiery, just start with Mongo. But welcome, Liz, everyone. Thank you.
Thank you. Let's get this. Oh, there it is. That all right? Just a moment. There you go. So, thank you for waiting. I'm not going to lie, for 4:20 p.m. on a sunny day in Berlin in a beer garden, everyone looks remarkably sober, so kudos to you. Thanks for sticking with it. Thanks to Prisma as well for inviting us to speak here. And the longer I've been listening here today, the more it's dawning on me that almost my entire talk is going to be preaching to the choir here. And the more I feel like I should have just done a talk about hundreds of ways that MySQL is clearly better than MongoDB, just to add a little drama or suspense, but I'm not going to do that today. I'm going to keep it clean. So my name is Liz. I work at PlanetScale. It's a company that builds PlanetScale. We're a cloud database as a service. We build on top of MySQL and Vitess. Vitess is an open source middleware layer that lives on top of MySQL, and it allows for things like transparent sharding, but it also just really robustly manages and automates MySQL at really large scales. It's used by a pretty large community of enterprise users. There are contributors to it as well. It's an open source project. And they use it primarily to help their databases accomplish massive scale. But it's got a lot of benefits that it can offer at small scales as well. And as of right now, every PlanetScale user is a Vitess user, whether their databases are 50 megabytes or 50 terabytes. We launched an early beta of that platform just over 1 year ago. We've been GA since last November, and we're really just barely getting started. As a company, I would describe us as pragmatists. We're builders ourselves. We eat our own dog food. We build PlanetScale on top of PlanetScale. And really, we're just building the product we've always wanted to exist. So from my side, personally, I'm not a developer. And actually, I can code, but I'm one of those people for who it's just really a vehicle for laziness. And the reason I'm here is, well, I'll admit I thought I would have a slightly different perspective to offer based on my particular experience. So prior to working at PlanetScale, I spent about a decade in professional services in MySQL. I've worn a lot of hats in that area. But yeah, pretty much my entire career has been spent sort of working in the MySQL ecosystem, helping people try and solve problems around scale. At PlanetScale, I am a solution architect, and I would describe my day job kind of composed of technology, speed dating, and firefighting, more or less. So where does that experience and my perspective come from? So data is really the beating heart of most businesses. I don't need to tell you that. It tends to be a company's most critical business asset, and for a lot of companies, just losing it means instant death. There's just no coming back from it. So I don't need to tell anyone this, but I just want you to bear with me because I'm trying to paint the landscape and open up the perspective on this beyond just us engineers. I mean, GitHub going down for a day, even a week, pretty annoying, like slows everything down, very, very frustrating. Everyone's going to complain to each other, but most companies can probably survive that. Phone systems die, same thing, like we figure out alternate solutions. But
a perfectly healthy business that suddenly loses all of their data, boom, everyone's done. Everyone goes home. And so people get really sensitive about this stuff. And they're also very strangely territorial, probably rightfully so. And 99% of incoming requests, or like the kinds of people that come talk to me, tend to fall into two main buckets. Those are the buckets. I would say I love category 1. They're my favorite. They usually come in with massive ideas. They're going to change the world. They just know they're going to need to scale 100x in the first 6 months, and they want to be prepared for that. I love them. And they take up maybe 10% of my time. The other 190% of my time goes to category 2. And these are the people that had an incredible business idea a while ago, and the idea worked out way too good, like way better than they planned for. And now they're just hitting instance limits, they're getting downtime, and really they just need help now. And so those end up being the cases that I deal with on a day-to-day basis. Now, just as an aside, PlanetScale talks a lot about offering sharding. We do offer sharding, but the percentage of cases where sharding is actually needed to solve a performance problem is really remarkably low. So most scalability problems that I encounter tend to be bad database design problems. And so that's where we need to address the issue. Basically, I've seen a lot of people do really bad things to databases. I cannot unsee them. Sharing my trauma with our engineering team, and then now also unsuspecting beer garden visitors. It feels like therapy. It feels kind of good. So that's what I'm going to do. This is the overview of my talk. I'm sort of halfway into the first point right now. I'm going to be sharing a couple of anecdotes that summarize a couple of the learnings that I've had. I believe you'll find they're echoing things that we've already heard today. I promise I haven't spoken to anyone in advance, but as it turns out, on both sides of this pipeline, like we're seeing the same things. Now, some of the things I share are immediately applicable in some cases, and I'd love to see you like open your computers and just double check if those things aren't applying to you today. And some of them are going to be a bit more conceptual. But I will share PlanetScale's philosophy around them. I do believe that a lot of it is also just common sense, and they will apply across different database platforms. So to frame this a little bit more, so not being a developer myself, the history of how databases have evolved over the past 30 years and why you could really fill libraries. So I'm going to start with a slightly different story. And I heard some other speakers sort of share their origin stories originally as well, so it's going to fit right in. 2004 was the year that I first went to college. Feel free to calculate that backwards if you must. But I always knew exactly what I wanted to be when I grew up, and I got an applied computer science degree at a small Belgian university, and it got like a healthy mix of modern programming languages. And I took note, I had a very different introduction to programming than Delba did, who spoke earlier today about Vercel. But yeah, basically, we spent an entire semester learning ASP.NET, another entire semester dedicated to learning about Jakarta server faces. Clearly, these were the web development frameworks, languages of the future. We didn't refer to it quite as nicely. We used a much less appetizing name because that's what grown-ups do. And honestly, JavaScript was kind of a footnote. I mean, it was merged in like in the same like trimester with basic HTML and CSS skills. It's not really worth spending a lot of time on, really. It wasn't even really a programming language at all. Like, it just didn't really count for anything. And so what happened? Like, something clearly changed. So what did happen? I mean, other than, say, 2 decades of blood, sweat, and tears? And as I was thinking about this, I realized back then a text editor and a browser were already available on every single computer. As it turns out, a well-placed console.log was enough to teach millions of people back then just enough about how to build things that worked. And what we find is when tools stop getting in the way of people trying to create things, the infrastructure they need is going to follow to support them. And it just doesn't work the other way around. You can't really force people into a very, very complex system. It has to be developer-driven. And as long as there is no lag sort of on iterating and improving, developers don't seem to mind getting it wrong a million times, even over multiple decades. You just keep building until you do get it right. And that's kind of that pendulum swing that we've heard being talked about earlier today as well. Like, it doesn't matter. Like, it sounds like we're trying to build the same thing, but we are in this place where, yeah, we're getting closer. We're really getting closer. So that is how mountains get moved. And that is the kind of energy that's driving PlanetScale. And we want to do everything we can to keep that momentum going. So the energy, which I'll nickname the unstoppable force, has a tendency to smash into what I'll call the immovable object, which is business data requirements. Super pain in the ass. So needing to think about how you're going to structure your data while you're still just barely prototyping is a super pain. And let's be honest, it gets even harder further down the line, even when your core functionality has already been fleshed out, because a database is often really a reflection of a much broader business process than just the stuff you're thinking of while you're making those first baby steps. And the burden of balancing all of that while you're excitedly trying to build something new is just too much of a burden. So the responsibility here also ends up being really fuzzy. And because schema changes for relational databases have been really hard, it ends up feeling like you're locking yourself into certain mistakes right from the start. And there's no arguments here from me on that side. Like, I know this is hard. I mean, these things are difficult. But we do know that all successful product companies eventually manage this process in some way. Nearly all of them eventually end up diving straight into the fun bits, which is just trying to manage this insane smorgasbord of data they've started collecting to actually get to the information that's locked within. And don't even get me started on the infrastructure side of it all. I heard Kubernetes being brought up previously. I've been using it almost daily for 3 years, and I've been solving problems in it on a daily basis. And every time I use it, I'm more convinced that computers were just a mistake. Like, we just shouldn't. This is too much. So it is a nightmare. It's really a lot. And so this is kind of where our stories come together. So where the database world also got really interesting is around the same time when JavaScript kind of refused to die. And in addition to schemas being really hard, traditional relational database solutions were just too expensive. They didn't really keep up with like this rapid shift to cloud infrastructure. I mean, MySQL was 15 years old around that time, and it still struggled to adapt. Like, it just couldn't keep up, so something had to give, and shazam. Suddenly we've got all these single-purpose databases popping up everywhere. We got in-memory stores, we got databases that completely change the format in which data is stored to allow for flexibility while building. We've got like unicorn companies of the Web 2.0 that are just trying to adjust to a tidal wave of data that they suddenly need to process. And everyone's going off to solve their unique challenges. And so builders now have this endlessly diverse box of database Lego blocks to choose from, combined with a massive world of new development principles. But the majority of businesses still just need the same thing, and it's the same thing that they needed 20 years ago. And the solutions that are still around today after that sort of burst, lots of them have started converging on similar sets of features. And you now see MongoDB supports transactions, and actually they do have a schema, et cetera, et cetera. But like, these initial principles on which they were built didn't include that. Turns out that's what everyone needs, though. So over all of those years, none of those companies stopped getting better at it. Like, they're all getting better at it. And there was one other quote that I picked up today that Delva said that I think summarizes the journey really well, which is that, like, we got to look at it as builders versus cynics. Like, it doesn't matter. Like, it makes sense we're all converging on the same place. It makes sense that we're all trying to offer the same features. It's the same problem we're trying to solve. So here's the magical wish list. Pretty much the same for every single business I've talked to. People need a stable data model just so they can turn things into business intelligence. everyone wants some consistency guarantee at some point, at least some of the time, and everyone wants to be able to scale 100x just in case they need it. And ideally, they never have to worry about availability either. So really, like, that's what people want. So, I mean, if you're like experiencing a bit of deja vu, please direct the blame at whoever scheduled me late in the day. It's definitely cooler to be quoted than to realize you pretty much wrote the same presentation as many other people. But it's honestly also been kind of amazing how solutions that are living in all different layers of the stack are sort of addressing the same underlying problem. And at least we're all looking in the same direction now. So what ORMs like Prisma can do is so much to bring us closer to finding that sweet spot of combination, like sweet spot combination of technologies that just lets us finally overcome the business challenge of having this stateful data store. And at PlanetScale, we're also aiming to set a new standard for what people expect from their databases moving forward. And we like to use a quote there, think not of what you can do for the database, but what the database can do for you. So I made a small fix to the screenshot from the, I don't agree with the fact that databases have to be brittle, but look, everything else in there is fine. I'm not sure if that's really readable. It looks really dark. But I wanted to add a little transparency check. You might be thinking, who's this woman talking at us about building product? And she just said she can barely code her way out of a reserved linked list, a reverse linked list, or whatever that is. Really, who knows? You're right. I don't know what it is. And I've learned everything I know from just observing and addressing other people's pain. And from listening as well to the people who've done this at some of the biggest data companies in the world. Now, there was another talk, and there are so many points today that I thought, oh my God, like, we should have talked up front. But I believe it was Hassan who spoke earlier, described kind of the cycle that I've tried to outline in this graph. And what I call solving for scale was sort of step 4 in the process, in the life cycle that he described. And I stole this diagram from my CEO. He used to be the VP of engineering at a company called GitHub. If that's not enough clout, our founding CTO is the person who built Vitesse while he was managing databases at YouTube. My boss was a DBA at Twitter. In our engineering team, we've got people who build core infrastructure at Instagram, at Facebook. And like, seriously, some of these people have forgotten more about scaling databases than most of us will ever learn. So it's just, there's an incredible amount of knowledge gathered around us. And if you don't want to take it from me, take it from them. Like, every company goes through cycles like this. And if they're lucky, they only get stuck in the solving for scale phase once. If they're really unlucky, then they never really leave that red zone, and eventually they end up talking to me to try and pull them out. So, yeah, my punchline for the talk has already been leaked. It doesn't hurt to repeat it one more time. This was going to be sort of the basis of this talk. And when Søren, who I've never met before, mentioned almost this exact same sentence in the keynote, I pretty much, I'm sure like someone must have heard my forehead slap. Again, though, I think it's really kind of beautiful that the problem has a recognizable name and everyone is trying to solve it. So let's talk about a couple of scenarios that are one and all made more complex because of this simple fact that state has weight. And that state, like any operation that you're trying to do in a stateful environment, ends up costing more. So I work with a lot of different companies, most of which I'm actually not allowed to call out by name. So I've just grabbed an example that I actually had zero direct involvement in myself, but whose story is just sort of out there on the internet, and it's a very sobering example. Imagine it's early 2020, Slack is happily experiencing the sort of healthy growth that's already forced them to rethink their scaling strategy. So at this stage, they were already shifting into Vitesse. They redesigned what they wanted their environment to look like. They just weren't quite there yet. So they were actively contributing, but they were migrating at a bit of a leisurely pace. So they were in a better place than most. But then COVID happened. And every single company that was already stretching that old model of theirs suddenly increased their usage of Slack something like 10x overnight. So just try and put yourself and your application in that position, and you can imagine just the heroic effort that followed. They've written extensively about it in a blog and on Twitter, so I'm not even going to go into the specific details here, but I'm just going to summarize a couple of takeaways. So these past 3 years have been like an unexpected mess in a lot of different ways to a lot of people. There's just been world-shattering events happening like one after another. And in this case, Slack was able to ride that wave because they were sort of prepared, but how many companies ended up just leaving massive piles of money on the table, or even worse, just kind of had to buckle under the pressure of a completely changed workload because they were basically caught with their pants down. So if you don't want to think about how you're going to scale your data right from the start, fine. But don't leave it until step 4. Don't create this separate stage in your company lifecycle where you're going to deal with scale. That is just not how it's going to work. So whatever it is that you need to do, if you want to outsource your knowledge gaps by going serverless, I mean, we'd love that. But honestly, like, go nuts, build your own. You wouldn't be the first. You're not going to be the last. Just start as early as possible. Start to think about this problem. And I guess the main thing I can say is, like, you're no longer alone in this. So many other companies have had to deal with this. Your problems are not unique, and they've probably been solved before. And talking about them with either experts or just with your peers are going to dramatically help avoid the biggest kind of drama. So, second anecdote. YOLO schema design choices. This is one that's a little bit more specific. So it's the kind of stuff that we can see people run into almost every single day. Somehow, they still end up blindsiding companies right in the middle of like a blissful growth stage. From one day to the next, like, they're just cruising along nicely, and the next day, like, their database is down, and they've got, like, they can't figure out how to fix it. So I'm directing this anecdote to anyone at Prisma as much as other developers here. Because for all the talk that I heard today about Typesafe ORMs, and I know it means a different thing, but it always sort of reminds me of this. I'm not really sure why SQL data types are considered safe themselves. Like, they're just, it's just as easy to shoot yourself in the foot with these supposed standards that everyone adheres to. So who knows the importance of the number on my slide? I don't know if you can read it, but it's 2,147,483,647. I'm hearing some vague, like, signed and that's about right. So it's the maximum value that you can store in a signed SQL standard integer type before its binary representation on disk starts overflowing, and basically you've spent all the space that's been allocated for it. So that means you can still try adding higher values, but there's just no room to store that, and you're kind of stuck out of luck. So that, like, if you combine that sort of situation with the primary use case, I think, of auto-increment columns across databases, which is to create a primary key. Every single one of those values is already used. It's a quietly ticking time bomb. And if you go online and search for people like this specific number, you know that people have run into this so many times. It happens all the time. This is not a new problem, and yet everyone still just creates their tables with ID int auto increment, and they never think to go back to it. And so very, very often, this is the kind of problem that we run into. It's very debilitating when you actually run into it. When it brings you down, it's usually in a case where your database is already significant sized. It's under heavy load. Trying to fix that, pairing that with really expensive schema changes, is hard. Don't do it. Don't be these people. So just to give I mean, rather than have you all run off to MongoDB, I just want to give a little context around why this happens and why it's still worth it. So predefined column sizes are at the heart of what make relational databases fly, specifically on these structured OLTP workloads. It just becomes super, super easy with a well-defined schema and ultra fast to tell your SSDs to grab just those bits that you need and never even bother looking at anything anywhere else. So it's that fast because the database engine just wastes no microseconds at all, even thinking about how it could read something from disk or memory. It just knows because you told it. That's your schema. That's why you define that schema. And it's a very simple and elegant thing that people tend to forget about. But this is also why it exists. And this is why relational databases are fast at these types of workloads. But yeah, using words like Typesafe, I mean, this is, again, something more generally directed. Maybe that's something Prisma can help resolve. I included a little screenshot of Prisma's int type mapping to the various databases that they support in their documentation. And I think, what is it, like 6 different types of databases are in there. So can you guess how many of those databases will run into exactly the same problem by doing exactly what they're told? It's all of them, because this is an SQL standard. Like this is, I mean, it's working as designed, which is tragic and really, really stupid, but it still happens. And so using an ORM doesn't really mean that you get to just forget about what's running underneath. And, well, I just want to say, break the cycle. Don't do this. And if Prisma can do anything about this, like I would say ORMs have kind of been offending recommended database practices for decades. So at this stage, like, if this is not something you can protect people from shooting themselves in the foot, as a good general default, it would just, yeah, like, it would just go such a long way to help people avoid these problems. So it's a different kind of type safeness, but it would help a lot. All right, number 3. This anecdote is kind of at the heart of what our CEO desperately wanted to solve for after his time at GitHub. And we think it really is key to rolling with the punches and not letting your development cycle stall while you are solving scalability problems in reverse, or in parallel, as it were. So I'm not going to pretend PlanetScale offers the only answer to this. Prisma offers migrations, like quite a few other development frameworks offer similar implementations that are kind of variations on the same theme. Most of them offer one way or another to at least streamline database changes alongside your code changes, making sure one team of developers isn't dropping columns others need for features being built in parallel, blah, 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 blah. So it sort of codifies database changes into a growing history of your application development and makes those, it orders them in deterministic ways. It makes it easy for people to reproduce replicas, helps them understand what the status of their staging environment, like it compares everything. It just introduces the database into this workflow in a way that's never been done, and that's amazing. It's a really, really, really good solution. But here's where we often bump into the next level of the problem. And again, this is related to the weight of the data and how impactful schema changes can be on a large and busy system. And that's a challenge that can't really be transparently handled by an ORM alone. So PlanetScale relies on its internals to figure out the best possible way to consolidate a production schema with the changes you're trying to roll out. In some cases, that might mean it's actually going to rewrite your alter statements because it doesn't agree that the way you're trying to accomplish something is the most effective way, or is the way that's going to have the smallest impact. So it treats DDL statements as deterministic, and it executes them in a completely non-blocking way as well. And if you don't trust me on that, no worries. We also allow you to rewind and revert those changes instantly. So once you have a schema change applied, you can just switch back and forth. We keep 2 copies of your table there. You can try both versions. If you need to roll back your code, that also remains available. So that's kind of the additional piece that we see as really critical to closing that loop. And to us, what we were trying to accomplish with that, I put these two diagrams next to each other. On the left-hand side, it's sort of what the general Git pull request workflow looks like. And we wanted to design a database experience that really fully implements all of those similar features and allows you to go back as well safely without needing to do manual cleanup. So, number 4. Almost done. I think I only have 5. So, one more scenario. We often see that sort of confounds people when they've moved into a cloud solution. I mean, it's pretty common overall. It's just one of those cases where different environments seem to have dramatically different performance. And I would describe the usual progression of emotional responses. So things look fine on your local machine. Everything's cool. No problem at all. Little slower on staging, but it's fine. Like, we can get away with it. And then once you hit prod, like, suddenly it just explodes for apparently no clear reason. You can't really figure out why that is. So I would say this is, when we encounter this is usually a case in favor of deepening your understanding of the database that you're using, even if your ORM is sort of helping you manage that relationship in a healthier way. The chances of your database living in the same rack as your web application in production have basically slimmed down to absolutely nothing, thanks to cloud infrastructure. And so we've suddenly quietly introduced multi-millisecond hops between all these different parts of your application. And possibly you have a distributed database system as well, so that sort of adds to the weight there. Now, if you have a solid staging environment, it sort of represents production. You can notice those additional milliseconds being added. You might decide they don't really hurt you quite yet and choose to go into production. But adding the sudden massive concurrency of your production environment where loads of people are doing the same thing at the same time, suddenly your response times grow exponentially. And I'll describe like one potential combination of things that could be causing this, and it's just something to stay aware of. One really big way that we've needed to change the way that the applications talk to our databases is by relaxing our reliance on transactions. I know we're all about transactions are super important, and they absolutely are. They need to be able to be executed consistently. But we really only should use them when we need them. So when you don't really care about round-trip time in a local development environment, or even like a simple staging environment, you don't notice how often your connector and your database actually talk. And using transactions does exactly what it describes sort of on the tin. Like, you hold a reserved connection, you execute multiple interdependent things in a row sequentially. Every step along the way, you go back and forth, sometimes multiple times. And in the meantime, your database is actively doing something that we call multi-version concurrency control, which essentially comes down to it preserving multiple versions of reality within memory, trying to keep track of what any number of concurrent transactions is trying to do, all the changes that they're making, just in case, like, they might be racing to the finish line, one transaction might undo everything something else did. Like, there's a lot of complexity involved here. And so it is an expensive operation. And it is made worse in every single way by distributed cloud infrastructure. There's no doubt about that. And is it one of those cases where we wholeheartedly recommend making a well-informed decision to relax your transaction consistency requirements, only using them when you really need them? Absolutely. So part of knowing and understanding where your code base talks to the database, and something like that part of things tends to be pretty straightforward when you're using something like Prisma. The other half here is understanding your connector settings. And as Prisma users, I was kind of going through the docs trying to figure out where I could configure that. The connection management doc page is one of the longest pages I've seen. But to me, it's very clear that investing the time and really understanding, like, what are you doing, it tends to pay off big time. So create those connections, understand what's actually reaching your database, how often are you going back and forth, understand that, change your settings if needed, know how it affects you, and you can dramatically improve performance with just a couple of small configuration tweaks. So just stay aware of that. A last bit of general wisdom, kind of passed down by the product giants that I work with. Nowadays, using a default isolation level of read committed tends to be good enough for more than 90% of workloads out there. So whether you're using PlanetScale or any other relational data store, you'll get more and better concurrency on transactions out of the same number of resources. In short, you're going to save a whole bunch of money and get better performance. So that's what everyone wants. Last anecdote. This one's almost petty to me. It's going to be a quick one. It's another cheap shot at SQL data types, and another reason why I just, whenever someone talks about type safeness at all, I just feel a little triggered. I could do a whole talk about the slowly creeping horror story of realizing that datetime types are really lossy, and most people don't realize it when they start to use them. And their precious date fields really are nothing more than glorified, pre-formatted text fields. Like, really, there's no intelligence really embedded in them. And so this kind of stuff really starts shining through when people start thinking outside of their initially deployed cloud regions. So imagine you're wanting to deploy some replicas somewhere else. Suddenly, you're confronted with multiple time zones, and you realize, actually, you cannot compare these values because you don't know what the source time zone is. And so once you start trying to use date time fields for any operation that requires auditing or actually being 100% certain what is the real time you were trying to store, just don't use them. Essentially, I've seen too many systems where multiple years of weird winter time, summertime changes suddenly have an hour's worth gap, because that's just what happens. And most people don't even realize it. So I'm not going to say a whole lot more about it. Probably running out of time anyway. So just don't use date times. Just use timestamps, mostly. Any fields you ever want to use for reporting, save yourself the headache, and just store things in UTC. Don't use time zones. Just, pick one and stick with it. So those were my anecdotes. I had a whole spiel about closing this out that was designed around trying to rally everyone. I mean, it's kind of late in the afternoon. I can see we're not really that energetic anymore. But honestly, most of the talks I've seen here today tell me we're already rallying around the same challenges, and it kind of feels to me like the A-team is already assembled. I'm literally preaching to the choir. So with that said, PlanetScale has summarized our design principles as a part of our feature launch week 3 weeks ago. From our side, as a relational data store, we aim to keep doing whatever we can to keep building that platform that focuses more on what it can do for you instead of just acting as an immovable object in your path. So real quick, because this talk was really all talk. I haven't really demoed anything. But yes, there is actually a real database that has been generally available for 7 months. It's already supported in Prisma, so you can try it right away. We are running workloads that generate up to hundreds of thousands of QPS today. And if you'd like to give it a shot, I can only really recommend you try out Beam. It's an internal company communication platform. We open sourced it as kind of the perfect example use case, and it implements all the things that PlanetScale stands for. And it's built on Prisma as well. So if all goes well on your path and you have learned some things from today, I hope you may never even need to talk to me in the future, but if you do, I look forward to it. And don't hesitate to come up and ask any questions. So thank you very much. Any questions? Or what's that? Yeah, 2 minutes. Anyone awake?
So how do you store date time in a database?
I would recommend using for anything that doesn't require you specifically storing times before 1970. So anything that you're using standard fields like created at, edited at, the kind of stuff that everyone uses to be able to do reporting on later, use timestamp. Just a timestamp using a UTC basis. It is much cleaner, it consolidates, and yeah, it's much more reliable. In general, it's very easy to transform, and you're not going to end up losing a lot of data.
I have here a little bit of note about this, because if milliseconds are important for you and you're using MS SQL saves 1 fucking byte on that. And you will not say if it has only 3 or 4 fraction at the end for it. So, of course, you will not lose a lot of data, but you will lose something very core for your application. So every time you should really deeply consider what do you do with dates, and there is no silver bullet at all.
Fair enough, absolutely. I didn't know that, and I fully support your statement. Know what you're using and make sure you understand what's actually being stored.
Liz, thank you so much. That was really a pleasure. And if you haven't tried the branch merging strategy in PlanetScale, it's all the right kind of mind bending. So it was really a pleasure to use. Thank you.
Thank you.
And well done.
See ya.
Yeah, you got to get that. I couldn't wear this one the whole time. So I don't know if someone hasn't answered this. I don't know how to describe it. I think it's really just the cause is tech debt. But I want to name something that we haven't talked about yet that Prisma enables. But being a seasoned developer. Seasoned, right? That means I'm old. I'm so used to trying to avoid technical debt in the choices I make up front. So when I know I'm going to start a new project or work on another failed startup of mine, I want to go through a lot of options because I know once I choose an architecture, once I build for a certain infrastructure, then I'm not going to be able to iterate and pivot and try something else later, right? Common experience. So what's been interesting with Prisma is I have one test project in Redwood using Prisma, and I used that test project. I switched over. It was started in Postgres, and then they came out with GA support for MongoDB, and I changed like the ID on 3 fields, reran some generators, and I was using MongoDB. Same test project, no code re-architecting. I wanted to try PlanetScale. I got in touch with James Quick at PlanetScale. We did a live demo together, used the same repo, used the same Prisma schema, swapped out Postgres for MySQL, and I was running on PlanetScale. And I just don't think that kind of iteration in your infrastructure has really, I've never experienced it in my career before, but I don't know what to call that thing, but it really, that fear I faced beginning projects of making the right choice is slowly reducing and allowing me to iterate a lot more quickly, right? There's just not that risk up front or the possible downstream risk, so you can take more risks up front. Does that make sense? Am I naming something? Has anyone else experienced that with Prisma similarly? All right, maybe it is just me. Like just me wearing the hat up here. Okay, we're gonna take a 6-minute break, so you have to be back at 10 after. And here's what this is for. This might be, you've got 2 great talks ahead of you, and then they play the techno, right? So this is whatever you need to do to prepare yourself for when the comes on. That's coming in about 60 minutes, all right? So take a quick break. We'll see you back at 10 after. And I know it's the wrong season, but anyone need a beanie? Right there? Yeah, Andre? Okay, it's coming at you. All right, cue the music. See you in 10 minutes, Internet. Oh, that was a good catch. 1 minute. Prisma Day participants, you've got 1 minute to return to your seats for our final presentations. I'm ready. Okay, we're there. You guys, you look good. You look like you've had a good day so far. Yeah? I like that. We got a little bit of cloud cover. I'm going to give the internet a little weather report. About I don't do Celsius. I forgot about that. I'm an American. We're terrible at stuff. It's about 73 degrees, which is how much in Celsius? 24. I did that in my head. And a little bit of cloud cover out right now. We're feeling good. There's been an open bar. Some of you are feeling really good. And it's been a really lovely day. And really, I'm kind of thankful to be here. So 2 more presentations. And let me tell you a little bit about the next one. So it was early 2020, that world pre-pandemic, right? We've got PD and AD, post-pandemic pre. Okay, anyway. And around February of that year, plus or minus a few days, there were, and I know this is like cliche, another JavaScript framework, but I kid you not, there were 3 full-stack JavaScript frameworks announced within 30 days of each other that were going to be new projects that came out. And I've since, in conversations with people, and the one podcast interview I did with Amy, people ask, like, what happened? Like, why were there so many full-stack JavaScript frameworks that came out at that time? And the answer is that was right when Prisma, version 2, now just Prisma, went into beta. And Prisma really became the inciting incident for a new type of JavaScript full-stack frameworks to come into existence. So that was the inciting incident. So it's fun to announce Alexandra, who's working on Blitz, a wonderful full-stack framework, and now actually more than that. And she's going to tell us about Blitz. Is that? Yeah, well, actually, no, not quite
No,
Blitz.
no,
Sorry.
I'm not going to talk about Blitz. But
I
I can tell
told
you
people about
Blitz
Blitz
afterwards.
That was good. You should talk to her about Blitz. She's a lead maintainer on that project. So talk to her about that after she talks about the other things. Alexandra,
Yes.
please. Thank you.
Thank you. Thank you a lot. Thank you for having me here. So today I'm going to talk about some SQL tricks and concepts that you might have heard about or might have not. But let me introduce myself first. So as David said, I'm the lead maintainer of Redwood.js. It's a framework, a full-stack JavaScript framework, which is now pivoting to a framework-agnostic toolkit, so that you will be able to use it like with Next.js or Remix or Svelte, possibly. I'm based in Poland, and you can find me on Twitter as Aleksandra CEST. So my talk is split into 4 parts, and we're going to be talking about different SQL stuff in each of them. So firstly, like before we start with the main content, like why am I even here? Why am I talking about SQL? And why do I think that it's so cool? So firstly is declarative. Like you tell the machine what you want. You don't tell it how to do this. It's like, here are some constraints. Go ahead, solve them. And it goes with some trade-offs, like being declarative. But what it also means is that it's only 4th generation language that got mainstream. 4th generation means like declarative and non-procedural. And everybody uses SQL. Like Prolog was kind of close to become mainstream, but it never made it. But SQL did. And it kind of goes with the name. Okay, someone is laughing, that's good. Okay, so since you're at this conference, I assume that you are more or less familiar with basic SQL. So this is like a simple query that you might have seen before. Here goes a bit more complex one, like we have some joins, there's more going on. But what about this one? Let me go to my terminal, and there's a query on the left side of your screen, which is way more interesting. Now I'm going to actually run it, and let's see what happens. So with this query, I can make it slightly bigger. So with this query, we just generated a Mandelbrot set. It's a set of complex numbers, and when you plot them, you can have this nice fractal. So this is more what we're going to talk about today, those kind of things. Going back to my slides, we're going to start with recursive common table expressions, aka the true gem of SQL. And I'm going to explain why later. So before we start talking about recursion, let's talk about the simple common table expressions without recursion. So here you can see how it looks like. We have the with keyword, and we declare the name of the common table expression. I have red cars. And then inside of it, I have a query that you can think of as like a named query that will produce like a virtual table. You can use this to extract some parts of your SQL queries outside of the main query to simplify your code, to improve readability. You can reuse them. Like normally, like if you would want to use some SQL, some select statement in multiple places with CTE, you don't have to do this. You can like extract it and then reuse. It also allows you to do multi-level aggregations that wouldn't be possible otherwise. So in the CTE, I can have like 1-level aggregation. I have this min, max on the grade column. And then I can have like another level of aggregations in the main query. Now, the recursion part. So here's a recursive common table expression. This specific example generates a series of 10s. So what happens here is that we have a base row set of a recursion. We're starting with 10. And then in the recursive part, we are adding 10 to the previous value. And we are doing this till we reach 100. OK, so why did I call recursive common table expressions a true gem of SQL? It's because it made SQL Turing complete. Recursion, like they added recursion, which means looping. And looping without max iteration count and unbound storage means Turing completeness. And recursive common table expressions did not only provide looping, they also let you store intermediate data and retrieve it. So you saw one example of a recursive common table expression. Now you're going to see a slightly different one. But before we see the code, I want to introduce one more thing. So you might have heard about brainfuck. I hope that I'm not breaking a code of conduct here. It's actually a name of a language. It's very simple. It has only like 8 commands, and it was made to like challenge programmers. It's not being used in production. On the right side, the thing that you see, it prints hello world in brainfuck. So someone was up for a challenge to write an interpreter for brainfuck in SQL. And that's what we're going to see. This is the code on the left side. It's only 55 lines. And now I'm going to run it in the second terminal. And we printed hello world. And we did all of that with recursive common table expressions. So we don't, on daily basis, we don't write interpreters. So we probably don't care about this specifically. But there are plenty of other use cases for recursive common table expressions. Like when you have a hierarchical data in your database, like company structure, tasks with subtasks, maybe like multi-level comments, or something similar, then they make it easy to build and get data from those like tree-like structures. And they can also traverse the data easier. And they also let you to generate like arbitrary row sets, as we saw in the first example when we generated like a series of 10s. Now I'm gonna briefly explain how it works. So there's this tree. Let's say that this is like a family tree, and we are looking for all the ancestors of Jordan. So we have this base row set where we are finding a parent of a Jordan, and then in the recursive part we are using union all, and we have the recursive part that involves the recursive common table expression ancestors, and is trying to find a parent of whatever we have already in ancestors. So this may kind of look complicated that we called the recursive query ancestors, but we are also referencing it inside of it. So let's take a look at this visual explanation. So we have this base query of the RCTE, and it produces the first row set, like let's call it a base row set R0. And then this row set is being like passed to the recursive query, this recursive part that we saw previously. And it produces another row set, R1, which is then applied to the next recursive query. And we're going on and on until we reach an empty row set. So then we take all of the row sets, and they are being merged together into the final result. So going back to the example, like how that works exactly. So from the base query, we are getting the parent of Jordan is Taylor. And then we are looking for parents of Taylor. And we get Austin and Sam. And then, again, we apply Austin and Sam, and we are trying to find their parents. We're finding Ezra and Alex. Then we don't have any more information. So the next row set is empty, and we get the final result with all the previous row sets that have been produced. So that was about recursive common table expressions. And since we are already talking about tree-like structures, I'm going to show you one more thing, like how to traverse this kind of data with ease. So right now we have a slightly different tree. Like let's say this is a company structure. And we would like to find out what's the path between John and Alex. And in general, we want to be able to answer questions like, what are the relationships between nodes? We can do that with the L3 extension. This is included in standard Postgres package, so you should be able to load it in most servers. You can do this with this create extension L3. command, and then you can use the L3 type for your column type. In my example, this is that the column is called path, and it can be like any other name, but basically the path is like dot separated string that then you can use L3 operators to fetch some data. So now let's see an example. I'm gonna open Table Plus. So I already created the table and I filled it with some data. Like I filled the same data that you saw on the example. And I have two sample queries. The first one is supposed to count like how many nodes there are below Alex. So if you run this, it's gonna print 9 because there are like 9 people below Alex. This operator here is from the L3 package. And the other query I have here is this. We are looking for all the rows that have Ezra somewhere inside of its path. So you can do those kind of things, like you can use the operators to count nodes, to find the descendants and ancestors easily, but it kind of looks like some fancy string operations. So the question is, like, can't we have the same thing with Postgres string functions? And the answer is yes, but also no. So the coolest thing about L3 is not the operators, but it's the indexing. So let's say we have this query. We're looking for a specific path in our table. If you have millions of rows, this is going to be very slow, like, because Postgres will have to go through each row and do the comparison and to see if the path is equal to the string that you have in your query. Now, you can add an index, like B3 index, that you are probably adding to your other tables. And that's going to be slightly better. Postgres will do a binary search on your data, so that will be an improvement. But still, Postgres doesn't know what this add operator means. So eventually, it will fall back to a sequential scan. That's where generalized search tree comes into play. So Postgres lets us to define our own indexing code, and this is what the L3 package does. It provides its own custom function that Postgres can use instead of the default one, and this is what makes the L3 searches fast. In that way, Postgres knows how to compare the paths, what it means that you are looking for something that's lower or greater than a particular path. So I'm going to leave a few links to read more about it in a takeaway section. And that's the gist thing. Is kind of an interesting topic to research. OK, now we're going to do some data analysis with SQL. Firstly, I'm going to state the examples that we're going to focus on in this part. So let's say you keep track of some kind of events, and you'd like to know how long ago the previous one happened. Like, for example, you keep track of all the logins to the application. And one more thing that you would like to know is, like, for each row, you want to know how much time passed since the very first event. For example, the account creation. To solve those kind of problems, we're going to use window functions. So here's an example of a simple window function. Here's a row number which assigns a sequential integer to each row. And what happens here is that we are specifying how it should behave inside of the over part. And we have the partition by age. It splits the data into blocks by age. It's kind of like a group by. And then we also have order by name, but it orders within the particular partition, not the whole data. So for the first block, we have one row with age 18. Then in the second one, we have a few more rows with age 19, and so on. Now, since I mentioned that partition behaves similar to group by, then what's like the difference? Why would you use one or the other? So with group by aggregations, you're going to have one row per each aggregation. While with window functions, you can have still one result row per one input row, which means that you can work with both aggregated and non-aggregated data at the same time. Now going back to the questions that I started with, I have a table events with just the name and a timestamp. I filled it with some data. And now here's the query that solves the examples. I'm querying the timestamp, like when the event happened, and then I'm using window function lag, which is comparing the current row with the previous row. Like the second argument is 1 because I want like one row before. I'm calling it delta, and then I also use another window function called first value, which will give me the thing that I wanted, the second example, like how much time passed since the very first event. So if I run it, I hope you can see it. Then I have like all the information I wanted, the delta and the total time that passed. Okay, so let's go to the last part of my presentation. We're gonna talk about some spreadsheets and SQL. So, as before, I'm gonna define an example that I'm gonna work with. So let's say that we have like a table with bank operations, and we would like to know a balance after each operation. But we also have this condition that it can never go below 0. So basically, for each row, we want a maximum of 0 and running total. Running total is the cumulative sum of the value and all the previous values in the column. So this is what we call balance here. So how do we do this? Can we use recursive common table expressions that we were already talking about? I don't think so. I haven't tried that, but I think it's not possible. Can we use window functions that we already saw? That's probably possible, and we could do this. But why would we do this if we can instead use some obscure, overcomplicated, and vendor-specific SQL? That's what we're going to do here. So you might have noticed that all of those questions would be fairly easy with Excel. Like, you know, you would have a formula in one cell, then you would drag it and apply it to all the other cells. Like, that would be a few minutes of work. So what if I told you that we can have Excel in the database? Specifically, we can have it with Oracle model clause. So this is only in Oracle, but it's kind of interesting, and I wanted to mention that in this talk. So how it looks like. You have the query, and then below you declare the model part. When you specify 3 things, like the dimensions by, so you're going to specify like the spreadsheet dimensions. And in Excel, you only have 2. But with model clause, you can have multiple dimensions. Then there's measures part. This is like the spreadsheet cell type. We're going to specify what we want to use in the spreadsheet. And then we have rules, which is the formulas. But In Excel, you can only have one formula per cell. Here you can have like a tuple with multiple of them. So let's see an example. For that, I'm gonna use Oracle Playground. I'm gonna make it slightly bigger. So I already filled it with some data. I have this account balance table with the date and an amount. And here's the query. Let's take a look at the model statement. So in the dimensions by, I'm using window function row number to assign an integer to each row. I'm doing that so that there are no gaps between the rows, and this will be my my one dimension of the spreadsheet. And then in measures, I have things that I care about. It's the date, it's the amount, and the total, the balance that we are calculating. And here's the most interesting part, the rule. So what I'm saying here is that for any cell in my spreadsheet, I want the greatest of 0 and the previous value of total plus the current value from the amount column. The CV stands for current value, and it's built in, so we can take advantage of that. So I already ran it. Oh, I didn't. Can I run it? No, my session has expired. I'm not gonna do this right now, but you can trust me that it works. Yeah, trust me. I'm gonna leave a link so you can try it yourself later. So let's go back to my slides. That was the last thing that I wanted to talk about. So let's do a recap of what we were talking about today. So we were talking about common table expressions and recursive common table expressions. We saw an L3 Postgres extension. We did some data analysis with window functions. And we saw how to simulate Excel spreadsheets with Oracle Model Close. If you want to learn more about those things, I included some links on my website. So if you scan this QR code, it will take you to my blog, to the speaking page, and you can find the slides there, and you can also find some links that I found interesting. Thank you a lot. Thank you for having me here. Do you have any questions? Do we have time for questions?
Alex, we don't, but thank you.
Okay.
And I will promote Blitz in your place.
Okay,
if you're working with Next.js and want to work in a full stack way with Next, definitely check out the Blitz toolkit, of which Alexandra is a lead maintainer. And thank you for that. If you have questions, at the upcoming break, which is also known as the after party, that would be a great time to talk to Alexandra. So, all right, we're almost there. You all you still look good. I mean, there's a little bit, but I can tell you're all here. So here's what I wanted to do. I wanted to take us back briefly through the things I was hoping you saw as themes throughout the day. And one of them was simply that there is a community here that's available to you. And through relationship and collaboration, there might be a lot more potential and opportunities for you that you knew about. I hope you saw that a lot of these people are people I consider friends, and they're people that have helped me in my endeavors, and it's just been reciprocity to be able to be here and help them with what they're working on. So I love that, and I hope you saw that. Another one was, and we saw this in many presentations, like the superpowers that, especially for front-end devs, you're getting across the full stack with Prisma. So that was another theme that I hope came out today. And then also, this whole Prisma 1 year ago was production ready, and you saw a lot of examples. You heard me talk a lot about a lot of examples regarding applications that are in production using Prisma and scaling and doing well. Lastly, today, GA for the Prisma Data Platform. And I think that was it. Those are some good things, right? See, now you feel good about being here all day. Whatever, you were in a beer garden all day. Of course you feel good about being here. Anything I missed? Anyone else learn anything? We can't, I know. All right, at the after party we'll talk. So now, final speaker, who barely needs an introduction, Nicholas Burke, Prisma DevRel, and you have the pleasure, my friend, of being the final speaker of this day. So
that's true, and I was actually not sure if that's a good thing or a bad thing, and I kind of saw two scenarios. Either everybody would be drunk or asleep, and it seems like everybody, you look more asleep than drunk. So, well, I don't know, I'll try that the content of my talk is exciting enough to keep you awake at least half an hour longer.
I think they're doing great, and you're going to do great. Nico, thank you, and I'm going to go sit and watch your talk myself.
Wow, what a great day. We've seen so many great speakers today. We've heard about these fantastic success stories of real companies using Prisma in production. We have heard insightful talks about databases, Neon, PlanetScale. We've seen insightful talks about the Prisma ecosystem, TypeScript, GraphQL, Redwood, all of that good stuff. And I think all of that is worth another round of applause to wake you all up for the last talk. So my talk today is about the future, but not just any future, the future of Prisma. And I think that's the reason why we're all here today. And really, it should say the foreseeable future, because I'm going to talk to you about the features that we're planning to work on in the next 3 to 6 months. But a glimpse into the foreseeable future of Prisma doesn't sound that exciting as a talk title, so I decided to leave that part out. All right, I think you're wondering, okay, who is this clown that's keeping me from the burgers and the after party? My name is Nicholas Burke. I lead the developer advocacy team over here at Prisma, and you can find me on Twitter and on GitHub as @NicholasBurke. So here you see a rough timeline view of the features that we have planned for the next 3 to 6 months. And you don't have to memorize all of this. I'm going to use that slide to guide through the talk, because I'm going to pick out 4 of these features and talk about them in a little bit more detail. And at this point, I also want to put up a huge disclaimer already, because while what I'm going to show you today is, will represent where we would like things to go in the future, our engineering process and our product roadmaps are both subjects to change. So be aware that the things that you're seeing today might not happen in the exact shape and form that I'm going to present them. So this has no guarantee, no warranty, and no return. I don't want to get any angry emails in 3 months because the features haven't happened in exactly that same way. All right, before we start talking about the individual features, I actually want to give you a high-level overview of our priorities for this year. And the first one that I want to talk about, there are 3 of them. The first one is that we want to improve the existing database connectors that we already have. In fact, we've been approached by a lot of people, developers, even database vendors, over the last couple of months that have been asking us, when do you build the next connector for Redis, for DynamoDB, for Snowflake? And the answer to all of them has been, well, unfortunately, we are not really planning to build any new connectors at this point. Building a new connector has proven to be a gigantic amount of work. That has just been recently proven by the work that we've put into MongoDB and into the CockroachDB connectors. So instead of building out new connectors, we really want to make sure that developers first can get the most out of the existing connectors that we already support. Then we also want to make Prisma more flexible. We want it to be better integrated into the developer ecosystem so that you can use it with whatever stack you're already using today. So if you're building a GraphQL API, if you're using Nest.js on the back end, or if you're building apps with Next or Remix on the front end, Prisma really should be smoothly integrated with all of them, and that's another core theme that we are focusing on for this year. And finally, we want to enable teams to collaborate better with the Prisma data platform that we've just seen launch in production this morning. And I think this is another really exciting priority that we have set out to for the remainder of this year. All right, are you ready for the features? Yeah, I think so, okay. The first feature that I want to talk about is metrics. And in fact, metrics is already available. So we just released it in the 3.15 release last week. And it's running in preview, and we are now working towards the general availability release. But you can already use it today. So what are metrics? Metrics really help with the observability and the monitoring of your application. And the metrics that we expose, they give you insights into what is happening inside of the Prisma query engine, which otherwise really is a black box for the developer, right? You have no idea what's actually happening inside there, and that's what we're tackling with metrics. We want to give you the ability to show what exactly is in there, and on the next slide, you'll actually see what exactly is in there. It's also based on the OpenTelemetry standard. So instead of inventing a new standard, we just thought, OK, there is OpenTelemetry. Most of the tools are already compatible with it. So we decided to also follow that standard for our metrics implementation. And then what you can do with it, for example, is you can send these metrics into a time series database like Prometheus. From there, you can pump it into a data visualization tool like Grafana. And you have a really nice overview of what's actually happening under the hood when you're running your application. So here is a quick overview of the metrics that are available in Prisma Client already today. So they are broadly categorized in 3 different buckets. The first one is counters, the second one is histograms, and the third one is gauges. And thanks to Alex, who saved me from the embarrassment to not pronounce this gorgeous. The first one is counters, and here are the counters that are exposed by Prisma Client. So you will get access to the total number of queries that are being executed by your Prisma Client instance and the total number of operations that are executed by your Prisma Client instance. What's the difference between operations and queries? Operations is what you're used to when you're working with Prisma Client, these top-level model functions that you are calling when you want to read and write data in the database. So find many, create, update, delete, these are the operations. But then one operation can map to multiple database queries under the hood. And so we expose both of this, the number of queries and the number of operations that have been executed. Second category, histograms. And here we provide you with a wait time for a worker to get a connection. So basically an operation that you have executed with Prisma Client, maybe a find many call. There weren't enough free database connections in the connection pool. So this is the wait time for a worker to get a connection. The execution time for all queries executed and the execution time for all operations as well. And finally, there are gauges. And we have 4 of these: the number of active database connections in use, the number of active transactions, the number of unused connections, and the number of workers waiting for a connection. So these are the metrics that we are exposing in Prisma Client. And I can see it in your faces that you're now really curious to see how you can get access to these metrics. So here is how you do it. You just call this new, or you access this new top-level metrics field on your Prisma Client instance, and then depending on how or in which format you want to retrieve these metrics, you either use this function to retrieve it in generic JSON, or if you're using Prometheus, and that's the nice thing about this new feature is that it comes directly with the Prometheus integration, you just switch that out to Prometheus. What does that look like now in a typical 3-tier architecture that I think most of you will be familiar with? So we have the client, the API server, and the database. Maybe on the API server, you're running Express. And now the way how you can make use of metrics is that, for example, you set up your time series database like Prometheus, and you add an endpoint that's called metrics to your API server, and then you point your Prometheus instance to that metrics endpoint. You define an interval at which this metrics endpoint should be polled, and then Prometheus is just grabbing the data at this defined interval. And from there, you can continue to send the data into Grafana, where you can then visualize it. Let's take a quick look at what this code actually looks like, because it's actually only a couple of lines. So here would be the example with Express. We define this new metrics endpoint, and then we call the Prometheus function that I just showed you before, and then we send that along with the response object for people to access in Prometheus. And yeah, this is really great. Just in a few lines of code, you can configure yourself an industry standard for monitoring your application. And I think that's worth another applause. If you're now curious about that workflow and what it actually looks like, I can't show you that today. But last week, my colleagues Alex and Tassin were running the What's New in Prisma episode that we are hosting every 3 weeks in our release week to explain what has been released. And they gave a really great demo of exactly that workflow with Prometheus and Grafana. So I encourage you, if you want to learn more, go to the Prisma YouTube channel and check out last week's What's New in Prisma episode for release 3.15. All right, that was metrics. Let's move on to the next feature, and that's query analytics. It's actually building on top of the metrics feature, and it's a new feature that we're planning for the Prisma data platform. It's actually already close on the horizon, so it's one of the features that we are currently kind of speccing out and that we really want to work on next, now that the PDP has been launched for production. And instead of me actually talking through that new query analytics feature in the PDP, I asked my colleague Spiros, who is the product manager of the developer productivity team that's building the data platform, to help me out with this. And here he is. And Spiros, maybe you could give us an overview of what that query analytics feature actually is and how it works.
Hi, Nico. Sure, I can walk you through the feature. So query analytics is a feature that aims to help you understand what's happening with your production application queries. And we measure the time that it takes from inside the data proxy. As soon as your query goes inside our data proxy, the time it takes in the database, and then all the way back out until the data proxy layer. So what you have in this table, this overview, is a couple of queries, in which you can see some information about the model and the type of query that is run. Sometimes you might have the same queries in different parts of your application, so you can use the query name feature in order to separate them. And we also show some response times. You can see the average, you can see some percentiles, so you can figure out if there is everything is slow, if there is a spike, and you can also see some sort of a graphical representation of that history.
That's great. Thank you so much, Spiros. And so we now have an overview of all the queries that we are running in our application with Prisma Client. Is it also possible to drill into one of these queries and learn more about each individual query?
Yeah, so you'll be able to click through in one of these queries. So let's go to the top one. And here we see how the response time has varied across the last month. We also see this in combination with the throughput. So we might see some sort of a normal weekend dips in the traffic and also the load, but we also see how it performs during the weekdays. So let's say, for example, that we want to see why this is taking about 400 milliseconds. If I click through a time period, I will be able to see all the queries that run in that specific time. And if I click through in one specific query, I will be able to drill down into this specific view of this one query that ran at that point of time. So here what we can see is that we have a breakdown of how long it took at different layers of the stack, the query, and we might see that probably the database part was the one that took the longest. So this is where you can get some insights of how a specific query performed in the past.
All right, so I can see the individual queries as well, but this last query, Spiros, it took, or it seemed to take a lot of time on the database layer. So does the new query analytics feature also help me in any way to optimize this now?
Yes, I'm happy you're asking that. So if you go down here, you will see that this is the query that is actually being run from your application code. And this is an editable interface, just like the current query console feature that we have. So here you will probably see that the payload you're receiving, maybe it's 1,000 or 2,000 artists. You don't want to get that in your application. Maybe this is some sort of a list or the homepage where you might want to paginate things. So you change the code, you try it out, and you actually get to see that the new paginated query is a lot faster than the one that ran in the past. So what you can do now is that you have the insight, you have the new query, you make the change, you update it in your code base, and then you can go back and observe how things are going for the next couple of days.
That's great. Thank you so much, Spiros. Spiros from Greece. So to recap, with that new query analytics feature, we are going to give you an overview of all the Prisma client queries in your application. You'll be able to drill down into the individual queries, and finally, you'll be able to optimize these queries on the fly in the built-in query console that's just coming with that feature. All right, moving on to the next feature, and I think that's one that a lot of you have been excited about just based on the number of thumbs up that it has gotten in our GitHub issues, and that's multi-schema querying for Postgres and SQL Server. It's also coming fairly soon. I think at the moment we are not yet at the implementation stage, but rather at the discovery and at the design stage. So actually, I'm not going to present to you a final API design for that today, but rather I'm going to show you two competing designs. And before I do that, actually, I want to take a step back for those of you who might not be fully familiar with the technical underpinnings of this. So who of you actually is familiar with the concept of schemas in Postgres? All right, not everybody, so I'm going to explain it. I would have explained it anyway, but here we go. Schemas in Postgres, what are they? Well, if you've used Postgres before, you probably know that you start out with your single Postgres server instance. And on that Postgres server instance, you can then run SQL commands, for example, create database to create a new database where you can then store data. But unlike other databases, like MySQL, for example, where you would now immediately start to create tables inside of a database, there is this intermediate layer in Postgres and also in SQL Server called schemas. And you can create a new schema with a create schema command, and then only inside of a schema you can actually create tables. And you can think of schemas in a way like namespaces. You can even create foreign keys across different schemas, and it's really just this intermediate layer to structure the data inside of your application. And if you have worked with Postgres before, but you're not really aware of this concept of a schema, it's probably because you've been using the default schema all the time, which is just called public. So it's actually a pretty nice experience. You don't have to worry about schemas in Postgres if you don't actually need them. But if you do need them, you can use them to have a better structure of your tables. And if we compare that with MySQL now, here we see that we just run the create database command to create a new database, and then immediately inside of a new database, we go ahead and create new tables. So how can you now work with multiple schemas in Prisma? Well, today, this is already possible in a way. It's just not natively supported. And what do we do when something is not natively supported in Prisma? We use the escape hatch and drop down to raw SQL again. So you could already theoretically start and use the query raw command that's exposed by Prisma client and put in some SQL there that is then, for example, joining data from two tables across two different schemas. And that would look like this. But of course, we're not using Prisma because we want to use raw SQL, so this is rather inconvenient. We don't get any type safety out of the box. So we want to make this easier for you and build multi-schema support for Prisma itself. And I already told you that we currently have two competing designs that we are thinking about. And these look as follows. So if you were to design schemas in Prisma, we have two approaches. And the first one is what we call the flat approach. In the flat approach, you just write your Prisma models as you're already used to, and then to specify in which schema this model should live, you add this new model level attribute at schema, where you specify the name of that schema. So pretty straightforward. The second approach that we are thinking about is the one that we call the nested approach. And there we introduce a new top-level keyword in the Prisma schema that's called schema. And then under this schema keyword, you actually then nest your individual models to make sure that Prisma knows which model lives in which schema. So these are the two approaches that we have there. If you then want to go and define relations across these schemas, in the flat approach, really nothing would change in terms of the syntax that you use to define relations. In the nested approach, on the other hand, you would probably now prefix the name of the model with the name of the schema. If you want to query these schemas in Prisma, then the flat approach would also, again, not change, just prisma.user.findMany as we're used to. In the nested approach, you would probably insert the schema name in the path here with dot notation. So now it would be prisma.schema1.user if the user model lives actually in the schema called schema1. If you want to query across relations here, then it would also be the familiar API just with include, no prefixes here, and in the nested version, again, we just include this additional schema path in our Prisma client query. All right, that was everything about schemas, and the last one is actually a really exciting feature that I'm very much looking forward to because it's going to enable so much in Prisma that hasn't been possible before. And it's called Prisma Client Extensions. That's how we are calling it internally. And I want to motivate it by starting to talk about a couple of missing use cases in Prisma today. So who of you here has used Prisma and wanted to use a computed field before? Computed fields, yeah, not really possible in Prisma at the moment. There are some workarounds. In fact, I'm going to show some later, but not possible. How about you have a big, big model, and this model has some sensitive fields, maybe a password field, but the model itself has 100 fields. And you want to fetch all of these fields except for the password field. What do you have to do in Prisma today? You have to list out 99 fields, and then you can exclude this one field that you don't want to have. Well, this new feature, the Prisma client extensions, are going to enable this as well, to just exclude fields by default. Then model methods. Model methods are another really interesting concept that at the moment on a model level, when you're using Prisma client, Prisma.user, Prisma.post, you're all familiar with that. What you can access then, you can only access these predefined model queries that Prisma provides you with. So again, find many, create, update, delete, we all know these. But what if you want to define any custom model queries for validation? If you want to check if a user has a valid age, and then you just implement a one-liner with age greater than 0. Something like this is not possible today in Prisma, but also will be enabled by this new feature, as well as new top-level methods. Top-level methods in Prisma Client are all the ones that are prefixed with a $. So $use, $transaction, and they're also, you can't really build any of these into your Prisma Client instance today, and that's another thing that's going to be enabled with Prisma Client extensions. So what if I told you that all of these missing use cases and more can be enabled with this single new feature that currently we just call Prisma Client Extensions, and the API is going to be a new top-level $extends. You can think about this new feature in the same way that middleware actually works in Prisma today. So it's kind of similar, but it's declarative and static. And that also means that we're leveraging TypeScript's type system. I think, Josh, you're yawning, but you should get excited right now. So it's completely type-safe. It's very flexible. It'll enable a lot of use cases. And the thing that I'm personally the most excited about, that it's going to be a new extension mechanism for Prisma itself. So today, we actually have 2 extension mechanisms already in Prisma, and these are generators and middleware. What do I mean with extension mechanism? Well, it's a way how developers can actually build their own NPM packages, upload them to NPM, and make the functionality available to other developers that are then using it. And that really contributes to the richness of the Prisma ecosystem. And these Prisma client extensions, they are going to be another extension point for Prisma, where people can just come and build their own functionality that other people can use. Let's understand quickly how this new extends feature is going to work. And I want to show this by the example of computed fields. For those of you who are not aware, computed fields are fields that are computed at runtime on a model. So they don't really exist in the database, but you can use them inside of your application. And here we want to compute a new field on a user model that already has first name and last name. And we want to have this full name computed, but we don't want to store it in the database. So we just want to concatenate the first name and the last name. How do we do this? At the moment, we have at least 2 workarounds. The first one I call compute in function, or compute function. The way how we do this, and this is now pretty small, I hope that you can read it. People online won't care. I think people on the other screens, they don't mind. I'll just talk through it. So we first start to define a new type because we want this to be type safe. So we define a new type that's called user with full name that takes the existing user type that was generated by Prisma. We attach this new string field to it that's called full name. And then we build a function that's called compute full name. It takes a user object as an input. It returns a user with full name object as an output, and then in there, we literally just take this user object that was coming in, we attach the full name to it with our small computation, and here we go, we have a computed field. The pros of this approach are that it's type safe, and it's even extensible via TypeScript generics. So if we wanted to add the computed field to more than just a single model, that would be possible with this approach, which is pretty neat. The cons are that well, it's really not a computed field. So I'm not even sure why I named this as a workaround here. And it's also pretty hard to maintain if you have to define the type and the function for every computed field that you want to use in your application. So let's take a look at the second approach, and that's with middleware. And with middleware, you use the top-level $use function, and inside there, you can check, is this current query now for a user? If that's the case, you can just execute that, and you kind of know that you get a user back, even though this could also be a user array, so this code is also buggy. But assume this is just a user object. We just do the same. We return a user. We attach the full name to it, and whoever has been calling a Prisma client query on the user model now will get an object back with that full name field attached to it. And that's great, I guess, because it does feel more like a computed field on the receiving end of this. But the problem is that it's not type safe. So if you're using TypeScript and you're using this approach, you actually can't make your code compile if you want to access this full name field, because according to the TypeScript compiler, it doesn't even exist. And again, it's also pretty hard to maintain if we just have to write middleware functions for all of this. So here is how it would look like with extends. Extends is a top-level function that you're calling on your Prisma client instance, and it takes in the previous Prisma client instance. So it's actually composable. You can do it a number of times, and it always takes in the previously extended Prisma client version. So prev, in this code snippet, you can imagine to be just another Prisma client instance. And what we then want to do, we want to override the find first method for user, where we want to now add the computed field. This, again, is just an idea for the API. This API is not set in stone, but that's what it could look like. We are calling the actual find first function, and then similar to before, we just add the computed field in the returned object to this. And this is great because it's actually a computed field. It's fully type safe, it's easy to maintain, and it's extremely flexible. As we've seen, it caters to all of these use cases. The only con I can think of at this point is that it doesn't exist yet, and you all have to be more patient to actually use it. All right, I think that were 4 features, if I've counted correctly. So what I want to leave you with is that you can stay up to date about everything that we're working on by going to our public roadmap on this link. And this public roadmap, it can change. And usually it changes because we're getting new user input from people like you who go to our GitHub repository, create new GitHub issues, feature requests, bugs. And yeah, that's really all I have for you today. Thank you so much. Do we do questions? Do we have questions?
Congratulations on the query analytics, really nice feature. I wanted to ask if it was also going to work with raw queries.
The query analytics feature? I'm just going to say yes. I don't know. I hope Spiros is not going to lynch me afterwards, but let's say it does. You had a question, Alex?
Yeah, I had a question.
Microphone?
I think you'll just answer no on this. Will there be a way to opt out of this sort of select star mechanism that we have right now in Prisma? So
You mean the default fetching of all scalar fields with all the Prisma client queries? I think eventually, but this is not something that we have on the closer horizon, I think. But this is indeed also something that we're thinking about, along with also just like making relations, for example, having different strategies for how to load relations, so that you don't always have to use include. Maybe if you already know that you always want to load a relation, that you can configure these things in the Prisma schema already. Here I would really recommend you, if you have ideas about what this feature should look like, go to our GitHub. Our entire product and engineering teams, they're always monitoring what's going on there. So instead of asking me at Prisma Day, go to GitHub, make sure this is persisted, and then you'll get the proper reactions with proper information.
Yeah, I saw that because it was sort of adjacent with exclude.
All right. Cool. Thank you.
Did we do it? You know what?
I think so.
You were the man for the job. Like ending, that was, yeah, he did all right, didn't he? Yeah, you guys came alive. I like that.
That's so
well,
nice.
It's almost time, and we'll end with this. It was a real pleasure to be with you all today, and really grateful for my friends at Prisma that invited me to come. I want to say thank you to Zoran, Nico, so many on the Prisma team that have worked with us at Redwood to make Redwood better. And I want to especially thank, there you are, Natalia. Natalia put this event, we thanked her earlier today, but now we really owe her a round of applause. Natalia and her team put together what we can now say was absolutely a wonderful event in a wonderful venue. And I think that's it. We just have one last thing to do. Are you all ready? It's group photo time. Group photo time, everybody. The American wants everybody on stage so we can get a picture of this moment, all right? So come on up. I'm going to be right here, and then I'll move over when Soren comes up. Let's do this. Yep, do it. You've had just enough alcohol that this is okay. All right. You won't feel awkward. It'll be fine. Come on up. You're doing a great job. I see some people in the back moving way too slowly or not moving at all. I see you. I see you. Come on up. All right, microphone off.